and we have total 6 speakers from Cochin University, and the different titles are HSC Study, HSC Design, Construction, HSC Management, Turnaround. So the program will start from 10 and it will run till 5 o'clock from Kuwait time. And from those who are from India, it is starting from 12:30 till 7:30 in evening. And we will be having HSC quiz via Kahoot. So there will be some prizes associated with this. Those people who cannot be able to see it live right now, they can also visit our SSP YouTube live page, and there will be a subject matter expert panel discussion on topic of our mutual interest. So we are very delighted to welcome you, and this is the first event from Cochin University of Science and Technology, and we are really grateful that they have accepted our invitation with help of our outreach committee, student committee, and our SSP chapter staff has worked it around from 1 week long preparation, and then we are embarking a new startup, a new networking, a new plan. So this was a startup of this, and we are on Zoom platform. There is a possibility that your connection will be lost. So don't worry on this. You can rejoin us. In between, you can have a break. Be respectable for other people's idea. We are here to share knowledge, enhance competency, networking. So be respectable for other people's idea. If your mic is not muted, kindly keep it muted unless you are being asked for. Now I will invite our Vice President, Mr. Mazharuddin Sheikh, for welcome address, along with the Professor Dr. George Matthew, Principal, School of Engineering, Cochin University of Science and Technology. So welcome Mr. Mazharuddin Sheikh, Vice President, for his welcome address.
Thank you so much, Safdar bhai. Thanks for this. Okay, so very good morning and good afternoon to our Indian fellow professionals. Thanks for joining today in this one-day technical webinar and panel discussion. I am also thankful to see that many participants are joining right now with us for this full day webinar. And first of all, I would like to thank for the person who has started this idea, because without thanking him, I don't want to start this webinar today. That is Mr. Najas. Really appreciate your efforts, and today we are here, mashallah, and this is now, you know, full day program we are going to have today because of you and your team's efforts. Thank you so much for that. Also, all the professional friends and professors, staff of Division of Safety and Fire Engineering from CUSAT, thanks for accepting our request and coming together today to improve our mental horizon in the field of safety with your expertise and with your knowledge in this area. So thank you so much for sparing this time. I know the preparation, how much it takes time, and thanks for everything what you did till date, joining us for the preparation and today for the presentation. Thank you so much for all your efforts. I would like to welcome all of you on behalf of ASSP Kuwait chapter, and also I would like to welcome all the participants. As you all are aware, this is our first full day webinar for this year, that is 2021 and 22. And this is something different because we have so many experts from different part of the world, Kuwait, India, UAE, who are going to throw light on a specific subject, especially design and construction and process safety. So I would like to welcome all of you once again. And it's my pleasure to walk you through the conference. If Ramana, could you please go through the agenda?
Dear Majher, please invite to Professor Dr. George Matthew.
Okay. So, sorry, Safdar bhai. I thought I would invite him after the agenda discussion. So here I would like to invite Dr. George Matthew for a few words. Thank you so much, sir, for being with us and for all the preparations you and your team has made for today. Thank you. Thank you so much. The screen is yours, Dr. George.
Thank you. Hopefully, I am audible clearly. Am I audible?
Yes, sir,
Very
you
loud
are.
and clear.
Okay.
Yes, sir.
Thank you. So, respected dignitaries, speakers, organizers, participants, ladies and gentlemen, a very warm good afternoon as well as good morning to one and all. So, at the outset, let me appreciate the organizers in selecting a very relevant topic for the today's technical webinar, namely safety challenges in oil and gas industry, jointly organized by ASSP Kuwait chapter and the Division of Safety and Fire Engineering, School of Engineering, CUSAT, India. At this juncture, I am happy to mention that the Safety and Fire Engineering Division is offering 4-year BTech degree program in Safety and Fire Engineering, MTech program in industrial safety, and PhD program in different domains of safety and fire engineering field. In fact, we have started the BTech program in safety and fire engineering first time in India way back in 1996. Our BTech program has been accredited under Tier 1 category by the National Board of Accreditation as per the Washington Accord. As we are aware, the Washington Accord is an international accreditation agreement for undergraduate professional engineering academic degrees between the bodies responsible for accreditation in its signatory countries and region. And this is very much benefited for many of the undergraduate students to get employment in various countries, signatory countries, in fact. With this introduction about our institute, let me welcome the core committee members of the ASSP Kuwait chapter, Mr. Fadal Al Ali, the chairman, Mr. Jahid Thakur, president, Mr. Mazharuddin Shaikh, the vice president, Mr. Safdar Ali Khan, secretary, and Mr. Badar Ali Hadrami, treasurer. I wholeheartedly welcome you all to this one-day webinar. I extend a warm welcome to the various committee heads of the ASSP Kuwait chapter to this function. I welcome Dr. V.R. Renjith, head of the Division of Safety and Fire Engineering, CUSAT, who has been instrumental in having this jointly organized event to this program. I understand that 6 of the speakers for the today's webinar are our alumnus. I wholeheartedly welcome them as well as all other speakers to this webinar. I welcome all the participants, students, and all other attendees to this webinar. I wish that this program will enrich the knowledge base of the participants and will open out new areas of learning as well as the new association and interaction between Cochin University of Science and Technology and ASSP Kuwait in the days to come. Thank you very much.
Thank you so much, sir, for this welcome note. And on behalf of ASSP, we also welcome you. And inshallah, in future, we will have a long relationship for the professional development of our people who are working in different part of the world and associated with the ASSP Kuwait as well as different ASSP in the Middle East area. So thank you so much, and thanks for giving the information regarding this courses you are going to introduce. I'm sure we have many people who are eager to join such courses and such degree, especially masters and PhDs. So I'm sure, inshallah, you will support us to get this benefit from your esteemed university. Thank you so much, and welcome to your good self also. Thank you. Mr. Safdar.
Yes, sir. Thank you, Dr. George, and thank you, Vice President, Mr. Mazharuddin Sheikh. Now, coming back to the program agenda today, please take a note of this. We will be having first technical session from 10:30 to 11:15. And I will be moderator, Mr. Safdar Ali Khan from American Society, and the speaker will be Professor V.R. Renjith, who is head Department of Safety and Fire Engineering, CUSAT, and his topic will be FMEA study in LNG industry. And then there will be another session by 11:15 to 11:30, which I will be sharing you what we are doing as ASSP chapter activity. And there will be another session, technical session, on topic challenges in project life cycle from concept stage to operation from 11:30 to 12:15, and moderator will be Mr. Mazharuddin or Sheikh, Vice President from American Society, and his speaker will be Mr. Rahul Patteri, leader fire protection and process safety, ENOC UAE. And then 12:15 to 1 o'clock from Kuwait time, there will be a break. Please, in their counterpart, accordingly, we have shared a separate timing for breaks. So this is before break, and after that, technical session 3 will be, moderator will be Mr. Najas T, member of Membership Development Committee. His speaker will be Mr. Dilip Madhavan, manager, Petronet LNG India, and his topic will be safety performance indicator based on OSHA. Then from 1:30 to 1:45, there will be a presentation on benefits of ASSP student membership by Mr. Yunus Kanat, Membership Development Committee. And from 1:45 to 2:30, there will be technical session number 4. It will be moderator Mr. Samiullah Pathan Khan, head of the student committee, and his speaker will be Mr. Anis Jairam, fire officer ONGC B&S Offshore India, and his topic is challenges in offshore exploration and production platform. And then we will be having technical session 5, moderator Venkat Ramana. The speaker will be Mr. Najas Takakate Abdul Karim, lead HSC Larsen and Toubro, and his topic will be challenges in underground services. Okay, his topic is challenges in challenges in construction of cross-terrain oil and gas underground pipelines. And there will be another session, technical session 6. Moderator will be Narendra Patel. Speaker will be Mr. Siju S. Surendran, HSC Manager, ISCCO UAE, and the topic is turnaround safety challenges. And around 6:15 to 6:30, there will be HSC quiz on Kahoot. And after that, 6:30 till 7:30, there will be a panel discussion on challenges in oil and gas. So moderator will be Mr. Sunil Sadanan, Advisory Committee member of American Society, Professor G. Madhu, Head of Department of Chemical Engineering, CUSAT, and we have different subject matter from construction, design, operation, exploration, and offshore. Few names are Raj Sekharan, MP Prabis, Arshad Ayub, And once I get more input on this, I will add the name and I will announce more on this. At this juncture, then by 7:30, announcement of quiz winner, and by 7:35, closing ceremony and vote of thanks. Each technical session will conclude with question and answer session. On the onset, I will share you a link that is called BCSV, Board of Certified Safety Professional. There is a global summit. I will be sharing you the link and more info on this, and I will share the link. There will be a $25 US dollar fee are there, which will be equivalent to 1,000 Indian rupees. So I will be sending you the affiliate link. You can use this promo code, and it will be having a media kit, and it will be having a platform of global learning, and you can have a great networking and continuous development programs are there. So I will be sharing you that link. This. Now, I will invite for today technical session to Mr. V.R. Renjith, who is professor and head of Division of Safety and Fire Engineering, School of Engineering, Kochi University of Science and Technology. We are really blessed that this gentleman of having high scholastic achievement along with his research work. Mr. V.R. Renjith has received his PhD in industrial safety from CUSAT in year 2011. His master degree in industrial safety from NIT Trichy with first rank and gold medal. He has over 23 years of teaching experience in the field of safety and fire engineering. In addition to teaching, he has published more than 65 papers in international journals and conference, and prepared 20 consultancy project report for different industry. He's guest editor and reviver of reputed journals published by Elsevier, Journal of Loss Prevention in Process Industry, Applied Soft Computing Engineering, soft computing article in selected as a most cited article by Journal of Loss Prevention and Process Industry. A dozen students are working under him for their PhD. His profile is so extensive that I take really a pleasure in talking this. And we are blessed that this gentleman is giving this session, and we will definitely try to get most out of it with the shortest span of time. I know we will be having a long relation with you, sir. He has guided more than 36 of master's thesis in the field of safety risk analysis. His major research in interest to improve the capability of tool used in safety and risk analysis by incorporating artificial intelligence and soft computing technique. He has developed 2 massive open online courses for CUSAT in field of safety. He has visited more than 200 industries in India and abroad. He has visited several countries, which includes USA, Singapore, Malaysia, UAE, and Sultanate of Oman. He is member of Board of Study in Safety and Fire Engineering and Chemical Engineering, and member of Faculty of Engineering in CUSAT. He is member of Executive Committee of National Safety Council, Kerala. So it is a request from everyone, if you have a question during the session itself, and we are having 101 participants right now on the board, and soon it will be increasing more in number. So if you have a question related to the presentation, you can post it on chat box, and whenever time permits, we will take you the question on board. So this was a brief introduction for the technical session 1 for failure mode effect analysis study in LNG terminal by Dr. VR Renjith. There is a request for every speaker and moderator, please stick to the time limit. Though we are on virtual platform, we understand if there is a technical glitches, we will adjust it. So please be on time and please try to wrap within the time. A personal request with this. So now floor with Dr. VR Renjith, and good luck to the all learners and the University of CUSAT on ASSP volunteers. Over to you, Dr. VR Renjith. Please unmute your mic, sir. Please unmute. Ramana, please help him to unmute. Yes, sir, you are. Okay, yes. Now? Okay. Okay, sir. Okay.
Am I audible now?
Yes, sir. Raise your volume a little bit.
I see some issues. I'll try my best. Okay. So thank you, Mr. Safdar, for the very exhaustive introduction. So warm good morning and good afternoon to all of you.
Sir, raise your volume a little bit more. I feel some may not be able to hear you clearly, or be closer to the microphone.
Sir, sorry, sir. Earlier you didn't use mic, no? Directly you were speaking, it was very loud and clear. You try in that way.
Now, yeah, I'll try. Now it's okay? Hello?
Yeah, it's better than that. Try, sir,
okay,
try again.
Okay. So, yeah, only problem is I cannot hear you properly. That's the only issue. Anyway, I will continue.
It's loud and clear, sir.
Hello?
Yeah, it's
okay,
loud
sir,
and clear.
Please go ahead. Yes, sir.
So, respected core committee members, respected principal School of Engineering, then the organizers, the speakers, dear participants, and my dear students. Once again, a warm good morning and good afternoon to all of you. So, first of all, I would like to thank each one of you for joining this webinar and a hearty welcome to you all. So, I feel proud to be a part of this webinar organized by the ASSP Kuwait chapter in association with the Division of Safety and Fire Engineering, Cochin University of Science and Technology. So I take this opportunity to thank the core committee for this collaboration. And I wish to place on records my sincere thanks to the organizing committee members for their marvelous job during the past couple of weeks. Then 2021 is a memorable year for us. So that is a silver jubilee admission year of our BTech Safety and Fire Engineering program. So we have planned a lot of events associated with this year, but unfortunately due to this pandemic, we could not organize. But it is the right time ASSP Kuwait chapter approached us, and then we are organizing this program. At least we are happy we could organize this program during this silver jubilee admission year of our BTech program. So I am very happy that ASSP Kuwait chapter approached us for this program. I hope there will be long-term association with the CUSAT Safety and Fire Engineering Division in future also. So once again, I thank all the core committee members for this collaboration, and once again, I welcome all the participants to this one-day webinar. So with these words, let me move on to my topic and presentation. So my presentation is FMEA studies in LNG terminals. FMEA stands for failure mode effect and effect analysis. I will be discussing on failure mode effect and criticality analysis also. So before moving on to the topic, I just take a couple of minutes for explaining about our department. So this is our Department Safety and Fire Engineering Division, or the Department of School of Engineering under Cochin University of Science and Technology. So as our principal mentioned, we are offering BTech program in Safety and Fire Engineering, MTech program in Industrial Safety Engineering, and we offer PhD program in all the areas of safety and fire engineering. The speciality of our department, so our BTech programs are accredited from 2016-17 onwards, And we are going for accreditation of our PG program. I hope within 1 or 2 months we will get that accreditation also. So these are all the highlights of our department. For the past 5 years, we have produced 9 PhDs, and we got the research projects worth 32 lakhs Indian rupees, and we got a number of consultancy projects from different industry. So the industry will approach us with their small problems. We will try to solve them, and we will charge a nominal fee from that. And through that way, we have generated around 20 lakhs, 27 lakhs Indian rupees. So we could publish around 75 papers during the last 5 years. And these are some of the recruiters, those who are coming to our campus for recruiting our students. Majority of all oil companies in India are visiting our campus, and we are getting 100% placement every year for our BTech program. So we regularly organize conferences and workshops, and in 2017 we have organized an international conference. So that in that conference around 10 countries represented, and 250 participants were from all over the world. And in 2019 we have organized a national conference. Then we regularly organize programs and workshops in the areas of asset integrity, reliability, and PSM, inherently safer design, then MATLAB toolbox, then recent ones in industrial safety engineering, safety requirements for engineering institutions, and art and science of technical paper writing. So we are in constant touch with the famous Professor Faisal Khan. So now he is now associated with Memorial University of Canada and MKOPSC Center of Texas A&M University. He regularly visits our campus and deliver lecture for our students, and he will be majority of the time invited speaker for our major conferences. So we will organize a lot of training program in different fields like CPR training, first aid training, firefighting training, like that. And these are all some of the dignitaries who have visited our campus and delivered expert talk to our students. So with this brief introduction about our department, I am moving on to my agenda. So today I will be discussing a brief introduction about hazard identification tools. Then I will be giving a detailed idea about what is FMEA, what is FMECA, and there may be 3 case studies I will be discussing. The first case study is related to FMECA application on anti-lock braking system. Then 2 more case study. One is related to the LNG unloading facility and the LNG storage facility. So first of all, we need to define what is hazard. A hazard is a source or a situation with a potential to cause harm in terms of human injury or ill health, damage to property, or damage to the environment, or a combination of all those things. So there are so many techniques used for hazard identification. So these techniques can be broadly classified into 3 categories. One is the qualitative technique, second is the quantitative technique, and third one is the semi-quantitative technique. So under the qualitative technique, checklist analysis are there, what if analysis are there, fire and explosion and toxicity index, also known as Dove index, then hazard and operability analysis, then failure mode effect analysis, then these are all qualitative techniques. Under quantitative techniques, fault tree analysis, event tree analysis, water analysis, failure mode effect and criticality analysis, and layer of protection analysis. So I'll just give a brief idea about what these techniques are. Fire and explosion and toxicity index, also known as Dove index, because Dow chemical company of US has developed this thing. Suppose I want to identify the subunit, most hazardous subunit in an industry. So those who are having experience, they can easily say, so that particular subunit is the most hazardous in a particular plant. But there may be sometimes some conflict. But scientifically, we can identify which subunit is most hazardous in your industry by using this technique. So this is a scientific way of identifying the subunit, most hazardous subunits from an industry. Then HAZOP study, hazard and operability study, which is a popular hazard identification tool. So a lot of guide words are used. By using guide words, we can find out the deviation and its causes and consequence, and we can identify the safeguards also. We can suggest additional recommendations in the form of safeguards also. So I'm not going into the details of this HAZOP study. So the next technique is fault tree analysis. So once if you are able to identify the hazards from HACCP study or any other study, so we may take that hazards as the top event, and from that we may be able to identify the basic events or the root causes which are responsible for these top events. And then if you know the failure probability values of these basic events, we may be able to identify the top event probability. So that is fault tree analysis. And the next one is event tree analysis. So event tree analysis can be utilized for identifying the different consequences which are arising from initiating causes. So we may be expecting different initiating causes in an industry. So in order to develop it further to a consequence, we have given a lot of safeguards against these initiating events. So depending upon the success and the failure of these safeguards, we may be able to identify the probability of occurrence of these different consequences. So the next technique is bow tie analysis. Bow tie analysis is a combination of fault tree analysis and event tree analysis. The central event is called the critical event. So in the left side of the bow tie analysis is the fault tree analysis, and the right side is the event tree analysis. So you may identify a critical event, and by using the fault tree, you may be able to identify the basic events which are responsible for this top event. So once these top events are there, then it may be leading to different consequences. By using event tree analysis, you may be able to identify the consequences which may arise from this hazardous event or the critical event. And the next technique is the semi-qualitative technique, so which is layer of protection analysis. So by using the HACCP technique, we may be able to identify different causes and consequences. So a cause-consequence pair in LOPA, we will call it as a scenario. So for a scenario, we may be able to estimate the risk associated with estimate the risk. And we can provide different independent protection layers similar to that of safeguards. And we can go for the analysis whether this risk protection is sufficient. And if it is not sufficient, additional risk protection measures in the form of IPS can be provided. So that analysis we can do with the help of layer of protection analysis. Okay, so with that introduction, let me move on to the exact topic, that is FMEA and FMECA. So as I mentioned earlier, FMEA and FMECA are one of the hazard identification techniques. In FMECA, we can use the criticality also. So in FMEA study, so we will consider one system, and from that system, we will identify the different components used in that system, and we will try to identify the different failure modes of that components, and then we will assess how it will affect the system as a whole. So that analysis is called failure mode effect analysis simply. And when you are introducing the criticality element into that FMEA, it is called as FMECA. That means which failure mode will be more critical to the system, that you can identify using a risk priority number by using FMECA. So what I have mentioned, I will just repeat with the help of the slides. FMEA stands for failure mode and effect analysis. FMECA stands for failure mode effect and criticality analysis. And FMEA is an alternate method of hazard identification, which is almost similar to that of HACCP study, which is less formalized than HACCP. It involves the consideration of possible outcome from deviations within the system. So here also causes and consequences are considered. Then it is particularly suited for complex mechanical or electrical system, whereas HACCP study is most suited for process system, and FMEA systematically identifies the consequences of component failure on that system and determine the significance of each failure mode with regards to that system performance. Then the process of FMEA, we need to define the system to be evaluated. You may take a car as the system. So there are different components in that car, like tire is a component, and brake is another component, its engine. So like that, n number of components may be there. So we need to identify the different components in that system, then we need to identify the failure modes of that component. Say, for example, if you are taking a valve, if it is a remote operated valve, sometimes we may give a command to open the valve, but the valve is not opening. So that can be taken as a failure mode. Sometimes we are trying to close the valve, but the valve is not closing. So that can also be taken as the failure mode. So we can consider all the different types of failure mode, and then we will analyze how it will affect our system. So some of the definitions used in failure mode effect analysis. Failure means the termination of an item's ability to perform the required function, and failure mode means the effects by which a failure is observed the failed item. So all technical items are designed to fulfill one or more function, and a failure mode is thus defined as the non-fulfillment of one of these functions. That is very important. Then there are different types of failures, like sudden versus gradual failure, hidden versus evident failures. Then according to the effects, it can be critical, degraded, incipient, and according to the severity, it can be catastrophic, critical, marginal, or negligible. So like that. Then the classification of failure modes. The first one is demanded change of state is not achieved. Fails to open on command or fails to close on command. I have already discussed this one. So now we will take a very small example. So consider a batch reactor. So you can see there are two lines which is coming from ammonia solution storage tank and phosphoric acid storage tank. So one valve in the phosphoric acid line is marked with the red. So and in that reactor, this ammonia solution and phosphoric acid are reacted together at the prescribed conditions, and we will get a product that is DAP, that is diammonium phosphate storage. Diammonium phosphate, and it will be stored. It will be collected in the storage tank and it is stored. So we can do the FMEA, and these are all the conditions for the hazardous situations which may arise from these particular reactor. So if excess phosphoric acid is coming into that reactor, it will result into off-specific product. If excess ammonia is coming into that reactor, then there is a problem of residual release of ammonia. Then if both ammonia and phosphoric acid are coming into the reactor, there is an excess temperature and pressure inside the reactor. So this is the worksheet normally used for FMEA analysis. So for the previous example, just we will consider one particular one particular failure mode. So we have selected one valve which is in the phosphoric acid line. The identification of that valve is valve B on the phosphoric acid line, and the description, it is a motor operated valve and which is used for phosphoric acid service. The failure mode considered here is fail to close. So we may be able to consider the fail to open, the leak, etc. But I am considering only one particular failure mode. And the effect is excess flow of phosphoric acid to the reactor. That is one thing. Then second thing is high temperature and high pressure if ammonia feed rate is also high. Then there may be another effects like high level in the reactor or DAP storage, and there may be another effects like off-specific product. So there may be some safeguards already provided, like flow indicator in the phosphoric acid line. So whenever there is no flow or more flow, that will indicate that by using this flow indicator. Whenever high temperature and high pressures are there in the reactor, there may be relief valve. Then in the case of high level in the reactor or DAP storage, operator observation in the DAP storage is also possible. So these are all the normal safeguards. So in addition to that, we may suggest some alarm or shutdown of the system when high phosphoric acid flow, or alarm or shutdown of the system when high pressure and temperature in the reactor, then alarm or shutdown for high level in the DAP storage. So this is the way an FMEA is doing. It is purely a brainstorming. We need to thoroughly understand the system, then only we can suggest more suggestions to prevent the accidents associated with that particular failure mode. So now we will discuss what is FMEA, failure mode effect criticality analysis. When FMEA is used for prioritization of failure modes, it is referred as failure mode effect and criticality analysis. It uses a risk priority number. The risk priority number is multiplication of three classes, that is occurrence class, severity class, and non-detection class. Occurrence means so we have already mentioned what is the failure mode. So we need to find out the failure frequency of that particular failure mode, and it can be classified as per certain guidelines given by IEC. And we need to identify which particular failure mode is coming under which occurrence class, and similarly what will be the severity, and that severity is coming under which severity class. And similarly, some of the failure modes we may be able to detect in advance, but some of them may not be. So we need to identify the percentage detectability of these failure modes, and depending upon the percentage detectability of that failure mode, we can assign certain values. And by multiplying these, the occurrence frequency class and then severity class and non-detection class, we may be able to identify the risk priority number. So once if we are able to identify this risk priority number, the higher the number means that failure will be much crucial for that system. So we can concentrate more on to that failure mode, and we can rectify that problem. So another case study I will be discussing is the FMEA on ABS system. So all of you are aware what is an ABS system. In majority of the car, ABS system is there. So what this ABS system is doing, so all of you know that what is an ABS system, anti-lock braking system. So the anti-lock braking system will avoid skidding. So this ABS system will compare the speed of the front wheel and the speed of the rear wheel. And whenever the speed of the front wheel is too less when compared to that of the rear wheel, there is a possibility of skidding. So in that case, the microcomputer which is used in this anti-lock braking system, which will give a command to open the valve, which will adjust the braking effect of the front wheel, and that's the way it is managed. So now there are different components in that ABS system. Say S1 and S2, these are the two sensors which is provided in the front wheel, which will measure the speed of the front wheel. S3 is another sensor which is provided in the rear wheel side or the propeller shaft, and a microcomputer for receiving and processing the signals, then valve V1 and V2 to control the braking force, and there may be a master cylinder for maintaining the fluid pressure for braking effect. So now we will consider the different failure modes of these components and how it will affect the system. So we may consider the front wheel sensor S1 and S2. So these are all the two sensor S1 or S2. Any of these sensor we can consider. The failure mode of these sensor can be no output signal. So what will be the failure effect? The microcomputer will assume that one wheel has stopped and will send a signal to open the corresponding valve. So the final effect is partial loss of front wheel braking. And similarly, when the rear wheel sensor S3 is failed or no output is coming from that sensor, the effect is no reference speed and hence no opening of valve V1 or V2, both front wheel locks on heavy braking. So if that rear wheel sensor S3 is locking, that means that so you will not get the benefits of ABS even though if you are installing ABS in your vehicle. So similarly, different failure modes like front wheel valve V1, V2 fails to open, fails to close, and the corresponding failure effects are one front wheel could lock on heavy braking, then partial loss of front wheel braking, and similarly microcomputer, no output signal to both front wheel valves, no output signal to one front wheel valve, and spurious output to both front wheel valves. So like that, so many failure modes we may be able to identify, and then we can identify the effects. So if there is experts who are well aware about the system, they can identify the effect, and they can even suggest remedies to prevent these effects. So when we are talking about the FMEA, about this particular example, So we have identified different components from which is used in the ABS system, the failure modes associated with these components, and we may be able to identify the failure frequency, and it can be classified as per IEC, and then severity, and then severity class, non-detection and non-detection class. Suppose now after getting all these classes, if you are multiplying these values, we will get the RPN number. So here from this example, we can understand that the microcomputer component with a failure mode no output to V1 and V2 with the RPN value of 24. So that is having highest RPN value. So that can be the most critical failure mode with respect to this ABS system. So now we will move on to the next part, that is LNG industry and FMEA study on LNG industry. I'll just play a quick video related to LNG industry that will give a brief idea. It will take a maximum 4 minutes, I hope so.
These resources are produced from subsurface reservoirs, both onshore and offshore. A complex value chain transports natural gas to consumers around the world. The value chain begins with the process of bringing natural gas to market by safely drilling wells to bring the gas and other reservoir components to the surface, where it may be processed on-site or transported to a facility for treating and processing. Natural gas extracted from subsurface reservoirs can contain non-hydrocarbons, including hydrogen sulfide, nitrogen, carbon dioxide, and water. The treatment processes remove these components from the natural gas. A solvent is used to absorb carbon dioxide, hydrogen sulfide, and water. Heavier liquids are removed from the lighter gas for separate processing. Water is removed, and the remaining natural gas is ready to be cooled into a liquid. Depending on the source of the natural gas, it may need to be transported to a liquefaction facility. The gas is transported by pipeline and can travel hundreds of miles or just a few feet to a liquefaction facility. This depends on where the gas treatment facilities are located relative to the liquefaction plant. The liquefaction plant cools the gas to -260 degrees Fahrenheit, or -162 degrees Celsius. As the gas cools, it is reduced to 1/600th of its previous volume. The resulting liquefied natural gas is clear, colorless, and ready for transport. The liquefied natural gas, or LNG, is stored in large insulated tanks until it is ready for shipment. Pipes connect the storage tank to a loading jetty. Regardless of outside temperatures, the LNG inside the tanks and loading facility remains at -260 degrees Fahrenheit or -162 degrees Celsius. The LNG is then pumped into specially designed LNG ships. LNG shipping tankers transfer natural gas around the world. Some of the largest LNG ships, such as the QMax, are longer than 60 city buses. And each QMax LNG ship carries enough natural gas to power 70,000 homes for 1 year. When the LNG ship arrives, it is guided to the receiving terminal, where the LNG is unloaded and stored in insulated tanks. The LNG is then pumped into a regasification plant, where it is warmed and converted back to a gaseous state. The natural gas is then ready to complete its journey. A network of pipelines delivers the
I hope that video gives a comprehensive idea about LNG terminal and the LNG industry. So thanks to ExxonMobil for this wonderful video. So now I will discuss some of the issues associated with the LNG when compared to that of LPG. So all of us are thinking that LNG is the cleaner fuel, but the problem associated with the LNG is its expansion ratio. So what the expansion ratio of LNG is 1:600, whereas the expansion ratio of LPG is 1:270. So there are some other hazards associated with the LNG. play one more video. So that would
rapidly, producing explosive gas vapor. Field tests show that pools of LNG can burn for long periods of time. Flames from large LNG pool fires can reach up to 150 meters in height. There have been multiple explosions of LNG tanker trucks that have caused serious damage. In 2012, an LNG tanker truck exploded in central China.
So there are issues like RPT, rapid phase transition, then rollover, then classification. These are some of the issues associated with the LNG handling. So this is a typical LNG terminal, courtesy to the Google image. And this is the process flow diagram of the LNG terminal. And we are concentrating on this particular study with respect to that unloading facility and the storage tank. So the major issues associated with the LNG, operations are loss of containment from the storage tank, the loss of containment during transportation through sea, and loss of containment during unloading and leakage during distribution. So appropriate and in-depth safety analysis should be carried out to avoid the safety issues to human and damage issues to property and environment associated with the new technologies used in this facility. So here what we did is we did the FMEA study. So that will be useful for a particular aspect, but there are so many other studies, CUSAT studies and other studies can be conducted to identify the problem associated with this LNG terminal. So the major units in a LNG terminals are unloading jetty and LNG storage tank, void of gas handling and recondenser, high pressure pumps and vaporizers, and the process control and safeguarding system, and general facilities like offices, warehouses, and workshops. So now we will move on to the next case study, that is FMEA on LNG unloading facility. So this picture shows the LNG unloading jetty. It consists of unloading arms. There are in this picture there are 3 unloading arms and 1 vapor return arm. So the vapor return arm is used for balancing the pressure between the tank and the ship. So this picture also gives a clear idea about how that unloading arm looks like. So I'm having another video that is related to unloading arm that will give the minute details of the unloading arm when the ship is coming and berthing in that jetty, how this unloading arm is connected. Yeah, there may be accident associated with this unloading arm also. These are all some of the accidents associated with this unloading arm, and there may be LNG release during unloading. So I have more slides about the description of this unloading arm, but due to lack of time, I'm not sharing the details. So anyway, there are so many parts associated with this unloading arm. These are the parts associated with this unloading arm, like loading and unloading arm, vapor return arm, vapor lines and valves, the relief valve, vapor return line, vapor return compressor, angle sensor, pressure sensor, flow sensor, then pressure alarm, motion alarm, UV flame detector, etc. So now we can conduct the failure mode effect analysis on this unloading arm facility. We need to identify the different components. We need to identify the different failure modes, and we also need to identify the different effects due to these failure modes. So I'm just showing only 5 failure modes here. So we have published a paper, and that is there in Journal of Loss Prevention in Process Industry. In that paper, at the end I will share the first page of that paper. You may be able to download that paper. So in that all these details are available. So the foundation bolt, then shear failure, then pantograph cable, then breakage of cable, like that. Around 44 failure modes we have identified, and then we have identified the effects of that one also. So similarly, by applying this occurrence class, severity class, and non-detection class, we may be able to identify the RPN associated with these different failure modes, and we can prioritize the failures, and accordingly we can concentrate more on the failures. So in this paper, the details are also available. I'm just taking a screenshot of small portion of that paper. So, so around 44 failure modes and FMEA studies results are also available. And we will move on to the last case study, that is FMEA on LNG storage facility. So this is a P&ID of the LNG storage facility, and this is the cross-sectional view of LNG storage facility. So these are all some of the important equipments which is used for avoiding the accident associated with the stratification, rollover, etc. So the equipments like barrel, cryogenic pump, density indication and control, flow indication and control, check valve, high level alarm, low level alarm, etc. So we need to identify the failure modes of these components, and we need to identify the frequency, and we need to classify which is coming in this class as per that IEC classification. Then we need to identify the severity class also corresponding to this failure mode. And finally, we can get the RPN value by multiplying occurrence, severity, and non-detection value. And finally, we will be able to rank these failures. We will be able to rank these failures, so we can concentrate more on to that aspect. And I have a lot of research related to this one, but since due to lack of time, I'm not taking that portion right now. So with this, I'm directly going to the summary and conclusion. So FMEA is one of the hazard identification tools used in complex mechanical and electrical systems. And FMEA is used to identify failure modes of components and its impacts on the system. And FMEA is used to rank the criticality of failure modes of components in a system. And FMEA study is conducted in the LNG unloading facility and LNG storage, and it gives some light on the hazard, the failure modes of different components and its impact on the system. So with that, I'm stopping, and these are all the references which is published by us. These two references I have used for the previous presentation. You may be able to download it from the net, or if you are so particular, you may contact me so that I can share it. Then I have used one more reference that is published by a different author, and we published a third paper also in this area. So totally we have published around 4 papers related to this LNG industry and FMEA studies. If you have any queries, you may put in the chat box. I will try to answer some of the queries, and if time permits, or otherwise, I will try to give in the panel discussion in the event. I am also there in the panel discussion as a panel member. So thank you very much for your patient hearing. Thank you very much. And this is my Google Scholar profile page. All my papers are available in this thing, and you can visit my Google profile page, and you may be able to download my paper. So these are all the research aspects. We have introduced some facility in this for rectifying some of the issues associated with this particular technique, but due to lack of time, I am not sharing that. Okay, so these are all some of the limitations of conventional RPN what I have taught, and we by using fuzzy logic we have rectified these issues also. So one of my PhD scholar is completed, and I hope within 3 months we will get a PhD in that area. So in some other occasion, I am happy to share that concept also. So with that, thank you very much. Once again, I thank all the core committee members and the ASSP Kuwait chapter for giving us a chance to showcase our ideas in front of the safety professionals all over the world. So thank you very much. Thank you.
Thank you, Dr. B.R. Renjith. It was really very enriching and engaging FMEA in LNG. We wish that duration was a little longer to engage more on this, but it was you have given us some fresh idea and fresh engagement itself. There was a question, I think it's of general nature, by our one of the expert, and he's a global leader. So see that. Yeah, by Mr. Ashok Garlapati sir. He is our senior mentor and he is global leader itself. Dr. Renjith, thank you for excellent presentation. Please share the link to the video to use in our awareness session. So this was one of the commendable remark and a request to share the link. Yes, Doctor.
Yes, sir. Yes, sir. Definitely, yes, I will share. I will share this presentation, and including that research aspects also. I have a YouTube video related to this. Another presentation, it's available in YouTube, and I already shared it with Najas. So those who are interested may utilize that particular.
Great,
video.
Sir. Great.
Okay. In addition to that, we are happy to share our research publications also. So you may refer our Google Scholar page so that you may be able to download. In case of any difficulty, you can contact us through our mail so that we will share it with you.
Great, sir. It was a really overwhelming response by audience itself. There is another remark by our past president, Mr. Sunil NS. It is a great value presentation by Dr. Renjith. Congratulations and many thanks for sharing this. This lecture itself, it is pertinent because we are having a biggest LNG commission a month before in Mina Al-Jor in Kuwait. So people will be definitely getting a value in this and they will be eager to know more about it.
Yes,
so
sir.
You have, yeah,
sir,
you have.
Yes, sir. Yeah, sir. This is this study we conducted with 3 visits, maximum of 3 visits. With the 3 visits only, we could do this much. So if the industries are sharing your experience and if you are sharing data, we can do a lot of research. That's the area we are. That's the challenge we are facing in the field of research.
Yes, I understand that to substantiate it and to add more value, then respective company, respective country itself has to allow access. We will try our level best to have a networking, channeling to help us, a researcher and like-minded people, and to have more focus and giving value to the people who are looking for research. Great with that.
Okay, thank you.
Yeah, we will take some more question if it is coming up during like a panel discussion session itself.
Yes, sir.
So thank you very much for all who had listened to us. I understand it is a long session, but bear with us if you want to learn something more about it. I will take you. Thank you all, and thank you, Dr. Via Renjith. We will be in touch again in between a networking time. So I will take you a little journey. Those who are new to American Society of Safety Professional, but I will share you a little information for ASSP Kuwait chapter. This is Safdar Ali Khan. I am looking more younger today than yesterday. Hope you agree with me. So this is Safdar Ali Khan, certified safety professional working as a HSC manager in ULA Fuel Marketing Company. And one of my volunteering activity is to associate with American Society. I have been associated with from 2005 and it has been 16 years. I have learned a lot of wealth of information and still ongoing. And I am a grade IOS member itself. So those who are looking for value addition, be in association with the American Society, and it will take you in a new dimension, which is more purposeful. We are looking forward for this. So this is a small brief, which I'm going to take you on this. Next, yeah. So these are some of the activity we usually do it. like these are glimpses I am just sharing with you. We have conducted definitely 3-4 sessions we are conducting in each month itself. So it is based on the annual program of various committee. Like we are having 10 committee. Gentlemen, I will take your question when you have raised the hand. Let me finish with this and then I'll come back to you. So this was called Global OSHA 345 authorized gas tester training, which held on 17 to 18 September by Mr. Ashok Garlapati and Mr. James Barnes, where 75 participants has benefited by attending this. As you are aware that November 3rd and 4th, there is a conference, Kuwait International Conference on Occupational Health and Hygiene. Those who are looking for enhancing their career in industrial hygiene or health, they can be able to attend this conference, which is still virtual. And before that conference is happening, we were having a professional development program. And these are some of the glimpses of that professional development program, which we have tied up with event organizer, that VConX. And there was one program which has held on career for CIH, and by speaker Mr. Hatem Saleh Al-Matar, where 54 participants had attended and got benefited about certified industrial hygiene exam preparation, objective, and know-how. Every year to promote private sector health, environment, and safety promotion campaign and recognizing their effort, every year we are doing this American Society of GCC HSC Excellence Award. In this one, there are various categories. Many companies can participate in. Please visit to our American Society webpage, Kuwait chapter. And those companies are having a certain criteria. There is by adjustment committee is there. When they submit their document, they are judged with based on their score, what they achieve it. Based on the score evaluation, there are various categories: gold, silver, bronze, platinum, and dividend tower. So last year it was. Despite it was on June, we held it on 30th of September, and there were about 60 different categories. The award was gone to various companies. They have participated in various categories itself, and around 40 companies has participated. So those private companies who are looking to participate, they can also participate in GCC award. And every year, American Society is awarding Safety Professional Year Award. And this year, our past president, Mr. Sunil Sadanand, who is working as a safety engineer in Kuwait Aviation Fueling Company, received this prestigious award. So congratulations to Mr. Sunil Sadanand, and we look forward for your support, your guidance in future for American Society volunteering effort. This was another professional development program on critical lifting plan for critical lift, crane lifting plan for critical lift, which was also a professional development program for KICOH on 4th of October, where the expert Lieutenant Colonel Frank Tan has given his insightful presentation, where 112 participants has attended this meet. This was another program which has given an sandblasting and recent alternative application by Mr. Dr. Abdul Al-Yami and Mr. Abdul Rahman, where 75 people participated on 14th of October. So see, these are something I was showing you. Whenever you have an opportunity, try to engage yourself, so you will be having a continuous professional development awareness program and able to maintain your CEUs. If the program is announced 1 month before and you are part of that. American Society is Kuwait chapter is also having Toastmaster Club. So every first and third Saturday of month, we are meeting for this program development and leadership development. So those American Society members who are looking forward for developing their leadership skill and presentation mastery, they can be a part of this, come as a guest member, first and third of Saturday of every Saturday of the month itself. So this was on last 2nd and 16th of October. As we have annual plan, so this was the glimpses of the last plan. Yesterday, Wednesday, every third of Wednesday, we are having a process safety technical meet. So now third week in Wednesday, third week of Wednesday, we will be having another process safety technical event. There is another event which is for breast cancer awareness on 24th. There is a breast cancer awareness on 24th by a wise committee on Swaiba Medical Center. So those who are here, they can be able to attend. This is especially exclusive for ladies program. Now, these are some of the training opportunity like ISO 45001 lead auditor training, which is program and scheduled from 7th and 11th of November. Those members who are already interested, they can send their nomination to our chapter WhatsApp page. Like I was saying, 17th November, we will be having process safety technical meet, and there is a Board of Occupational Health Safety W50 program, which is one of the model required for CIH examination. 505 is a plan by end of this November. And this is a long awaited our every 2 years this program we are doing it. So the program is scheduled on the 9th or 10th of the November. The date will be already announced and you will put it here also. So 11th Professional International HSSC and Loss Prevention Professional Development Conference and Exhibition. We were not sure when this phase 5 will be overing and the people will be permitted to have a joint meeting in a conferences. So for that region, the date was still lingering. Alhamdulillah, now the COVID all around the whole world has receded. It's a great relief to human mankind, and industries and other conferences, schools, university are coming back to the track. So we look forward for your participation in November 2nd week. So thank you for all being with us in the journey of American Society. This was a small brief about this. So moving back to, we will go to another session. One gentleman has raised his hand. Let me see who is this gentleman. listen to his question. It was another message from Ashok Garlapati sir that CUSAT student can become ASSP student members for $6 per year and get all benefit. That's we will be sharing the same information in the membership benefit presentation. There is another gentleman who has raised his hand. I can see him, but I will take his question when the time permits. Okay, so this is for American Society Kuwait chapter briefing. And now we will move towards technical session number 2. And moderator will be Mazharuddin Shaikh, Vice President, and who is also working as a safety engineer in Kuwait Oil Company. And he is certified functional safety engineer and very vast experience, especially in process safety related. And today's speaker, Mr. Rahul Patteri. We have listened you, sir. Very engaging. You remind us to one of our leader, Mr. Jitu Patel. Your voice seems very similar, and you have a very vast knowledge of subject, very quality, engaging. We like you all the time, and we will not leave you. Remember that. So the networking has just started, and we will be meeting you most of the time, sir. So floor is yours, Mr. Mazharuddin Shaikh, Vice President.
Thank you, Safdar bhai. Am I audible?
Speak loud, sir.
Hello. Am I audible, Safdar bhai?
Little louder, sir.
Give me a moment. Give me a moment.
Yeah. Just to add on, we are the first chapter which is certified all over world. First chapter. We are operating. We have 36,000 volunteers all over world, and we are having 11 different areas. So in that one, we are first to be awarded ISO 9001. So it is a great achievement for ASSP chapter leaders who were pioneer behind this and making to this stage. And with your networking, with your collaboration, we will take this chapter to new scale of success. So please bear with us. We are having some adjustment in networking.
Hello, Safdarji.
Yes, dear.
Okay, so now my voice is coming now. Huh?
Yes, dear. Yes, dear.
Okay, okay. So thank you, Safdarji. Thanks a lot. And yes, what you said about Mr. Rahul Patteri is really correct. We have enjoyed his session yesterday, which was also very, in depth, starting from basic of fire triangle to going to the level where incident can happen due to issues in the design or due to maintenance. So correctly you said he is very engaging one, which is good for all the participants today as he is coming up with different subject. But before I introduce Mr. Rahul, I would like to throw some light on our this session. We have a 45 minutes for this session, and in which 5 minutes for introduction, 30 minutes for presentation, and in last 10 minutes we will have a questions directly to Mr. Rahul and concluding remarks. So I request speaker to be in time if possible, and to all the participants, please mute your mic, because in the first presentation, as you are aware, we have seen some disturbance. So request all of you to mute your mic, and those who are on PC, keep your mouse on side, so it will be better. By mistake also, it will not happen. And post your questions starting with capital S, 2 and Q. That is session 2 question. So there will be no confusion with the questions if anybody is posting later for the session 1. So that is the thing, and give full concentration to this presentation, because it is part of a very good learning, particularly my favorite subject, which is challenging in life cycle of project from the concept stage to commissioning and operation. I remember we presented this in 2017 in USA, CCPS Global Congress on Process Safety. And really, it's a very vast subject and very difficult to cover within 30 minutes. So please, everyone, give your full concentration in this and ask your questions in chat box. Only ask your question in the chat box. Whatever you want to write, I request, write it after the presentation is finished. And if you want to ask direct questions, please raise your hands. At the end of the presentation, I'll call by the name. Please then introduce yourself and you can go ahead with the question. So that's all. And let me introduce Mr. Rahul. He is a BTech from the CUSAT only. So he has 2 connections today. He is also a part of ASSP Kuwait chapter recently with us. And now I think since many years, he is also alumni of CUSAT. He is MSc in the Process Safety and Loss Prevention from the University of Sheffield, one of the best university and one of the best degree, you can say, in the field of process safety from any of the university in the world. So now we have very experienced and very qualified person with us, the giving trainings and instructions and awareness. Throwing awareness is his favorite part of his job. He loves it, and that we have seen yesterday the way he is doing. And especially for this part of the world, which is Middle East part, he has a very good experience in the part in Oman, in Abu Dhabi, right? So he knows the culture here. So I'm sure he must have considered that also, as yesterday what he did. He is also functional safety professional from in IEC. Then he is also Lean Six Sigma Green Belt and Chartered Professional Engineer. Presently, he is a leader in fire protection and process safety in ENOC. So, Mr. Rahul Patteri, I would like to welcome you, and you can share your screen, and then we can start our presentation. Thank you so much.
Assalamu alaikum and good day. May I please check, am I audible?
You are very loud and clear.
Oh, thank you very much for the feedback. To begin, I would like to stack the deck to what my sir, Renjith sir said. We are very grateful to ASSP Kuwait chapter. Though my association has just been a few hours young, starting from last evening, but then it feels as though it has been somewhat a long association, especially when Mr. Shaikh speaks so vividly about myself, and Mr. Safdar Khan has given me an excellent brotherly sort of addressal by stating that he's not going to leave me. I really, really liked it. That this actually shows how much of humility yourselves have. Why? Because energy always flows from higher to lower. And since it is flowing from your side, I am humbled. And like what Renjith sir said, we are very grateful for this opportunity. And without any further ado, I'm sorry, I have to also address my CUSAT. And to all the people over here from Cochin University, namaskaram. Thank you for the students for having taken the time, because we have the faculties over here, And then the faculties can give a lot of academic know-how. And with the Kuwait ASSP chapter, the ASSP Kuwait chapter, and with ourselves, we can have a good amalgamation of academics and industry so that you get a wider perspective and your paradigm changes from how academics can influence the industry and vice versa. So let's start. The topic today that we are going to talk about is about challenges in the project life cycle. In terms of linguistics, like when talking, I do not really like the word challenges, but then why I have specifically kept challenges here, we are gonna find out at the end of the presentation. A little bit about myself. My dear moderator has stated, I've got a master's. I'm a functional safety specialist. I've got around a decade and a half of active industry contribution to major accident hazard sites across the globe. And very fortunate to have worked in various diasporas and various cultures, and each culture is a learning, and with each learning is an understanding. My career profile spanned as a firefighter. From firefighter, I've moved to something called as technical safety engineering into offshore and onshore industries. While doing my master's, I also had an opportunity to work as a consultant for design accidental loads and safety studies and what we say like the HAZOPs, and like what our Renjith sir said, the HAZOPs, the hazards, the FMEAs, the QRAs and the like. And now presently have an opportunity wherein all these learnings, or let me say all the mistakes that I have done across my career, is now set right so that the industry develops. And when an industry develops, we develop, and we develop, humanity develops, there is well-being. And when there is well-being, safety is actually well-being and freedom. Looking forward, yes, my Renjith sir actually has taken a lot of these basics by himself. However, please be rest assured, this particular basics is going to be more an industry specific, so that the students over here has now heard an academic perspective, and let's see how we can club it with the industry opinion. And then we will look into the opportunities and challenges in the project life cycles. So what is the petroleum value chain? Yeah, we must have heard, I'm sure we all have heard things called as upstream, downstream, and midstream. So what is all these? Why is it called upstream? What is upstream? What is midstream? Well, upstream is said to be the oil exploration and production firms, wherein the sort of establishment or the infrastructure is used to drill and explore oil. The downstream, however, are the large industrial units which have a lot of heat and mass transfer operations, and thereby converting one form of fluid to a more usable or more user-friendly or more energy-intensive operation. And the interim between upstream and downstream is the midstream, which is primarily transportation of whatever sort of fluids are from the upstream, which had a very little separation, moves via pipelines, via floating installations on road to the downstream. So now, have we thought, why is it called upstream? This is just my guess. For those who know about this can always correct me, but this is an opportunity where we can talk, and therefore let me guess, why is it called upstream? As we said, in this upstream industry process, the drill bit goes down, the reservoir is punctured, and the inherent pressure pulls, or let's say pushes the fluid up, and therefore I believe it's called upstream. And downstream, why is it called downstream? In the same paradigm of thought, if you have really driven across a refinery installation or a petrochemical installation and just look into the topography, the heart of the plant, or let's say where it all starts, is the distillation unit. And from the distillation unit to the cracking, the isomerization, alkylation, and likewise towards the tankages, the topography actually slopes down. And this is why I believe, since the fluid flows from distillation to the product storage tanks, and so it flows in a downward direction, and therefore I believe it could be, that's why it's called downstream. And then what is midstream? We just saw a midstream is the interim between upstream and downstream. It's actually the downstream feed is upstream's product, if you really see it. So how can the product of the upstream go as a feed downstream? There should be some sort of a movement mechanism, a propulsion mechanism. It can be pipelines. There could be floating installations, as we saw. So floating installations can go in, it can anchor in, and using SPMs, or like what Renjith sir said, by marine loading arms, can load to the refineries. So moving forward, now coming to basics about hazard. I mean, I haven't seen any sort of presentations where this word hazard is not really talked about. So hazard is the potential for harm. So here, if you really look, hazard, or there is always a potential wherever we see. Here is a typical downstream operating plant. There is obviously hazards of combustible materials. There is combustible fluids. There is pressure. There is temperature. There could be toxic gases. There could be asphyxiating medium. And what about here on a racing car? Isn't there a hazard there as well? Yes, because there's a lot of kinetic energy that this car possesses. And by the law of conservation of energy, if anything or anyone gets in the sort of direction of this energy, the energy can be transferred, and that can cause harm, or there is a potential for harm. What about a lifting operation? We just talked about kinetic energy. Here it's a potential energy, and the energy is stored. There could be a potential for the slings to break and fall, and there is a potential for harm. So anywhere we look, be it be an operating plant, be it be just walking down the street, there is always hazard. But then the hazard there does not really mean that we need to stop everything and then, how do I say? We need to go and develop, and we need to bear the brunt of it. And that is where we have something called as a PHA. A PHA is a preliminary hazard analysis. So there are various tools, which in fact, my Renjith sir had also now spoken, and these are just a few of them. Let's look into them one by one. So here, what if? What if is like a questioning technique. We see an operating, let's now ask these questions. What if my fuel in the car diminishes? What if I get a call while I am driving? What if there is an accident in between the traffic? So these kind of what if questions will anticipate ideas and therefore find solutions. Let's look into the next one called hazard. A hazard, by the acronym, is hazard identification. So hazard identification of what? Hazard identification in layman's term of all those things outside a processing plant or outside a pipeline. So it is just to identify all those hazards outside the pipeline. For example, the design philosophy and guidance. What is the soil stability? Is there a potential for a natural calamity to happen? Let's take this example that you see here in this particular, let's say, spool piece. Can there be a dropped object in place? And if there is a dropped object in place, I mean, there's a potential for dropped object, what can we do? Is there sufficient spacing to change the spool? These particular spool piece, since there are flanges in close proximity, we know that it need to be torqued in and out for any particular reasons. So is there a place to actually, whatever is torqued out can be laid down properly? There could be flow transmitters, there could be level transmitters. So can there be an electromagnetic radiation? Can there be electromagnetic interference? Can there be hot surfaces? So ideally what HAZID looks into is to identify all those hazards, like this particular investigator of mine over here, looking into all the hazards outside the piping. So coming into HAZOP. So I kept on saying outside the piping, outside the piping, outside the piping. And please see the acronym over here, HAZOP, hazard during operations. So unlike HAZID, because HAZID looks into all those hazards in the vicinity of the processing facility, whereas HAZOP looks into all the hazards during operations. So now for an effective HAZOP to happen, what needs is that there is a need list. For example, people sit together. This is also a brainstorming exercise, and there are some need lists like PNIDs. PNIDs are called piping and instrumentation diagrams. There need to be cause and effect diagrams. Cause and effect diagrams will tell for various causes what would be the effects. There needs to be hazardous area classification layouts, and these kinds of these are called process safety information which a team needs. For those who are not very familiar with these terms, please take note of it, and we can discuss on this either today or whenever you have time, because I'm always available. So as we said, a HAZOP is to look into deviations in process parameters. And what are these process parameters? Because earlier in HAZID, we talked about design philosophy, dropped objects, spacing criteria, emergency response, hot surface, and the like. However, in HAZOP, the process parameters are flow, level, pressure, temperature, reaction, viscosity, and all the like. And if there are batch operations, there could be time-based operations, there could be purge cycles, there could be cleanup operations and the like. So anything and everything associated with things inside an operating plant or inside an operating piping or a vessel will classify as the process parameter. And we said deviations. So what are the deviations? Deviations are certain prompts like no, which means no flow or no level, no pressure, no temperature, or we can say more temperature. Reverse means maybe reverse flow. Other than means something is supposed to flow, but other than that, something else is flowing. Phase changes, we are supposed to have something in the liquid phase, but then there was a gas blow by. Gas blow by means something of a different phase comes into and therefore disengages and causes turbulence. As a very simple example in this, let's see flow. Here we've got tanks, there are few pumps. So what is the particular process vessels here? There are few settling tanks here, there are pumps and piping. So what happens? There can be flow happening across, there can be level happening across. Maybe let's say that it's an insulated tank, so there is some temperature. Maybe there are some, how do you say that? Those sort of mixers over there, so some reaction happening. So In a HAZOP, what we see is that we look into a system, it's called a node. So we look into a system and we ask questions. Can there be no flow to this tank? Yes, there can be if this pump is not working. Can there be no flow to this tank? Yes, there can be if the discharge piping is broken. Can there be no flow to this? Yes, it can be if the suction line is broken, or maybe what happens is that the particular operator, because of the, like we said in yesterday's discussion, there was a contributing cause wherein the operator, instead of starting this pump, goes and starts that pump. So a HAZOP is a brainstorming exercise where a team looking into the information asks the relevant questions into the node in our into the node which will be examined. Moving forward, like Renjith sir said, fault tree analysis. So here the thing that we have to see is a tree. What is a tree? A tree has a lot of branches, and a tree comes from, it's a top-down approach. So like what Renjith sir said, we always start with something called as an undesirable top event. So here, something that you have to remember is a tree grows from bottom to top. However, a fault tree, fault means ulta. So a fault tree, so it goes from top to down. So that is how I remember. So a fault tree is a top-down approach, and it will always start with an undesirable event, an undesirable top event, which means something that has already happened. For example, over here it is saying the plant has burned down. So and then it looks into some logic diagrams like and, or, fault. There is XOR, NOR. So there are a lot of these things which we would have to go through, but since we will be looking into the opportunities or the challenges in projects, I'll just skim through it right now. Moving forward, we have an event tree analysis. So a fault tree analysis, it is a fault of a tree. Tree grows from bottom to top. So fault is the reverse. So it's a top-down approach. However, an event tree starts with an initiating event, whereas a fault tree starts with a top event. Top event means something that has already happened. So an event tree starts with an initiating event. Let's say, for example, there was a gas release. For those who have been listening very patiently to Renjith sir's discussion, he had stated an initiating event, safeguards, and their success factors. So success factors here is the yes and no tree, or the branches that you see here. Let's go through the event tree analysis. If a gas release happens, let's say the things are, is it pressurized or not? So if it is pressurized, we say yes, it is pressurized. Now, can there be an immediate ignition over there? Maybe there is some hot work happening, or maybe there is some sort of a gland, an electrical wire that has lost its gland, and therefore it is no more ATEX certified. It sort of ignites. Can it ignite? Yes, it can be ignited. And something in pressure gets ignited immediately. It's a jet propelled fire. So now let's say if it is a no, if it is not a pressurized one, but there can be an immediate ignition happening, since there is no force, it is not a jet fire, but it can be a flash fire. So that is something called an event tree analysis. So I'll just say fault tree is the reverse of how a tree grows. Event always starts. An event always starts. So for an event to start, we need an initiating event. And for failure mode and defect analysis, my sir has actually spoken. He knows much more than I. So I do not want to disregard by saying anything more on FMEA, because he's talked about FMECA, and my moderator, who is a functional safety professional and a specialist, also knows there is something called as an FMEDA as well, a diagnostic analysis. But we will talk about that possibly and inshallah in another session. So now, from a PHA, we have determined the hazards. That is, from PHA, we have determined those with the potential for harm. Those which can harm us is measured. It needs to have a unit to measure. Unless we measure, we cannot, how do you say? There was I forgot the proverb. A data, if it cannot be measured, it cannot be resolved. So unless we measure it, we cannot resolve it. So a harm is measured by its severity. But then what is this word called risk? We've heard about hazard. It is a potential for harm. And potential for harm, it can have a consequence, and the consequence is measured by severity. Whereas risk is a multi-dimensional entity. A risk is a multi-dimensional entity, which means it needs more than one event to happen. So a risk can, in terms of how do I say, representation, say, is a function of severity from the hazard and the probability of the hazard occurrence. So it is a function of, so that's why it's a multi-dimensional one. It's a function of severity and probability happening together is a risk. So now if I can ask a question, when I say multi-dimensional, can we say it's a two-dimensional one? Not really. A multi-dimensional is given for the fact that the more you want to determine or more you want to plug into, like what Renjith said, the more research you do, you will have more conditional modifiers or more multiplicative units to be placed, and therefore it's a multi-dimensional entity. So now we said risk. Just a minute, please bear with me. Okay, a risk is a function of severity and the probability. It can also be said that risk is a multiplication event, or risk is when a consequence is and there is a frequency of occurrence, or there is an impact and likelihood. So many ways of looking into it. So what are now called risk receptors? We saw what a hazard is. Hazard is something that can cause a harm. We know what a risk is. Risk is when there is a multi-dimensional event happening, which means the hazard needs to occur. Two things at least should happen for risk to happen. Two things as a minimum should happen. And what are risk receptors? Well, here it is almost lunchtime, so let's take a fruit example over here. This is, my son is now just learning how to speak. So this is how he speaks. Pa, ra. It's a pear. In Malayalam, we say pear. So what is a pair? In risk receptors, P is for people, E is for environment, A is for asset, and R is for reputation. Just look into asset. Computers means information. Machinery is the equipment, the vehicles, the buildings, all are the asset. The capital investment is the asset, and reputation. So the risk, so when a multidimensional thing happens, the effect can be received by these many dimensions. So there can be people, environment, asset, and reputation. So like my Renjith sir said, there can be qualitative, there can be quantitative, there can be semi-quantitative. I'll just take you through. A qualitative is just like a metric. So here is the severity. Severity is the hazard. I'm sorry, I cut it off. There was something called as a likelihood over here. So you just have to go through, and that will give you a qualitative approach. Here we have a semi-quantitative approach. I mean, earlier, if you see, it was just low and low, which means a severity 2 with a likelihood 1 is also low, and a severity 1 with a likelihood 2 is low. So a person who is reading it does not really like what Renjith sir said, the risk prediction number. We do not know how much lower is to this particular quadrant to this particular quadrant. To make that relatively understandable or relatively quantifiable, there is something called as a semi-quantitative metrics. For example, all the area over here is green, But however, when I see an area green 1 and I see an area green 8, I know that particular hazard which creates a probability to, or that particular consequence that has a likelihood to have 8 is something that I need to address first. And not this, because it still has a long way to go before it comes to a medium risk. And now coming into quantitative risk. So quantity, anything which can be quantified, can be understood, and what can be understood can be resolved. And that is why we always quantify the risk. Why? Because if you quantify it, you will know how to prioritize it, and you can actually make it more sustainable. So in order to quantify, let's go back to our receptors: people, environment, asset, and reputation. So the quantitative assessments performed in these receptors are the following. Excuse me. So there is, for people, we do something called as a quantitative risk assessment. It is denoted by something called as IRPA, which is individual risk per annum. For environment, we do an environmental impact assessment. To be honest, I do not know what it is, and I'm sorry, I did not look into the unit. For an asset, you remember, I mean, we all remember the asset could be information, so cybersecurity. Asset could be the capital investment, the equipment. So there is something called as a fire explosion risk assessment. A BRA is a building risk assessment and the like. So here it looks into what your critical equipment and system. We will talk about the critical equipment system in a minute. So in case if the risk happens, so what is risk? The hazard when it materializes, what all systems can be impaired is quantified by these approaches. So once it's quantified, those which have a high risk, just pardon me, I'll take the pen. So those which have a high risk can be looked into and money can be spent wisely there. And those have a relatively lower risk can have a long expenditure line. And then reputation, of course, reputation here now, since the social media has come in, there is always an international media picking up. So when the international media picks up, what happens to the market or the unit shares? It flows down. And also the reputation of the company in order to have its business to continue, because it will have service level agreements with other agencies. So there will be an agreement. For example, if I am an industry, let's say I am an upstream industry exploration and I have my downstream partner, and there is an agreement that I will be flowing so much of fuel every day. If something happens, then I'm violating the agreement, and then that can adversely affect the reputation. So here it is translated to something called as a downtime. I'll go back to the laser pointer. Okay. So yes, since we are not relatively focusing on QRA, I would kindly ask my friends, peers, and mentors to please go through my YouTube channel. If you can, my friends have told me in YouTube, if you just type Rahul Patteri, you will come to see my channel, wherein I have spoken around 24 minutes about quantitative risk assessment. And I am very fond of this particular video. Why? Because it's all on pen and paper. So it is easily understandable even to a layman, is what I opinion. So now let's talk about risk analysis. So when we talk about risk analysis, so we saw hazard, we understand the dimensions in risk, and we talk about risk assessment. So there is a word called risk analysis. In the industry, many people actually, I wouldn't say confuse, but then it's a local parlance to use risk assessment and risk analysis together. To be honest, there is a subtle difference, but that difference is what is very essential. So risk management is actually the function of hazard analysis. So that particular hazard that we identified is quantified. And like we said, anything that is quantified can be analyzed. Why? So that we can effectively resolve it. So risk analysis, in fact, is determination of the risk reduction measures to reduce the calculated risk to ALARP. I know I'm using jargons, but it is just to mean that whatever risk you have, high, low, medium, that is being determined, quantified, semi-quantified, that can be analyzed appropriately so that the appropriate risk reduction measures to make it to ALARP. ALARP is as low as reasonably possible or practicable or practical. So the industry demands that, like we commissioned in the beginning, we have to live with the hazard. Hazard is there everywhere, but a prudent industry, a growth-minded individual assesses the hazard. Assesses means quantifies the hazard and analyzes the hazard to ensure that the risk is reduced to as low as reasonably practicable. And as low as reasonably practicable is a commitment of evolution which says that I will keep on trying to make it as low as possible. Like in our Plan, Do, Check Act, we say, continual improvement. Likewise, ALARP is a commitment for continual improvement. So now the risk analysis is determination of risk reduction. And to determine of risk reduction, there is something called as hierarchy of controls. So what is the hierarchy of control? So hierarchy of control from the most effective to the least effective over here, wherein PPE is the least effective one. While yesterday in our session with the American Safety Society Professional Kuwait chapter, we talked about human errors, and always PPE is supposed to be something which will help them. It is the least effective one. In fact, what we have to go through, we have to see, can I eliminate the hazard entirely? But no, hazard is there everywhere. So we cannot really eliminate it. Can we substitute the hazard? Is it really possible? For example, let's take a generic example. I want to have, let's say I want to eat healthy. So if I want to eat healthy, I can make healthy choices. For example, using honey instead of sugar, or using a more fibrous food instead of the refined foods. So can we substitute it? So that substitution is a method of lowering the risk. For the chemistry and the chemical engineers and the stalwarts learning chemistry, in our alkylation plant, hydrofluoric acid is one of the, HF is one of the catalysts. So what we did, learning from the incident in Texas, what we did is that we have now gone back to a solid fuel instead of a liquid fuel. So we have substituted the agent of the catalyst so that the risk relatively gets lower. Then we see, can we isolate it or separate it? Is it possible to isolate it? Here's a good example, an occupied building. We saw something called as a BRA. A BRA was a building risk assessment. So it looks into what are the risks to the building. Can the building collapse because of an explosion or not? In that case, can we separate it outside? Let's say this is the explosion area. Your building was here. So can I locate it to a safe area? So that is what, can you isolate it? Engineering controls, and this is what, can you give engineering controls? We have just listened to Renjith sir in his LOPA presentation. He was talking about these things. Once you have your PSVs in place, once you have your active fire protection in place, your alarms in place, all these are your engineering controls. Our permit to work system, administrative control, load to confined space, training, competency, all are organization controls, and of course, procedures and PPE. So these are the hierarchy of controls, and the hierarchy of controls are determined by risk analysis. So those risks which are very high, we need to eliminate it, substitute it, or isolate it. Those which are relatively lower can be looked by procedures or organizational controls. So this is what hierarchy of controls in fact means. So now moving forward, so we, those who have a Indian origin, Indian roots, diaspora would know this movie where Amitabh Bachchan says, "Mere paas
Rahul,
building hai,
just,
property hai, bank
hello.
balance hai, sab kuch hai. Tere paas kya
Rahul.
hai?" Yes.
We have 3 minutes left for all the question, answer, and concluding remarks, so that we can justify the next speakers also. Also,
Right.
I just request your good self to little bit speed up.
I'll do that. Thank you. Thank you for
it's such a
the
nice
heads
and
up.
interesting, but we need to justify time of the next speakers also. Thank you.
Absolutely, absolutely. So then we will move forward by, he says, so mere paas maa hai. So this maa is a major accident hazard, and coma is control of major accident hazard. So a major accident hazard and control of major accident hazard is nothing for the receptors that we have seen here, when there are more people dying. When there are more people dying, it's a major accident hazard. When there is a large environmental spill, there's a major accident hazard, and likewise an asset and reputation. LOPA, I will skip this now. Why? Because Renjith sir has actually spoken about it. Safety, we've got various elements of safety. We've got safety at workplace, we've got process safety, we've got functional safety. I've got videos on all this, so please, you can go and check it out. We also have something called as reliability, availability, and maintainability. Let's look into one particular example over here. My gas turbine shuts down 6 minutes at every 1 hour of operation. So here, the availability is actually 90%. How? 6 by 60 into 100. Availability is 90%. 90 seems to be good in terms of availability. However, the reliability is very poor. Why? Because each time my turbine shuts down, it has to go through a turn down sequence and a startup sequence. So just because your equipment is more available, it does not mean it has to be reliable. So the basics we have recapped. Project life cycles, and this is actually to be the crux of the event. Because of my poor time management, I'm sorry, I'm now embarrassing all the other speakers. But let's take it with our stride. So there is something called as a screening phase. So the screening phase, as you know, is an assessment of the various options for value proposition. For example, if there is a need for exploration and reservoir development, we have various options. There can be an artificial island, there can be a jacketed structure, or a floating installation. However, the challenges over here are the time period. For example, mostly screening phases are short term. There could be a lot of environmental criteria and environmental NOCs needed. NOCs means no objections needed, which could be very difficult at the screening phase. There are impacts from adjacent facilities which we might not know, because there could be other operators and their concessions which could potentially stop our particular project to develop. And then, of course, shortage of time. So from the screening, from the various options, we decide one particular option. So the challenges in that is that here also the time period is limited, the environmental impacts and all are the same. And here there is always the main problem in a concept phase is the complacency in calculating the budget. For example, we actually over design and provide an overestimated factor of safety, because of which the prices goes up, and sometimes the project does not see fruition. I mean, for those of us who have lived by the 2016 recession, know how many of the projects got shelved because of overestimated and over design. And of course, the documents are not mature. Why? Because it's just a concept phase. A feed is called front-end engineering. So once you finish the concept and now you are starting the engineering. Here, the challenges are surprises from geological conditions. For example, when you were trying to do the, how do you say, the screening and the concept, you had more of a gas reservoir, more of a liquid reservoir. But during this 5 years of turnover from concept to feed, the reservoir pressure and all went down, and now it's more of natural gas. So this can happen, plates change. There could be challenges in pipeline routing. There could be challenges in flaring capacity. Why? Because your concept was to flare liquids, but now there is gas, so you have to change the whole flaring philosophy. There will be constructability issues which will be checked during feed phase, and of course during engineering you will have your fire protection. And in an artificial island, if there is a lot of water in it, it can actually lead to stability of the island. Detail engineering phase, let's now look into a jacketed structure, a platform. The challenges over here is that from the feed to detail engineering, this is something called as LQ, a living quarter where people live. So what happened is the number of people went up so high that from the time of feed till detail engineering, the number of people estimated increased by 2 times. Why? Because there was an adjacent power generation barge and a jackup barge pulled up here, and all of them had to be accommodated over here. Then, of course, there are lifeboat testing difficulties and chopper arrangement difficulties, and of pandemic delays, of course. Commissioning phases, yes. Commissioning, one of the challenges we had while commissioning this multi-purpose tank was that while we saw that the foam concentrate, because as per the design, the foam concentrate had to be last fire approved. What is last fire? Large atmospheric storage tank fire approved. It was not done. Post-well heat treatment was not done properly. Non-ATEX rated equipment and the like. And in operations phase, always there is something called as loss of containment. And the 3 areas leading to the loss of containment is poor operational excellence, poor mechanical integrity, and poor engineering design. The contributing factor here, 51%, is operational excellence or operational flaws. For that, to be honest, I had made a presentation on how to do that. But since we are crunched with time, please, I will ask your permission to push it through. But however, please don't be rest assured, I have a YouTube video on that, and I'm sure you will have better understanding. So here, as we said, I do not like the word challenges. To be honest, these are opportunities. Once we engage with CUSAT, once we engage with the Kuwait chapter, we learn, and therefore once it's learning, challenges becomes opportunities. So here we end it. Credits to the videos that I've seen. This is something called as a golden circle. My why is to democratize illustrative and interesting education. How do I do it? By the YouTube video. And what I intend is for all of us to have better ability to manage and understand the hazard. As a point of gratitude of all my video, this is my Dr. G. Madhu sir. While I was learning in CUSAT, for this particular person has influenced me a lot, because he encouraged me to make mistakes and did not judge me, he and his pedagogy. And thanks to him, I am now able to come out and speak so freely. Thank you very much, Mr. Moderator, for having given me the time, and thank everyone for your patient listening. Thank you.
Thank you, Mr. Rahul. Wonderful presentation. And as I told you, and all of you, when we started, that this subject is very vast. Even if you sit here with the 5 days, 8 hours a day, we cannot complete it, because I know in depth of this subject, and it's very difficult within half an hour, but still you have covered a good area. So Mr. Rahul has already covered that there are different stages like identification and concept selection stage and project definition stage where we do feed, and then we have project execution stage where we have detailed engineering design, which did, and construction and commissioning, pre-commissioning and commissioning, all that. And after that there comes operation stage. So what he has shown, if we considered at a particular stage all this risk assessment and risk analysis studies properly, then the outcome of the studies will surely give you idea how you can reduce the residual risk which will be on the operation and maintenance staff during the operation period. So this is really a wonderful, Mr. Rahul, and I think we don't have any question in chat box, but very wonderful words for your good self. That in one word, I will say this is really a nice and insightful presentation. Thank you so much once again for giving a back-to-back two presentation in less than 24 hours. And surely we will not give you more time for the next one also. We will see you together. Thanks everyone for listening. And even if you have any questions now, we are going to have a break very soon. During that time, I would request Mr. Rahul to be there at least for 5 minutes so that, you know, if anybody has any question, he can directly join you. So he will be there for 5 minutes of the initiation of the break. And then he would also like to have something to eat after having so much of talk and you know. So thank you so much once again, everyone, for listening, being calm. We have not heard any disturbance during the session. Thanks to all of you for listening very patiently. And I'm sure there are a few questions during our Kahoot from this presentation. So those who are very, you know, concentrative during this presentation, I'm sure they will give a good answers there. So see you for the next thing, and hand over to Mr. Safdar Khan once again. Thank you so much, Mr. Rahul, once again. And
pleasure is mine. I will not take more time, but then Mr. Shaikh, you are such an excellent moderator. I don't know how you do it, but then, you know, I need to learn from you. Thank you.
Oh,
thank you.
It's my pleasure. It's my pleasure that you thought of me in that way. Thank you so much.
Thank you, Mr. Rahul and Mazharuddin Sheikh. Basically, we are doing networking, learning with each other. Now we will be taking a break here for 45 minutes, and we will be meeting sharp 1 o'clock. That session will be running from 1 o'clock till 1:30, and moderator Mr. Najas will be there, and speaker will be Mr. Dilip Madhavan. And topic will be safety performance indicator based on OSHA. So be on time, and we will meet you after the break at 1 o'clock. So it is a break for 45 minutes. We will see you soon by 1 p.m. in Kuwait, and rest in India. Please convert that. Okay, see you soon there. Let us have an ergonomic break and lunch.
Thank you, Mr. Safdar. So myself and Mr. Rahul are here up to next 5 minutes. That will be 12:30 in Kuwait time and 3 o'clock in India time. So anybody has any question related to project life cycle or any studies what he has presented, or anything, any issues you are facing during this project life cycle or during operation, you're very welcome to ask the questions.
I have posted our SSP web link. Those who are looking for some previous session, more information, more study materials are there for a student, for CUSAT and other people itself. Too much resources are there, that can be also downloadable. So please have a visit and see, there are abundant information who are looking for advancing themselves in knowledge. So it is already there. Okay, so see you soon at 1 o'clock.
Thank you, Mr. Rahul, for being there. Just will take your 5 minutes if any question arises.
Sheikh Saab, anytime. I have no problem. I am free, nothing to do. I have no much work.
At least eating.
Yeah, that's true.
So, how things there?
Things are very, very good over here.
What
Business are
about the
picking up.
restrictions?
Restrictions have actually now come down. Though mask is mandatory, however, there is 100% occupancy with mask, and the distance criteria, which was 2 meters, have now come down. Cases are relatively being low. There is, I think, very close to 100% of all the people who are vaccinated. And as in our terms, we say risk normalization. So now it is normal, you know.
That's good. That's good. Here also we have started from today. Good thing, and the good part of all of Indians over here is that we are gonna have benefit of full operation of the airport from 24th
Okay.
after a couple of days. So that would be very good for the people who are waiting to go from here up since last 2 years.
Oh yeah, that's true. Correct.
Including
true.
me.
Okay. God bless you. Yeah, good. Nice.
Inshallah. So that will be good. Yeah, Mr. Najas. Saying hi. Yes. Hi, Mr. Najas. You can come on the link. This is not only break, it's also networking. So you are warm welcome. If anybody is there to ask a question, the particular person will raise hand. So no worries. You can join us in the conversation. Mr. Najas, all star of the day. How are you?
Yes.
Yes.
I mean, I would like to thank Najas, because it is Najas who actually gave me this opportunity. I mean, of course, in consultation with the Kuwait chapter. Thanks to Najas.
Yes. He's the center of the circle, and working from behind, curtain. But all the success of this, if a single person, of course, it is not for the single person, but if I have to give to a single person, it's yes, of course, Mr. Najas. And also all the presenters from the different areas. I'm happy to see from the university and my previous organization. I have seen one presenter from ONGC. So I'm really excited today to, see all other presentations. It's really good. Mr. Najas, you would like to hear something? I have not heard your voice since long. From Mr. Vijay. Planning Kahoot demo. Okay. Thank you, Mr. Rahul. An interesting delivery and excellent talk. Really, it was really interesting and engaging. I think if you considered, we can have a little in detail session in future, not immediately. I know you are doing back to back for us. Very good. Whenever you feel good, we can have at least 1.5 or 2 hour session on this.
Certainly, I work well in impromptu sessions. So whenever it is needed, I just give me a few hours notice and we can do it. No problem.
We will give more details to our guys on different stages of the project.
Yes.
And where these studies are covered in different stages, because as you know, we are not covering QRA in identification stage. So
correct.
We will, what my idea is and my plan is that we will work together there and tell them why these things are required at particular stage and what particular benefit at that stage. And what if you do in other stage, what you will miss.
Exactly.
So that kind of thing I will present to our people. And
I like what you said, the why. Oh, yes, Mr. Saniwada, Vijay Saniwada.
Yeah, hello, Rahul.
Yes, hello. Hi.
Yeah, hi, Mr. Saniwada. How are you doing?
Yeah, I'm good. Actually, your presentation is very nice. Just I want to know, you told the synopsis there will be one of the consideration point, one of the challenge during feed stage and the engineering stage. And how about the synopsis during the operational phase and commissioning phase? How we do the risk assessment? How we do quantify the risk there, or just only normal risk assessment only we do?
Excellent
question.
Two things So if I understand your question well, you're asking that for operation, construction, commissioning, what role does SIMOPS play, and how do we know what all simultaneous operations are permitted? Am I correct?
Yes. Yes, and we do quantify the risk during the SIMOPS operations, or only we do normal risk assessment for the SIMOPS operations?
Oh, yes. Excellent. So the thing is like, the idea of SIMOPS is to look like a go, no go. It's to look into what all activities can go together and what all cannot. Rather than quantifying it, it is to see which can marry together and which cannot. For example, in the upstream industry, it's called MOPO, Manual of Permitted Operations. For example, while you are sort of maybe doing a well testing, you cannot do commissioning of your fire and gas systems. Are you with me? Or let me say, while you are doing gas testing, you cannot do maintenance of your fire and gas systems. While you are doing your barge operations, you cannot flare. You're with me? It is more than quantifying it. It is to let them know the window of opportunity for simultaneous operations to happen. When there is a chopper operation, there is no crane operation.
Yes.
Likewise, when you have a rig walkover, you cannot do your intermittent operations. When you have your hot work happening, you cannot disengage and do your maintenance for your ATEX cables. When your LOTO is engaged, you cannot take your DCS away. So this looks in it. It's like an XY matrix. Yes, someone has
Mr.
now.
Rahul, I just so you can just give them. I will not go up and down, but just to this because I have no permission right now for this session to show this. So that is why I'm not going up and down to tell you which company is this. But this is just an example.
Yes,
it will help you much better to understand, Mr. Vijay.
Yes, yes.
So here, if you see, there is something called as no means never, like, yes, and R is under circumstances.
Restrictions.
So yes, and under restrictions. So here, I mean, more than quantifying the risk, because these risks by itself has already been quantified. So rather than quantifying it, it is to see which can go together.
Yeah, actually, my question is actually some of the operations are allowed during the operations, during some production operations going on.
Correct.
Work hour is there.
Correct.
Some operations will be allowed. So during that simultaneous operations, both operations will be allowed. So how the risk will be quantified? Either risk will be quantified or just normally we'll consider individual risk, individual quantified risk only. We'll consider how will SIMOPS will do that.
SIMOPS. Okay, so SIMOPS, what it means is multiple activities happening at the same time. Yes. Are you with me, Vijay? Like we now with our moderator and us together, before you quantify what is needed, you need to identify. Yes, Mr. Saniwada?
Yes, yes.
So before you quantify, you need to identify. SIMOPS metrics, which now is in our screen, identifies which can go together. Are you with me?
Yes, yes.
So once you identify what can go together, the operational person, who is the area authority, certifies that or authorizes the operation to happen. Are you with me?
Yes.
So from the SIMOPS metrics, two activities can happen together. Operations says that please go ahead. And once that happens, the HSE section looks into maybe using a task risk assessment, maybe using a JSA, maybe doing proper simulations as such, quantifies it. You're with me? So that is the assessment. And once you quantify it, regards to the risk, we then will give the controls. You are with me,
yes.
Saniwada? So a SIMOPS, So the thing is like, I'm not sure if you were there yesterday, Mr. Ujjwal Ritvik, he made one statement. I'm sorry, we are talking about someone in his absence, but this is in favor of a general principle. Hazard identification is understanding the workflow. So your question was, how is it quantified? Is it quantified? I understand. But then first is identification. Once you identify which can go together, that one can go together. Operations have a go, no go principle to say, please go ahead. And anything that has to happen, which is not routine, yes, any non-routine thing has to go through a hazard analysis. And for hazard analysis to happen, you need to quantify it. So to answer your question, yes, it will be quantified, but to identify which needs to be quantified is what SIMOPS helps us.
Yeah, okay.
Mr. Mazharuddin, would you like to say something?
Is it audible? Is it audible? Is it audible?
Yes, very loud and clear.
Yeah, okay. Now I am using headset. Mr. Rahul, what is asking regarding the risk rating? That is my understanding. So when we are considering, usually we are considering only one activity. So suppose we are doing 2 activities at a time during the SIMOP, the risk rating definitely will be more.
Oh yes. So if 2 activities are together,
is it who was raising this question?
Mr. Saniwada, Vijay Saniwada.
So we had to consider 2 activities and we had to count and definitely the rating will be more.
Yeah, normally
the rating will be more. So we had to consider 2 because multi-level activities. Somebody is working up and somebody is working down. So there is risk rating will be more definitely.
Yeah, we are doing SIMOPS in Saudi actually, but actually during feed and during engineering stage, we don't have this operation also during the time. But during commissioning and engineering phase, the maybe risk will be more.
Yes.
During engineering phase and feed stage, risk for the simultaneous operation, the risk will be less compared to the engineering phase.
We have predefined. We have predefined. We have predefined the protocol. That means certain activities will be allowed, certain activities will not be allowed.
We will have discussion matrix will be there as per matrix. What are the MOPO? Multiple operations which are allowed, not allowed will be there. It will go as per the matrix. But what I'm asking Rahul is, during the production time, operation time, the risk will be more compared to the engineering phase during the construction phase and the commissioning time.
If I get you,
during that time, how we do the quantification of the allowed? What are the allowed jobs which are allowed? Like what you told, no, some jobs can be allowed, some jobs are not allowed. During allowed, what are the allowed jobs are there? Normally we do only task risk assessment only. Is there any normally, as I don't know the standards of the other world, what they do any quantification for the 2 different type of these major risk jobs? They do quantification for both combinedly.
Vijay Saniwada, now I get your question loud and clear. So you are, you have your experience in operations. You are asking from the engineering side, how can SIMOPS help in risk assessment? I'll give an example. In our project, we had an artificial island which had multiple operations. So it had initial production IP phase, it had drilling phase, it had wirelining phase, it had workover phase, and there was gas testing phase. And there was one timeline when all these phases were together.
Okay.
Are you with me, Vijay Saniwada?
Yes.
So then what happens is, from the engineering side itself, because from the engineering phase, we need to do a risk assessment on these to let them know what temporary controls need to be placed. For example, you have your IP phase going, which is initial production going, which are not proper pipelines and pipe racks, but then small sleepers where pipes are going. There is drilling happening wherein your rigs are moving. There is wirelining, testing, flaring, all happening at one point. So there, what happens? Your manpower increases. So when your manpower increases, what all you have to do? And these things you need to do from the starting of engineering. Why? Then you can budget for these things. Your question is very correct, and if it's not your question's fault, it's my fault if I'm not able to answer, but I'll try to now rephrase it because now I've understood. For operations, there is a protocol. Whereas in engineering, when multiple things happen together, in order to cost, we need to know the risk. And when it is handed over, when a particular operating plant is handed over to the authority, then the manual of permitted window is relatively lower. But then when it is in the engineering phase, when you have one side of the island is being dredged, but then in order for the market mechanism, they want to keep drilling and production, you will have a time when there is engineering happening, there is dredging happening, and there is production happening. So as consultants, why? Because this is a legal federal requirement that during an engineering phase, Mr. Saniwada, I think, is left. Is it? Okay.
Oh, he's there.
He's there? Oh, okay.
He's
so then
this video only.
Okay. So then what happens is that
I think he's not there.
Now, because he was having interruptions in his service.
Yes. No problem.
But
this is good. I think he's clear. That is why I put this also.
Yes. Thank you for that, Shaikh ji.
Thank you so much. And
I
think CUSAT would like to. Yes, Mr. Najas, you are saying something?
Well, let us have some networking. There are no members. And we would like to play one demo Kahoot also in between during the break.
Okay, all yours.
If
all
the
yours.
participants permit.
All yours.
Yeah. So
and I think actually I just lost battery, but the last message I got is that CUSAT would like to share something. Mr. Najas, I just lost my battery in this. Could you please check? They would like to show something here.
Yeah, they were showing that brochure, placement brochure.
Please. I'm handing over to you, Mr. Najas. Thank you, Mr. Rahul.
Pleasure is mine. Thank you. Najas,
you can have the networking.
Yes.
I will be back.
Yeah.
Sir. Sir, എല്ലാം പറഞ്ഞു അതുകൊണ്ട് എനിക്ക് നല്ല സുഖമായി. സാറിന് കോപ്പി അടിച്ച പോലെ ആയിപ്പോയി. പക്ഷെ സാർ ഇതാണ് നമ്മളെ തിങ്കിങ്ങിന്റെ ഗുണം. നമ്മളിപ്പോ നജാസ് സാർ ഞാനൊക്കെ നമ്മുടെ തിങ്കിങ്ങിന്റെ ഗുണമാണ്.
Excuse me, better speak in English. There are a lot of non-Malayalis are there.
Okay.
So
why Najas, you being there, you didn't teach them Malayalam? Very bad.
No, I don't know, because let us have an introduction from the participants.
Certainly.
Yeah, Sujit.
Renjith sir is here.
Sujit is there. Sujit, are you there?
Yeah, yes, Najas.
Yeah, Sujit, you can introduce.
Okay. What details I have to share about me in this one?
So I know personally you, but others.
Yeah. Okay. I completed my degree in 2007, and then I joined British Gas in Mumbai. I worked as a HSE engineer for 1 year. Then I switched my profession and I moved to well engineering. Right now I'm working as a well supervisor in Shell in Netherlands.
Oh wow, Netherlands, very nice.
Yeah.
I think this is the first guy shifted from safety to non-safety process.
No, it is great, no? I mean, well operations is very, very good.
Turn your camera so that I can get your face.
Okay.
I have something in my mind. You need to check whether
you are a CUSATian, is it, Sujit?
Yes, Rahul, I was your junior batch, 2007 pass out.
എനിക്ക് മനസ്സിലായി എനിക്ക് ഓർമ്മയുണ്ട് yes I remember. Good, very happy to see you. So you are in Netherlands now, is it?
Yes.
So it's like how many 4 days working in Netherlands? How does it happen?
No, here they have different systems. I mean, the rota which I am in, I have 2 week on and 2 week off schedule.
Okay.
And
I had come there once for one CFD modeling assessment into the CMR Institute, and we did some explosion modeling and all that a long time back, but it was long time back. I need to Renjith sir is here, or else I will ask you some things. But okay.
I also want to ask no problem, Rahul. If you are out,
അല്ല സാർ എങ്ങനെ പെൺപിള്ളേർക്ക് സൂപ്പർ ആണോ ചോദിക്കാൻ വിളിച്ചാ പെൺകുട്ടികളൊക്കെ നല്ലതുണ്ടോ അവിടെ എന്ന് ചോദിക്കാൻ വിളിച്ചേ ഇവൻ നല്ല സുന്ദർ കുട്ടികളായി നിൽക്കുന്നുണ്ട് അതുകൊണ്ടാ
okay. Yes, if you are good in CFT modeling,
yes sir.
ISR has approached us for some.
Okay sir.
Discuss it personally with you.
Certainly sir, certainly.
We are planning for a manned mission, so in that we need to do some CFT also.
Sure sir.
That's it. You can.
Excuse me, Mr. Said Fayaz, are you there? Mr. Said Fayaz?
Yes, sir.
You can share that brochure.
Okay, sir.
Rahul, actually it's going live in YouTube.
Oh, okay. I didn't know that. Right.
We are live streaming.
Okay.
So I think participants are only 63 right now. They went for a break. So Sujit,
so now are we taking a break or we are now continuing?
No, we will continue in the Zoom. Okay, when we will restart from 1 o'clock. So let's just have a networking.
So I have shared the link. In that link, you may get the publication from my side, and I will share the link of CUSAT and then the department also.
Yeah, sir. Sujit finished his intro and you finish your introduction, no? Currently, you are in.
It's not much. I mean, keep it simple. Just.
Yeah, better. So right now, where are you? Are you in Netherlands?
Netherlands.
Okay. Thanks for connecting. What's the time right now?
It's 11:45 now here.
11:45 morning or night?
Morning.
Okay.
We are 3.5 hours back from Indian time.
Okay, that's fine. Okay.
So Sujit, so now you are into well operations, is it? Proper, pure well operations. So
yes.
Mud control and the soapification and Christmas tree and choking and all that good things, is it?
Yeah, I would say if you just classify that as a well operations into different phases, like drilling is the first phase, then it comes to operations, then comes the well intervention, and then decommissioning or workover. So I would say I am a supervisor for well intervention and workover activities.
Oh wow! So all wirelining. So this is an onshore and offshore one.
I have been in both locations, offshore and onshore. In
Okay.
India, I was in offshore. Then for some time I was in Kazakhstan, which was a kind of land and sea
correct.
operations. And in here, when I joined in Netherlands, initially I was in offshore in North Sea. Then now I'm in back again on land.
So there also it's the same BOSIET itself. How does it happen?
We have a BOSIET, but it's not the tropical one. It's a cold climate one.
Yeah, that's what, because the temperature would be minus 50, minus 60.
Yes.
I mean, so even then the mud that is used would be different, no? I mean, for this particular temperature. And how do you, so do you have jacketed compressors and mud pumps and all that, steam jacketed ones?
Here, yes.
Okay, nice. Sujit, you please, because there's a lot of learning that I want to ask you.
Yeah, no problem.
Okay.
We can connect offline.
Yes.
Okay, Rahul, that's better. Right now, Ashok sir is there? Ashok Galapati.
Yes, I'm there.
Sir. We would like to provide a great gratitude to Mr. Ashok Galapati, who is behind our TSP accreditation. Our course is accredited to TSP, Transition Safety Professionals with the BCSP. So
yes, I know you got the ASP
because of you only, because of your support only, we got it. We still remember the meeting with the BSSP professional body members at Delhi.
Yeah,
during the conference.
Jiman, his name is, yes.
Thank you, Ashok sir. I think Jinad met you there and then we discussed.
Jinas, yes.
Jinad is still here.
If I had a meet on that, otherwise I will also be there on that day, right? Then we could meet.
Thank you. It's our pleasure, sir. Our people are getting benefit of ASP waiver is that because I know that we have got a good capabilities and we wanted to demonstrate that we succeeded in that. Yes.
Yeah, within short time we didn't expect that. Within short time we will get the TSP accreditation.
True.
Thanks once again for.
Sure.
Can you tell a few words regarding some of?
Yeah, I mean, I've been. This is I posted in the chat box that CUSAT will be our chapter's education partner. Mr. Safdar and Mr. Shaikh, they are very instrumental in connecting this particular collaboration, and I'm sure this collaboration will go a long way. In fact, and I was thinking why we are not traced this diamond. Mr. Rahul is an excellent presenter and excellent knowledge he has shared today. I was wondering, Mr. Rahul is in Middle East and how ASSP Kuwait did not trace him, But finally, thanks to Najas for connecting with Mr. Rahul. And yesterday also I was listening to his presentation, but I had another meeting. That's why I could leave. I had to leave earlier. But it's a good, Mr. Rahul. Thank you for sharing your knowledge today and yesterday. Yes.
Pleasure is mine, Ashokji. Thank you for your kind words. Knowledge increases by sharing. So
exactly, I do believe in that. Yes, absolutely.
Thanks to Najas who gave the opportunity. Thanks to yourself and the rest of the panel people who agreed to accept me as one of the speakers. I am indeed grateful. Thank you.
Other members can come forward for the introduction at least. Please, one by one, we'll admit.
Yeah, I am Sridhar myself. Am I audible?
Yeah, it's audible.
Yeah, I am Sridhar, working as a field HSC advisor in Kuwait Drilling Company, Kuwait. Yeah, presently I am on field only, but fortunately I have a Zoom meeting, right? That's the reason I'm somehow attending this meeting. And yesterday also I attended this PSM. But okay, almost all as a field HSC advisor, I completed in KDC 8 years. So what I feel this meetings is, I want to say thanks to Rahul sir. So was such a nice presentation he given. The thing is, the way of speaking is impressed. So literally, I'm busy with now the casing jobs is going on. So I want to move there and come back. But my intention is always why I'm missing too much. So really, the great job done by the Rahul, Mr. Rahul sir, and thank you. Thanks a lot, all the team members, those who are conducting these meetings, webinar. Thanks from my side. Thank you.
Thank you, Sridharji. Thank you very much. It is these positive affirmations from yourself which inspires people like myself to come forward as well. I am at your depth for your kind words. Thank you, Sridharji.
Okay, actually we have a quiz section during the at the end of the technical sections. So we are using the platform Kahoot for the quiz. So in order to familiarization, we are having some demos. So are you ready, guys?
Yes.
Yeah.
So I'm just handing the mic to Mr. Ramana. He will give you the short guidelines for how we had to play Kahoot.
Thank you, Najaji. Good afternoon, all, and welcome back after the break. At the end of this session, we are going to conduct a quiz on Kahoot platform. So we are going to have a demo right now. Okay, for this, what we need to do is, if you are using the same device, actually we are experiencing some difficulties, but anyway, this is a test one. Somebody told that we can able to do with the same system itself, no need of second device. We were thinking that we need two devices, one to get the display and another one to operate, participate in the quiz. Now, this one is the integrated one, playing with Zoom, playing in Kahoot, playing in Zoom. Okay, so just log into kahoot.it and use this pin. You can use Kahoot downloaded from Play Store, or you can directly put kahoot.it in any of the browser and use this pin 8473354. Okay, you can use any browser or app, kahoot.it app, and put this pin 8473354. Once everyone joins, we'll start playing the game, quiz game. If you have any difficulties, please ask me, or some others who are very experts in our Ashokji is there here. He can also guide me. He has guided me earlier, and I played a game, but this is the second time integrated with Zoom. Earlier, I played in a different way. This is the integrated one with the Zoom. We'll see how it works.
Good, Ramana. You're doing great.
Thank you, sir.
Better put your name and company name or college name as nickname. So that this is the only demo. There will not be prizes for this one. The actual quiz will be played at the end of this section in the evening. Meanwhile, you can continue the networking.
It's already 1 o'clock. Shall we wait for a few minutes?
Yeah, we will wait for a few minutes. Let us continue this one. So those who are coming at 1 o'clock after the break, let them also join the Kahoot demo, so that they can also give a chance to play at the end of the section. So we'll start after the demo. That time we will adjust while running.
Okay, okay.
Because
Still,
most of the
yeah,
most of the people are not much familiar with this one.
Yes, okay.
So we'll continue the networking. So those who are come forward with your introduction, please.
Okay, if those who are facing any issues, inform us.
It's very simple. Okay, you have to log in kahoot.it from your laptop or your mobile browser, Google or any browser you can use. It will directly go to a web page, and only thing, you enter the game pin 8473354, then put the nickname. So it's very simple. No need to download any app as of now. Mr. Rajesh is there, Rajesh Pudurthi. Rajesh sir, can you have an introduction?
Yes, good afternoon, Majas. Good afternoon, everyone. My name is Rajesh Pundriti. It's happy to know that the ASSP Kuwait chapter and CUSAT is jointly making a platform like this. Actually, I did my BTech from CUSAT only. I'm the first batch. We could proudly say we are the first batch student. And I've taken that in 2004 I came in Kuwait. So my first job was in Reliance Jamnagar Refinery, and in 2004 I came to Kuwait. And I have been associating at that time, that in 2004, I know many co-founders of the ASSP Kuwait chapter. That time it was American Society of Safety Engineers. Now it became to ASSP. So I know the co-founder, Mr. Ujjal and Ashok ji.
Thank you, Rajesh. Thank you, Rajesh,
Yeah.
for joining.
Yeah.
You have been hiding somewhere, but CUSAT team has brought you back. Welcome back on board.
Because it's yeah, we worked together in 2004. I was the head of the publication head committee, and
Very good,
since
yeah.
I moved to the rotation in oil and gas industry, now I work for Kuwait Oil Company in deep drilling. Now I work for rotation. That's why I could not attend that many of the ASSP sessions and everything. But it's in the COVID situations make that session online. So it's gotten, and right now I'm in the rig site only. In the North Kuwait. Okay,
I appreciate your effort joining us from.
We can see your uniform, still in uniform.
Yeah. So
okay, Najas, let us catch on time.
Renjith sir is there.
Hi. How are you, Rajesh?
No, Rajesh, continue. I'm just doing a pre-planning. Hello, Rajesh.
Okay.
I'm just lining up for the further plan.
Yeah, there's minor change. There's minor change in the moderator of Mr. Dilip.
Okay, no problem. So who will be replacing?
Mr. Ramana will update you in message.
Yeah, okay. Send me that and I will take it. My permission.
Yeah.
Okay. Thank you. Yeah.
Mr. Rajesh.
Okay. Yeah, that's all from my side. Anyway, happy to know many faces. My juniors, they are presenting very good presentations and everything. And I just really missed out our Sir Renjith sir presentation. Anyway, I'll track it on later through YouTube. Okay.
Record
that's all from my side.
available.
Okay, fine. Okay, that's great. Anyway, we will keep in touch through online sessions. This is a right opportunity for us who work in the field. Thank you, everyone.
Thank you.
Thank you,
Mr.
Rajesh.
Rajesh.
Thank you, Rajesh, for joining us despite your busy rotational schedule. This is the beauty of networking. Thank you, dear. Thank you. Yes, Najas,
Yeah,
you want to play this?
Yeah, we will play one demo because.
No problem. Go ahead. Go ahead. Run it quickly so people will understand. Okay.
Yeah, let them join some. We are waiting for some more people to get an opportunity to play because
Yeah,
this is
maybe
only a demo.
that's why if they are sorry. Yeah, it is okay. I thought mic is not off. Okay, many are leaving automatically because when they are idle, it logs off automatically. That's why we have to tell them to log in again because we can't keep like that for long time. Dear all, please check again. Kahoot has logged off from your devices. If you are online, okay. Sometimes if it is your screen is off, it's logging off automatically. Okay, please check whether you are online or not. Now we are
Anyway, we will start within 2 minutes. So it's only a demo. 25 people are there total. It's very simple. Okay. So join at any browser using your mobile or a laptop or a PC. To go to www.kahoot.it and enter the game pin 8473354 and put your nickname. Kuwait people are mostly familiar with the Kahoot that we are using always, but those who are from CUSAT or India, they are not much familiar. That's why we are putting some demo on that one. So,
shall we start?
Yeah, better, Ramanaji. Start.
Okay, this is for only demo. It's not related to any safety. It's related to ASSP KC. Okay, we'll just go on with this.
The question is, when was ASSP chapter established in Kuwait? So if you put the right answer, for example, 2000, put the blue diamond. So if it is 2001, you can click a red one, triangle.
How do we know our answer has been registered? Okay.
Yes,
this will come. It will come. So you can see Mubarak. Then
the score depends on the
time,
like speed. Yeah, time.
That minimum speed who clicked. It's like a KBC. Questions will be displayed. That with minimum time, we have to answer. Who is answering in minimum time will be the winner. So we are going to the next question. Who is the founding chairman of ASSP Kuwait chapter?
No, sir. Don't look for the answers. Actually, correct answers. It is only for demo. You click on something. Okay, I'm just skipping. I don't want to waste that much time. Okay, to get familiar only. Okay, like this, if somebody answers in a quicker time, he will move ahead. Okay, earlier one will go down. Like it depends on time frame. If you miss three, 4 questions also, you may be the winner if you answer next questions.
So those who are answering fast, minimum time will come up.
Some R is there. It's not me, Ramana. Okay, somebody else.
No.
Okay. Only 7 questions. After that, we'll close it. if you are facing any issues, please tell me. We'll stop it and we'll explain further and we'll move forward. I hope everyone is playing, right?
Can you please give me the pin?
Oh, pin you want? No. We are now we can't join. It's already at the end of the stage. Only one question left.
Weekly. So those who answer fast in minimum time will come first. So Sri was not there in the list, initial list, top 5. Okay.
Hello.
Okay.
வணக்கம் வணக்கம் என்ன எப்படி இருக்கீங்க பாப்பா எப்படி இருக்கறா மறந்துட்டீங்களே
மிஸ்டர் சேகர்ஜி
இல்ல 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 நீங்க மறந்துட்டீங்க பரவாயில்ல நல்லா இருந்தா எனக்கு சந்தோஷம் நீங்க நல்லா
Okay, now finished. This is the podium. How the winners will be displayed automatically. You can see now. I'll play the podium again because earlier I didn't put the sound.
We know the scores, how many questions he answered, he or she answered with the total points.
Okay. Oh, that's okay. Shall we move to the next? Sorry. Safdarji, are you around?
Yes, I'm there.
Okay, just a minute.
So this will be technical session 3, which Mr. Madhavan will be taking, right? Ramana?
Yes. Okay, Safdarji, you can proceed.
Okay. Welcome back after break. I hope you all have had a good time before the break, and we will be having continuation of the same energy, same level of participation, and we will be having too much to take away with the imminent speaker and networking sessions. So moving to technical session 3, I'm myself Safdar Ali Khan, Secretary and Chartered Certified Safety Professional, and for moderator of this event. And we have a speaker today, Mr. Dilip Madhavan. He is working as a manager fire, Petronet LNG, and his topic is safety performance indicator based on OSHA. Profile of Mr. Dilip Madhavan. He is BTech in Safety and Fire Engineering from CUSAT. He is also having a NEBOSH and IOS certificate. He has undergone through lead auditor OSHA 18001, and he is a graduate member of Institute of Fire Engineers UK. He had industrial experience of 15 years in manufacturing and gas sector with extended expertise in field of fire safety management. In course of his career, he has witnessed and involved in major rescue operation in incidents such as Balkwood chimney collapse in 2009, Column explosive blast 2016, hot mill spill, spontaneous combustion of coal and electrical fires. His current responsibility include ensuring safety in LNG terminal through risk assessment, fire prevention, inspection, training, emergency response, and continual improvement of safety and fire management system. So we are fortunate to have Mr. Dilip Madhavan, who has experienced some live major rescue operations. So it is really great to learn from this gentleman. Welcome, Mr. Dilip Madhavan.
Hello, sir. Am I audible?
Yes, dear.
Yeah. So shall I share the screen?
Yes, sir.
Okay, I believe I am visible too.
Yes, you are visible there. Yes, your screen is also seen. Yeah.
Okay, thank you. And it's always a pleasure to associate in some webinars where knowledge transfer happens.
Very good. Mr. Dilip, remember that we are having time of 25 minutes from now.
That's okay,
including 5 minutes for question session.
No
all participants are encouraged to post their questions on chat box. We will take it at the time permits. Now, floor is yours, Mr. Dilip Madhavan.
Thank you. Thank you. With great gratitude and thanks to ASSP, CUSAT, my seniors, my faculty, and all the colleagues and participants there, let's directly come to the topic for the day, which is safety performance indicators. So as Sri Safdar told about the introduction, in fact, I'm a proud member of CUSAT who passed out in 2007. I'm junior to Mr. Rahul. Hi, Rahul. And Dr. Renjith and Rahul had given some amount of technical knowledge through their talks. So what we'll be seeing here today is a little bit non-technical, but we'll try to see how process safety can fit in into the safety performance indicators. Now, as many of you would know, there are some times in our career where we would like to take a pause and go back to the fundamentals, right? The basics. So be assured that this presentation which I'm having today will take you back to some of the fundamentals and the core basics which a safety professional should never forget and should always keep in mind. With this, let's have a small food for thought. So what Campbell Institute, for those who have seen it, please ignore. For others who have not seen this statement, please take care about this statement. Please listen to it very carefully. What Campbell Institute has told is today the EHS practitioners continue to rely on injury rates, absenteeism, and other lagging indices or lagging metrics, despite the growing acceptance of the fact that these failure-focused measures are ineffective in driving continuous improvement efforts. So the need for leading indicator and the focus and the focus on the leading indicators should be extremely higher than what is being followed right now across the world, that is being focused on the failure focused measures like the lagging indicators. Now this is what we are going to talk for today. We'll have a small introduction to what is leading and lagging indicators and some characteristics of effective leading indicators, some smart examples of good leading indicators, and we'll conclude it with a small action plan. Now, across the globe and across many industries, at least in India, the commonly used safety indicators in industry are very simple. Safety observations, that is unsafe act, unsafe conditions, plus near misses are commonly clubbed as the leading indicator. All the injury cases and other incidents, whether it be a lost time injury, it be a fatality, a first aid case, or a medical treatment case, everything is a lagging indicator. So this is the general idea which we have about leading and lagging indicator. Now there is something called a KPI, which is a key performance indicator, and a commonly used guideline for KPI in percentages, the number of lagging indicators divided by the number of leading indicators into 100. This gives a percentage, and the target of KPI, if it is kept within 15%, is globally accepted to be a good safety performance in the industry. This is how many of the industries follow. There may be better systems. I don't take this as a final conclusion, but yes, this is more or less followed everywhere across the globe. So we talked about unsafe act and unsafe conditions. Now, these pictures from the internet, you would have seen it and you would have trained people on this, and you would yourself have used it in many of your presentations, that what we see here is an unsafe condition. A forklift with a lifted load is an unsafe condition. That is what we are taught. And the unsafe act is when a human being is underneath, a person is underneath the load. So that is supposed to be an unsafe act. So think it this way, is in the unsafe condition has also been created because of an unsafe act? Yes, the unsafe condition here has been created due to an unsafe act by the forklift operator in keeping the load in a raised condition. So that is the unsafe act there, right? So there is a hidden unsafe act because of which there was an unsafe condition created. Similarly, you see the live example of a motorcyclist riding in a high speed. This is a clear case of unsafe act. There's no doubt about it. There's no unsafe condition here. There's only an unsafe act. The fire extinguisher is in blocked condition. This is commonly categorized as an unsafe condition, right? But then there's an unsafe act behind it. What is unsafe act? A person has kept a drum because of which the extinguisher is obstructed. The motorcycle is in an unsafe condition. The condition of the motorcycle is not very good. But then, if you put it in this way, that lack of periodic maintenance of the motorcycle has made this unsafe condition. So again, you go back to the unsafe act of the person who has owned this bike or who is responsible for maintaining this motorcycle. Very real life examples of an open pit or a drain. Again, we categorize normally as an unsafe condition, but there is an unsafe act behind it. The person has kept it open. So now what I mean to say is, even though you have safety observations under the category of unsafe acts and unsafe conditions, predominantly everything is normally an unsafe act. That is what an industry normally categorizes into. So yesterday we had a very good talk from Mr. Rahul on there is human. So again, an eye-opening talk. So most of the pro safety incidents are also tried to be categorized into some of the unsafe act of the person because of which that incident has happened. So there is a human factor involved everywhere, right? So that human element and the emotional element has always to be kept in place. Going forward, these are very fundamental examples and definitions of leading indicator. It's again pure English. The leading indicators are proactive, preventive, predictive measures that provide information about the safety performance in your industry. So leading indicator, an example, a very simple example of a leading indicator is the amount of time it takes to respond to a safety hazard report. Now, it looks very simple, right? The amount of time it takes to respond to a safety hazard report. One of your worker reports a safety hazard that there is a corrosive support structure for a pipeline. And because of high corrosion, the structure may fail and the pipeline may fall down, something of that sort. And then you have a system, some people, some organizations use an online system of reporting a hazard. And there is a system in place where the area owner or the manager of that particular area or in charge of that area has to accept that hazard and he has to take a remedy action. So the amount of time it takes to respond to that safety hazard report is a leading indicator. It shows how involved are we into safety. Now, what they measure, the leading indicators measure events which lead up to the injuries and illness and other incidents. So it leads, leading indicators, as the name indicates, it leads to what? It leads to some indications whether something bad is going to happen or not. Very good, right? It's a very good term and very important to adopt and follow. Now, direct opposite is a lagging indicator. What is lagging indicator? These are traditional safety matrices which are used to indicate the progress towards compliance with the safety rules. A very real example is frequency rate. You have something called LTIFR. In India, they call it LTIFR. I don't know. OSHA call it total recordable injury frequency, TRIFR. So there are different terminologies. So these frequency rates, the number of injuries, the absenteeism, the man days lost, number of illness, number of occupational health issues or occupational diseases. So these figures are lagging indicators. Why they are called lagging? They actually come into play after an incident or a thing or a consequences happened. So they don't actually lead towards something safe. They actually give us an outline or a performance evaluation of what has happened. To give more clarity on this, you see the bottom two portions of this pyramid, the near misses and at-risk behaviors. In terms of behavior-based safety, people talk about at-risk behaviors. So near misses, at-risk behaviors or unsafe acts, whatever name you call it, those are leading indicators. And lagging indicators, there are many examples: recordable injuries, man days lost, severity rates, workman compensation is a lagging indicator, of course. Fatality is a lagging indicator. No, having a fatality doesn't give you a leading opinion. It is actually something very bad has happened, and then it's a lagging indicator. More clarity on this safety incident. Before occurrence of a safety incident, there are proactive indicators like the leading indicators. After a safety incident has occurred, there are reactive indicators like lagging indicators. So why we are talking so much on the leading indicators? Why the focus is on the leading indicators? So leading indicators help in preventing the worker fatalities. Of course, how we will see in further slides, it will prevent worker fatalities and injuries and illness if it is well recorded, documented, and tracked. Management can demonstrate their commitment to maintain a socially responsible workplace by using the leading indicators. And also it brings in a lot of savings. Leading indicators can bring in a lot of direct savings by identifying and fixing the hazards in a very early time. So by now, you know that a lagging indicator can measure failure, whereas a leading indicator can measure the performance. So what do we actually want to measure? We have to measure a performance. As a safety professional, our measurement scale shall be more focused on the performance rather than the failure. Again, have a thought inside yourself. What are you actually doing as a safety professional in your own organization? Are you measuring only the failures? Are you keeping a track of the first aid cases, the accident records, the absenteeism? Is that what you actually do? Are you doing an analysis of the failures? Or actually you do an analysis of the performance? So this is what you have to rethink and retrospect. Another food for thought. Now, many of the organizations, I believe most of the abroad organizations, as well as in India these days, have a celebratory, you should celebrate safety. I'm not against celebrating safety, but have a very highly celebratory modes that, these are some very common statements which you see. My organization has very low injury or accident rates. We have achieved 50 million, 100 million accident-free man hours or man days, whatever. There's not been a single fatality. Yeah, of course, during project, we have a couple of fatality, but that's project. It is supposed to have some kind of hazard. But in operation side, we don't have a fatality. Every worker in the industry, in my industry, is aware about safety. So these are some thoughts and some statements which we come across in highly process-oriented and especially private organizations. But are these indicators of a perfect safety culture? That is what we have to think about. My submission is not necessarily. And I could be a little controversial here because all the 4 statements which you are seeing here, a low injury rate, achieving -million accident-free man days, not having a single fatality, every worker is aware about safety. Yes, these are all very good indicators. These may lead to a good safety culture, but not necessarily. Now, further drilling into an effective leading indicator, you all are aware of the term SMART: specific, measurable, achievable, reasonable, and time bound. So we don't take much time in this. So any leading indicator has to be specific, which means it has to provide specifics for what action you're going to take. It should be measurable. It should be presented as the leading indicator should be presented as a number, a rate, a percentage, or something, so that it can be measured. It should be achievable, it should be reasonable, and it should be time bound. So a SMART applies here also. What is a live example of a good leading indicator? This reference is directly from the OSHA. This is not something which I've taken from my mind or my experience. So I thank OSHA for this bringing out this paper. My only role is to share it with the people out here. So one of the examples, a very simple example, is to obtain the 100% or 97% attendance, worker attendance at monthly safety meetings. So the goal is achieving 97 worker attendance rate at monthly safety meetings. Now, whether this is a SMART example, let's see. Workers will attend a safety meeting every month. So this is a good example, right? So you give a statement that 97% of worker attendance is my target in a monthly safety meeting, is of course the SMART statement because it is specific. 97% of a worker has to attend the meeting. Now, it also says that there is accountability here, right? There's an accountability. The workers have to attend the safety meeting. So it is a very good accountable statement that workers have to attend. It is reasonable because we are not asking for 100% workers to attend the safety meeting. Yes, if we have 90%, 97% attendance, it is fine. It's a reasonable target, and you can track. It should also be time bound and it should be tracked also. So you can track the attendance because you have already set a target of 97%. So this is a very, very simple and a SMART example of a leading indicator. What we normally do in an industry is to have a safety meeting or a quarterly safety committee meeting, and then we read out some agenda points, and then people come and attend it, and there are some minutes prepared, and there are some points discussed, and an action plan is made to attend to those points in the safety meeting. But are we ensuring the 97% attendance in that meeting? Are we ensuring that the meeting has achieved the objectives for which the meeting has been planned for? And have we actually given an objective to the workers that this meeting is going to give you this outcome? So if this kind of the jargons or the English terms are being tracked quantifiably, so this will give you a better representation of the leading indicator in your organization. That was a very, very simple example which we talked about, but let's talk about some very specific examples of leading indicators. When we talk of management leadership, let's see this example, very wonderful example here. The percentage of managers and supervisors who attend mandatory safety and health training for workers. Now, what we talk here is the percentage of managers and supervisors who attend the mandatory safety and health training for workers. So we have health and safety training for workers. Every industry has that. Now we have a mandate that maybe for our industry, I come from an LNG industry, and we have a mandatory safety and fire safety training on every Friday. Every Friday of the day is scheduled to be a training day, and we have all workers and management staff to attend that training. So more or less what we see is all the workers and mostly the junior management come and attend the training. And for the senior and the middle management, we have to have a push. At the last, you have all these senior guys coming up and attending the training. This was the case a few years back. Now it is slightly changed. So now you can keep a track. Your leading indicator should have some amount of the target shall be some amount of percentage of managers and supervisors who has to attend this training, not the worker alone. This is another interesting example. The average score on the survey questions related to the workers' perception of management commitment. No, some industries and some organizations follow something called a safety perception survey. This has gained a lot of importance of late now. So people talking about behavioral safety, behavioral science, and safety perceptions. This has got a lot of importance of late. So if you see the average score of the survey questions related to the workers' perception, this can give a very clear picture of how people perceive the organization's commitment towards health and safety. The number of work reported hazards and concerns for which employers has initiated the corrective action within 48 hours. See, such a wonderful leading indicator. No, you have told the example of a worker reporting a specific unsafe condition, and it goes to his manager or maybe a safety guy, and then they have to address that issue or at least attend to that issue or listen to the issue. So if that is happening within this 48-hour time, it gives a very good indication of how your safety culture is. Many organizations have safety line item for budget. Of course, we have good budgets. Good companies always keep a certain percentage for safety budget. But the number of safety related line items in budget and the percentage of these fully funded every year can be a good leading indicator. Someone has to track it. It is us who has to take up this responsibility. So that was about management leadership. And if you talk about worker participation, we can have similar leading indicators like, for example, number of workers asked for feedback on good safety goals ahead of the safety meeting. You have a safety meeting, ahead of that you ask questions from the workers, and number of workers who have been asked for the feedback. This can give you a good picture of a leading indicator. Number of workers who have involved deeply in developing safety procedures. No? We still have issues in this part of the world of not involving workers proactively and religiously into SOPs. SOPs are always done at the office level by engineers. Sometimes the manager gives us comments, but the workers are supposed to follow the SOP. They are not asked to participate in creating the SOP. So the number of workers involved in developing procedures can give you a good idea of how the safety culture is for that organization. The number of workers participating in toolbox talks can be easily tracked. Number of workers participating in the injury accident investigations can also be a good leading indicator. Now we come to the core role of a safety engineer, which is hazard identification and assessment. If you take the case of hazard identification and assessment, the frequency at which the preventive equipment maintenance tasks are initiated and completed on schedule, this can be a good leading indicator. Now read very carefully. The frequency at which the equipment maintenance tasks are initiated and completed within the schedule is a good leading indicator. This has something more to do with process safety. We'll come to that in a subsequent slide. The number of hours passed after an incident before an investigation started. See, such a simple trackable leading indicator, but how many of us track that? The number of hours which have passed after an incident before an investigation is started. It's a very good leading indicator. The number of hours passed after an incident before an investigation is completed, that also can be tracked, right? See, the percentage of daily, weekly, monthly inspections completed, the percentage inspections that include a follow-up inspection. So these are all examples of good indicators in terms of hazard identification. Come to education and training. Now there are good indicators like number of trainings provided to the workers on hazard recognition and control as compared to the worker attendance rate at these trainings. So we have a comparison here, right? The number of trainings provided to the workers on hazard recognition compared to the workers attendance rate. Match these and see and track. Percentage of workers receiving mandatory training on schedule, percentage of incident investigations listing insufficient number of workers trained, and percentage of improvement on post-training assessment scores over pre-training assessment scores. So how many of us do that? You have a training program for example, an LPG safety. Before the training program, we give a pre-training assessment material. They answer a few questions based on their knowledge on the topic. And then after the training, you give the same set of questions plus something extra as a part of the post training. And then you check. And so the percentage of improvement on the pre and the post can be tracked as a good leading indicator. So whatever we talked till now had to do something with safety, but more of the procedural side or administrative side. So when it comes to process safety, Now you have these lagging indicators, right? The LOCs, the loss of containment, major process safety incident. These are all lagging indicators in process safety. Can we have some leading indicators in process safety as well? Let's see. So these are some things which I could jot down. The percentage of inspections of safety critical plant equipment due for inspection and completed on time. So here on process safety, what we ask is the percentage of inspections of the safety critical equipment due for inspection and completed on time. What are the safety critical equipment? Could be a relief valve, could be a bursting disc, could be a deluge valve or a sprinkler system. It could be the fire and gas detection system. It could be an EDG diesel generator which serves the emergency. What else could it be? It could be a flexible hose which takes care of the settlement issues in your plant. So these are some examples of the safety critical equipment. So whether the inspections of these equipment are done on time, are inspected on time and completed on time, could be a good indicator on process safety. Percentage inspections without non-conformities, great trackable safety indicators. As percentage of safety critical equipment which performs to the specification when inspected and tested. You have, for example, you test something called a gas detector. A field gas detector is tested using methane gas. So there is a particular response time at which a certain amount of gas has to, at a certain area, has to reach that detector. It has to perform, or it has to indicate, or it has to give the intended result for which it is kept there. That is, the gas detector has to give an alarm. And the gas detector, sometimes if it is clubbed with a suppression system like a deluge system or a spray system or a sprinkler system, it has to activate that system. So how many of those critical equipment has actually performed to the intention to which it is designed for? It is a good example of a leading indicator in process safety. We do this, right? Many of the process safety engineers here are already aware of these things. But then the analysis and the tracking and the record of these kind of indicators may or may not be done. Okay. Percentage of work permits issued in which the hazards and control measures are adequately specified. These are very good leading indicators. How? I'll give you an example. Today morning, I had to issue a permit for a hot job which was at an elevation. So we have something called a shell and tube vaporizer, which actually vaporizes the liquefied natural gas into a natural gas by contact with ethylene glycol. It's a small process, kind of a heat exchanger. So there are different levels in the shell and tube vaporizer, and each level has a platform where people can actually stand and work and mobilize themselves between each floor to check the parts and the equipments and the pipelines and the fire system. So there was a hot job which happened at the 7th level of the shell and tube vaporizer, and as per the hot job permit or the hot work permit, one of the criteria is to keep the combustibles away, 35 feet away from the area of spark. One other condition is to have a firefighter as a standby, as a fire watch. So these conditions are all satisfied. The permit is issued by the issuer, it is well received by the receiver, toolbox is given. At the site, we go and see that a fireman is standing at the 7th level. There's a welder who does a welding job. He has to actually cut a pipeline and weld a different piece, pull piece, and join it. The welding work is happening. There is an extinguisher nearby. A fire hose reel is laid out to suppress any small fires which happens. A DCP extinguisher is in place. A fireman is also in place. But the interesting part is the spark which falls from the 7th level is actually reaching not directly below. Because of the wind, it gets carried away to another equipment which is far away, somewhere around 20 meters away from the equipment which is on which the welding is being done. So here it is very important to have an area barrication and the fire watch at the bottom level also, at the ground level. So that risk, has it been identified, is a big question there. So it's a normal hot job. The site is seen and seen by the issuer and the receiver. The safety engineer is in place. He goes and checks the site. Everyone signs the permit. Everything is clear. When the work happens, this is what is actually happening. The spark at the 7th level, somewhere around 15 to 18 meters in height, the spark, due to the wind, it gets carried to a different place. And that place is full of oil and some combustibles and those sort of things. So are the control measures adequate in such kind of permits? So you can have a percentage of work permits tracked in which actually the risk and the control measures are identified. So these are some examples of Good, Prof. So let's, for those who don't know about the Caterpillar story, Caterpillar, Caterpillar, right? So in order to create zero safety incident performance, the company used something called the Safety Strategic Improvement Process, SIP. So what did SIP include? These are all English, but these were actually termed and divided into different objectives and quantified. So the strategic improvement process of Caterpillar include assessing the culture using one-on-one interviews and a safety perception survey. So they did a lot of work on this one-on-one interviews with their employees on the safety perceptions. They built a plan, and by reporting and analyzing the assessment results, they trained the safety steering team and agreed on a strategic plan. And they developed the process through which the safety culture excellence workshops happened to form a continued improvement. They did small pilot improvement projects on this, started implementing newer processes on this, and checked the efficacy and went back to the process once again. So such a brilliant vision which through which safety could be enhanced. No, Caterpillar at some time, like in the early 2000s, 2003, they had accident rates like something like 20,000 in a year, 20,000 injuries in a year. These kind of injury rates in such a high quality process-oriented organization were something which actually made them to analyze and go back and check whether what they're doing is actually correct or can they do something better. So they gave it a term called strategic improvement process, SIP. And you see this wonderful statement by the manager of Caterpillar Safety Services. We address safety the same way we address quality. These are the things which are being talked about in India also, but then how much it is put into implementation is a big question. Sorry, I'm not degrading or talking something low about my own nation, but this is how it is, right? You have limitations of the budget, you have limitations about the manpower, the competency, but what as safety engineers we should do is to elevate, and at least the next generation and the generation after that, to improve their concepts, and the process and the thought process about safety should be totally different than what our earlier generations were thinking about. Let's conclude with a small action plan. You can go back to your organization, identify your top problem areas. You can talk with workers on the areas you could improve. The workers, the ground level workers, give you the best plan which is possible to attend to the safety management culture. You can sit in office, you can develop procedures, well and good, but the field work is really important to understand the practical solutions. Set safety goals for yourself. It can be a good safety objective. Sometimes objectives are just for the IMS implementation. We know that, but try setting smart safety goals. Try setting smart leading indicators to achieve the goals. Collect the data, periodically review it. So what we have to remember is that just 1 or 2 smart leading indicators can make a big positive impact on the safety culture of the organization. So with these small words, I humbly submit my presentation here. I conclude it, and I thank once again the ASSP and CUSAT for organizing this joint webinar knowledge transfer program. And I wish all of you safe years ahead. Whatever doubts which you had in mind on this topic can be posted. I'm open to questions. Whichever I know, I can answer. And wherever I need some reference, definitely please allow me to get back to you after I refer. Thank you once again.
Thank you, Mr. Dilip Madhavan. So far, I don't see any questions are there. If there is a question, I'll post it to you, sure. But you have made a very exemplary example with the mixing general industry and process industry in very simplified way, which is a need of our right now, and we have to see in a different perspective what else better as a safety professional can do. So definitely all participant will be taking some message for their own action item. Thank you, dear Dilip Madhavan, for giving your excellent presentation and engaging audience. Right now, I don't see any questions are there. If there is question, I will definitely check with you.
Please
So,
do. I'll be available. Yeah, across.
That's fine. Thank you. Thank you, Mr. Dilip Madhavan. Now let us move to another session. Meanwhile, all participants are encouraged to post the question leading to Mr. Dilip Madhavan safety performance indicator based on OSHA. Okay, these are some of these remarks for Mr. Dilip. Padmanabhan Veluswamy, congratulations, well-structured presentation. This all takes a very positive notes on the speaker. And there is also saying, Anaga Ravindran, thank you, Dilip sir. So these are some of these very commendable messages for our speaker today. Let us move to another session. And this session will be benefit for ASSP, American Society of Safety Professional Student Membership. Now, those who are in university right now, CUSAT, who are still continuing their study for bachelor or master's, they will be considered as a student. So, and the speaker for this, Mr. Yunus Kanath, he is a membership development committee head for American Society of Kuwait chapter head. So the whole presentation will take you minimum 15 minutes. So over to you, Mr. Yunus. If you have any question, query, please post your on chat box, or you can raise your hand. We'll stop there and we'll reply you back. So over to you, Mr. Yunus Kanaat.
Yeah. Good afternoon, Safdarji.
Good afternoon, whole audience. Yeah.
I'm great pleasure to stand here on behalf of ASSP Membership Development Committee. I know the challenges are here in this is the first time we are conducting with collaboration CUSAT. It is very happy moment. I have to tell something in ASSP. The ASSP chapter communities provide accessible face-to-face and virtual opportunities for ASSP members to become better safety professionals. ASSP is a global association for occupational safety and health professionals. For more than 100 years, we have provided education, standards, development, advocacy, and a professional community to support the advancement of our members and the professional as a whole. Our members are dedicated to certain safe work environment by preventing workplace fatalities, injuries, and illness. Sound safety practicals are both socially and responsible and good business, leading to increased productivity, a better reputation, and higher employee satisfaction. I have to tell something benefits of student ASSP membership. The student member, if you are a student pursuing an undergraduate or advanced safety related degree student, membership is for you. Students dues $15 per year and include one free practice specialty or common interest group. You know, the Professional Development Conference PDC next year we are conducting. Actually, PDC offers you a great opportunity to gain top quality safety education from leaders in the OSH industry, network with thousands of other OSH professionals, and experience firsthand the latest product and service innovations in the field. You will also find professional and personal inspiration in our keynote presentations delivered by the thought-provoking and engaging speakers. Our student members have access to wide array of benefits that ease the transitions from students to practicing safety professional following graduation. Your local in your area, learn about internship and employment opportunities to find a mentor. You can prepare your career, meet potential employers, participate in mock interviews, resume critiques, and roundtable discussions with the experienced safety professionals at our Future Safety Leaders Conference. Access virtual communities. Receive complimentary access to a free practice, specialty, and common interest group designated to provide education in your areas of interest. Free webinars. The polish your soft skills and learn the latest OSHA trends with complimentary access to all ASSP webinars. Access career resources, including job and internship posting through the ASSP Career Center. Continue to succeed. ASSP offers a free year full membership as a graduation gift to help you easily transition from your academic life into your professional career. Other benefits of student members as well as professional members. Networking among HSC professionals. Certification skill development training on free or subsidized amount. Notification of job openings for better opportunity. Opportunity for volunteering to serve public or fellow members. Discounts on doctor consultation, medical checkup, and lab test. This is, we will enrolled in this year. Prices, gifts, vouchers for different contest winners. Access to world-class publication journals, online courses, webinars, and so on from ASSP.org. Participate in extra curricular activities like blood donations camp, cricket teams, etc. We are arranging many of activities. Improvement in soft skill development leader. Add the membership card and certificate from world's largest and oldest safety organization to your career profile. Free technical meets by experts from HSE field. Free webinars by specialists in respective areas. Free monthly professional safety magazine. Subsidized HSE training programs. Access to the HSE resources through BOK. Networking with other professionals in the field. Career and professional development guidance. Can join the ASSP Toastmasters Club for developing leadership and communication skills. Participation in member program during biennial professional development and conference. Volunteering opportunity and recognition in the society activities. Group study learning guidance for the various HSE certifications. Access to HSE library online. Represent Kuwait chapter in the US and other places professional. Development conference based on selection criteria. Leadership development opportunity and individual recognition. Engage with peers in 20+ practice specialty and common interest groups of your own field. Career growth and employment opportunities. Exchange of ideas, sharing best practices and knowledge through decision forms. Sharpen your skills with a training, workshop, technical meets, and international conference. Enroll into webinars and professional development. Network with fellow HSE professionals. Recognition awards to the active members. Leadership, opportunities, and much more. Not less. And another thing, the free membership when you finish if you are a student member and complete your academic qualifications, you are entitled for a free membership for 1 year. This is for ASSPs providing you students as a students member. Thank you and getting me the opportunity for ASSP Kuwait and CUSAT for this today technical event. Thank you once again.
Thank you.
Thank you, dear Yunus Konath. Now, this was a overview of what a student membership or getting a membership of American Society, an individual can benefit by that. And if you have any question and query, kindly post it on chat box and we'll reply you back by Mr. Yunus. So there are evident benefits you can get and keep your career signing. Thank you, Mr. Yunus Konath. If there is any question is there, please send. Okay, we have sent that. If you have any questions, put it in our WhatsApp chat or any email is there. It is already posted on this. So now, if you any further questions coming, we will take you and we'll reply you back. Okay. Thank you. Now let us move to another technical session, session 4, which Mr. Moderator is Mr. Samiullah Pathan Khan. He's head of a student committee of ASSP Kuwait chapter, and his speaker is Mr. Anis Jayaram, fire officer of ONGC, BNS Offshore India. The topic is challenges in offshore exploration and production platform. So the time is for 15 minutes. So over to moderator and speaker, Mr. Anil Jayaram, and good luck to you.
Hope I'm audible.
Yes, dear.
Yeah. Thank you very much, Mr. Safdar, and provide me opportunities for this today's very important webinar, knowledge sharing webinar today. And today technical sessions for Mr. Anis Jairam. He's a fire officer, ONGC, BSN Offshore India. He is coming up with the topic challenges offshore exploration and productions platform. He also completed the BTech Fire and Safety Engineering from CUSAT, and apart from the BTech, he is having some certifications courses like NIBOS, IUGC, TSP, HUT, MEMIR, OPTO, and he has been working as a fire protection engineer in upstream oil and gas industries since 2017. By handling responsibility as an in charge of fire services of BPA process complex with offering power of HSEM. So this is indicating us like career opportunities in fire and safety field, because he has just completed his BTech in 2017. And I believe this will also, by achievement of Mr. Anis, will encourage to the student who are attending this virtual event. And his expertise in HSC audit, risk assessment, commissioning and maintenance of fire suppression systems. He also took part in the installations and commissioning of booster compressor module, BCPA, and associate with the BTP, PRP, etc. He also trained in the blowout control and management of emergencies, and constructed working model of various fire equipment and fire and gas system in situ. So he's one more dynamic speaker from the CUSAT. So I would like to welcome Mr. Anis Jairam. So we have very short time. So now it's floor for you. I will not take much more time. So please welcome Mr. Anis, and now floor for you.
Okay. Thank you, Mr. Samiullah Pathan. Am I audible?
Yes, you are audible.
Yeah, I'll be sharing my presentation. Okay. Is my presentation visible?
Yeah, is visible.
Yeah, first of all, I thank ASSP and SOE CUSAT for giving me an opportunity. Relatively, I'm the younger of this lot. Just started my career back in 2017, and I graduated. After graduating, I straight away joined OGC, and ever since I'm working in offshore from 17 onwards. I did an initial 6-month training in various aspects of ENP, an integrated MDFF and ST training, and straight away I got my posting as in charge fire service in a platform called as BPA. It's a salt processing platform and it's one of the largest offshore complex in the Southeast Asian region. So let's start straight away. So basically, this was already explained in very much in depth by Mr. Rahul Patteri. So I'll be just skipping this. Basically, it's just what upstream, downstream, and midstream, what it means. Basically, my work is over upstream, where exploration and production takes place. And I won't be covering drilling because my work experience is associated with surface facilities that are, those are production platforms, basically. So what are production platforms, basically? The pictures are for my the youngsters back in college. For those who are not aware about this entire vast field out there, we are not seeing this. I mean, the general public is not seeing this. Actually, this is basically an offshore complex. This is how it looks like, basically. And unfortunately, due to certain government rules and protection imposed in our mine station, I won't be able to share photos or data related to mine station. So these are photos that are readily available on the internet. So right now, what we are seeing, this is the main process complex. These are jacketed, individual jacketed modules. These are bridges connecting these individual jacket modules. And these small structures that you see, these are basically unmanned platforms, well-led unmanned platforms. So what an offshore complex does is basically it receives the well fluids, I mean fluids from the well. They process it and they dispatch it to onshore facility for further treatment. Basically, we receive the well fluid, we process it, we send to the via pipelines, we send to a midstream facility, and from there it goes down to downstream processing. These are some the pictures, and here the flare tower is actually visible here. Another picture also, and this is the jacket structure, and almost all the installations that we have in India in Western offshore, those are actually fixed platform. Basically, in Arabian Sea, the water depth that we have range from 55 meters to up to 68 meters. So this is considered as shallow water. So we only need fixed installations to work over here. So it's a flare tower, and this is just a module of one of the offshore platforms. So these are type of offshore platforms that we can have actually. But right now in the Western offshore, in our region, we only have fixed platforms. These can go up to 1,500 feet. Then we have compliant towers, sea stars, floating production system, tension leg, and spar platforms. These are based on the specific requirement of the location. If the water depth is more, we use another different type of platform. So this is basically a layout of what to expect near a particular production platform. So this is an unmanned well-led platform. This is the ones that I showed over here, these small structures. So basically, this is an unmanned platform, and usually the wells are here in the unmanned platform. And what we do is that we collect them in the production header, and that's connected to the riser lines, and the riser line delivers it to the main process complex. And we may also have FPSOs, we may also have surface isolation valve, plumbs, etc. based on location to location and from platform to platform. We may not even have FPSO. And our field, we have one FPSO in D1 called Armor Sterling. This is how a well actually looks like. This is a generic. I would be able to go in depth because of the limitation, because if you go deep into well, that itself is a huge subject. Basically, for safety, we have two safety valves, that is subsurface isolation valve as well as surface safety valve. Basically, subsurface isolation valve is one which closes the production tubing downhole. And we have another wing valve also, we can manually close it. And associated with the flow arm, we have a surface safety valve also. Basically, just I'll be taking care of this presentation is intended to the downstream of whatever comes from the well. So let me in brief explain to you what actually happens in an offshore complex. So fluid from the well, this is the gas side of the process. The fluid from the well comes into the gas cooling system. We have to basically cool the gas first, because for the efficiency of compression and for the ease of separation, we are cooling the gas first. And after that, it is sent to a spherical high pressure separator. And in the separator, we separate the gas and the fluids. The fluid will include water as well as condensate. Condensate is a value-added product. So we strip the water from water and condensate is separated in the IP separator. And the gas that is separated from the separator is sent to the gas compressors. We use a 3-stage compression. It involves a total of 11 compressors. And we can receive gas as low as 7 kg per centimeter square, and we can compress it up to 90 kg per centimeter square. And after compression, the gas is sent to glycol contactors. And the glycol contactor, what happens is we basically strip the water contents out of the gas, and we send it via the trunk line to onshore facilities. The water that the byproduct, the water that we separated, goes through a treatment process, produced water treatment conditioning unit, and it's disposed to sea after ensuring the ppm is less than 20, oil and water is less than 20 ppm. Now moving towards the oil side of the process, the oil, similarly, oil also comes from the wellhead and moves to the HP oil separators. And basically it separates the gas, oil and water. Water is fed to the produced water conditioning unit, and also it's sent to the skimmer vessel. Basically, the water that we get from the separator is a bit oily. So we try to recover that oil also while the skimmer vessel. A skimmer vessel and some caisson is used, and after recovering the oil from the some caisson and skimmer, it's put back to the LP separator. And the LP separator, it's again separated into oil, liquid, oil, water and gas. And the gas from the LP separator is of less value because the gas is of very low pressure. We can't efficiently compress it, so it's straight away sent to the flare. And whatever gas we get from the HP separator, we send it to the HP compressors platform. And afterwards, we use MOLs to pump it to an onshore facility. So basically, broad classification of the challenges. Basically, I've divided this into 6 basic sections. So one of the first challenge that we have to deal is the logistics. So our installations are spread far out in the Arabian Sea, in the Western offshore, ranging from 77 kilometers up to 220 kilometers. We have installations. So we basically use helicopters. We have chartering helicopters on a daily basis. We fly hundreds of sorties per day. And the issue with helicopters is that if people who have referred this particular book called Bob Skelton's Process Safety Analysis, there are certain interesting statistics in that. It clearly states that the FAR, that is the fatal accident rate for a helicopter journey in offshore, is approximately 500. That's a significantly huge number. And most of the it's a risky operation also, and most of the fatalities also occur during offshore transfer operations using helicopters. So what in our country, what we do is that all the helicopters are AS4 rated standard, and all helicopters that we use have dual engines, and both engines will be operational at the same time. In additional to that, they are equipped with floats, and people who enter the helicopter when we are being transported offshore, we are wearing this full PPE kit that comprises of an EPD, but we won't be wearing this immersion suit. Immersion suit is only for temperate ocean or temperate waters. Luckily enough, we are blessed with having tropical water, so the risk of hypothermia is not there. So we won't be wearing this yellow jacket. All the other equipment will be wearing. This is the life jacket, and attached to that is an EBD, emergency breathing device. The helicopters that take us to our installation are equipped with flotation devices. These are called floats. In case of an emergency, in case we have to ditch in the water, we basically engage the float and the pilot can safely land. And one more interesting thing that I would like to stress is that in case of failure, I mean, engine failure, dual engine failure, we have actually two engines in a helicopter. In case both fails, the helicopter won't drop like a stone. There's a principle called as auto rotation, and the helicopter will just glide down due to this principle, and you can land it on water or land. So this is the HUET training by Opito that we have to undergo to get the certificate that is necessary and mandatory to board the helicopters that take us. Next thing I would like to discuss is the working condition that we are faced in offshore. What happens is that we are in a rotational job basically. It used to be 14-day on, 14-day off, but due to COVID, now the shift is a bit extended. We are doing upwards from 21 to up to 54, etc. Based on reliever to reliever adjustment. So for some people, extended duration of time in offshore, and this has an impact psychologically. This is one of the issues many middle-aged people face. I have not observed this in the youngsters, but generally middle-aged workers have this issue of extended stay causing problems. Plus, most of the platforms are pretty old. Considering our installations, we have been operating since 30 years. So naturally, a lot of modification might have happened to the plant, so that the locations are constrained, I mean, congested. The area, I mean, the working places are very, what you say, confined. So these are all the actual working conditions that we are facing on a day-to-day life. So this is a challenge for people working manually. For example, maintenance of some equipment, pulling out certain pumps. So a lot of physical effort also goes into this work that we do over there. And this is made worse by the harsh conditions that we have been exposed to. Plus the issue of weather. Up till like 3-4 years ago, we never had this issue of erratic weather in Western offshore. But recently, over the past 2 years, we've seen that the weather pattern have changed drastically. Every year, we have one cyclone or the other. And what happens is that for our installation, since it's fixed, and we can withstand wind up to 220 km/h and swells from 18 to 30 meters. But for rigs and certain barge, it may be an issue. And this is a challenge that we are facing, that we are relying on 3 external agencies for accurate weather forecast. So based on the weather forecast, we'll be able to address the solution and prepare accordingly. So basically, we pull out the barges and vessels from our vicinity when the weather, when there's an unfavorable weather condition. And we have strict marine procedure manual that we follow. Based on that, we decide whether to keep a vessel or keep a rig in a particular location or move it towards the onshore facilities. The major issue that I want to address in this presentation is actually dealing with emergency in offshore. So the issue is that offshore, it's very far away from any kind of help that we can readily receive. In case of an onshore facility, you'll have mutual aid, you have local fire services, local help is always available in case something goes wrong. But in offshore, the issue is that we have to deal with whatever exigencies with the resources that we have right now. So I'll be discussing certain scenarios that we faced and we've identified in our ERP. ERP is not.
Namo.
Hello.
Wait, Namo. मोबाइल लगा नेट गया मेरा.
Hello.
Other non-speaker, please mute your microphone.
Yeah, if there's any query, you can actually directly chat.
Other non-speaker, please mute your microphone.
So based on the ERP, we have totally identified around 27 scenarios and broadly classified this as the ones that I've shown here. So we have helicopter crash, man overboard, vessel collision, gas leak, fire, blowout, oil, chemical spill, and natural calamity, as well as medical emergencies are the certain key scenarios that we have. So to tackle the emergencies, we have a comprehensive detection and suppression system along with an emergency evacuation procedure. So as I said, our complex is pretty large. So our detectors run into thousands actually. We have more than 2,000, 3,000 detectors on board, and it's wide range of detectors, plethora of ones. And we have IR, UV, thermal, smoke, H2HC, and fusible loops. So these are some of the detection systems. So these are combined with this is integrated with the FNG system, and it's combined with the suppression system actually. And our installation is very huge, that we have approximately 51 areas that are individually protected by total flooding system, as well as 19 turbines which are protected by package systems. So these are integrated with the DCS and ESD and FNG PLCs. So some of the fire suppression systems that we have are portable extinguishers, foam water hose reel, DCP skids, and foam water monitors, clean agent, and deluge system. These are certain generic pictures that we have. These are fire extinguishers. This is the hose reel. This is the DCP skid. This is a bank of NOAC, and this is a bank of CO2. Only two pictures are from my installation. Rest are from the net actually. So before we move on, I like to stress on one important philosophy that we follow in offshore. That is, during an emergency, the activation of ESD and FSD. So before that, we have to understand what ESD is. ESD means emergency shutdown. So basically, I'm taking an example of just a vessel over here. Maybe consider this vessel as a KOD. So there's a feed coming in. There's a feed going out, and this is a blowdown. This line goes to the flare actually. So imagine there's a process abnormality or deviation. For example, the level of the KOD has increased more than a certain level, so it goes into tripping. So KODs generally there will be liquid carryover. Basically, KODs used to knock it out. So if the liquid level of the KOD increases, naturally this process, there will be a disturbance in the process, because when the liquid carries over to the downstream of the KOD, it may damage the associated equipment. So basically what happens is that in an emergency shutdown, where the system senses this and it shuts down by closing these two valves, that is the shutdown valves. It closes the incoming feed, and it prevents the feed from going downstream also. So basically it traps the system in a particular state. So this is called ESD. Usually ESDs occur during unit shutdowns. Individual units, when shutdown happens, this ESD is initiated. And along with ESD, if we open this valve, this is a blowdown valve. What happens is that it will vent the content of the vessel or whatever is stagnant over here to the flare, so that we can burn the flare up. So we can burn the inventory up. So FSD is basically initiated when there's a fire actually. When a fire is actually detected, we call for the FSD of the plant. And what it essentially does is that it is a basic fire tetrahedron. You need fuel for the fire. So basically what it is doing is that we are venting off the inventory directly to the flare. So we are getting rid of all the inventory, all the flammable inventory that we have in the plant. We are diverting it to the flare where it's burnt up. And we have systems in offshore. Everything is highly automated. All our system is highly automated, and is associated and integrated with the DCS, FNG, PLC, as well as ESD and FSD PLCs. So this is something that is known as total flooding system. So what this system is used to protect a particular area of importance. For example, in a process complex, electrical switch gears, the instrument equipment room, control rooms are important locations. So they have equipments that are very costly, and any incident that happens will impair the plant operation also. So whatever fire or emergency that we have that arises, we have to instantly suppress it, or instantly we have to normalize that event. So this system, what actually does is that there's a system of sensors in multiple loops based on the design philosophy. Two detectors and other different loops they actuate. It will send a signal to the FNG PLC, and FNG PLC, as per the safe chart that we'll discuss later, as per 14C, there's a safe chart, takes the action for the particular deviation. Consequences the release of the particular clean agent. So this it will send a signal to the clean agent bank to release its content. So what happens is it will release and dispense the content into the location, hence extinguishing the fire inside this particular zone. So this happens very quickly. After detection, within 30 seconds, the first 30 within the 30 seconds, it will release the clean agent, and that 30-second is for operator intervention in case if it's a false actuation. So once a clean agent is released in a particular location, it is automatically FSD happens to the plant. The FLG PLC will give the signal to the FSD PLC to initiate the FSD of the plant. So these are linked together. Next, coming together is next is actually the suppression system that we have installed in our PGC package as well as the turbine generator packages. So these are unit package. These are packages actually, individual units. So in case of any emergency in the unit, there won't be any FSD of the plant. That particular unit only gets stripped. That's basically a unit ESD. That unit takes an emergency shutdown. So there will be sensors within the turbine. So the turbine is enclosed in a compartment. It's called an enclosure, turbine enclosure. And the turbines, we have a minimum of 15,000 horsepower upwards to 20,000 horsepower engines we have and the plant. And what happens is that once a abnormality is detected, we have IR, UV, thermal, and smoke detectors within the. Sorry, we don't have smoke. We have only thermal and IR, UV inside the packages. And once a set point is reached and fire or some abnormality is detected, the clean agent that is protecting this turbine is instantly activated. There is no delay in this case. So instantly activated, the unit takes a shutdown, and there's an ESD in the plant. So this is another piece of equipment that we have, that is fire water pump actually. If someone asks me which is the most important equipment that you have to deal with emergency, it's the fire water pump actually. It is very reliable, and it needs to be also very reliable. It's not a normal centrifugal pump, it's a vertical shaft turbine centrifugal pump. This caisson that you see, this goes down all the way down to the ocean. And as you see that our platforms are jacketed, it is in a one conductor casing, and this casing goes down all the way down to water. And
excuse me, Mr. Anis, we are running out the sort of time. We need to wrap up the session within 5 minutes.
Okay.
So,
yeah, I'll just wrap it up. So what the logic of fire water pump is that in case a fire is detected, I told that an FSD is initiated. When the FSD is initiated, will send the signal to the fire water pump to start. So once the signal for starting happens, the fire water pump will never shut down. You have to manually go and shut the fire water pump, and it will shut down only in two conditions, that is overspeed as well as high vibration. Other than that two conditions, the fire water pump will never shut down, and you have to manually go and shut it down, because it will runs on a sacrificial logic. It will die and kill itself to save others, basically. So why it trips in overspeed? Basically, overspeed happens in a diesel engine or an IC engine when ingress of flammable air occurs. So that's why it detects and it trips. And high vibration is only when some issues with the shaft, and if you run it further, the pump will eventually get damaged. Another challenge we face is the presence of H2S. In our reservoir, we have super sour as well as sour reservoirs, ranging from approximately 200 ppm upwards to 18,000 ppm. So the permissible limit is 10 ppm, STEL is 15, as well as IDLS is 10. So our
देखो 6-7 क्वेश्चन उसने लिखा है, तो आपने हाँ ठीक है, okay.
So we have severe so these are some consequence of being exposed to H2S. Typically, as IDLS is 100, we never let any personnel be exposed at that level. And since we are in offshore, due to the wind conditions, we rarely get in case of a leak, we rarely get ppm above 30. And H2S is a odorless gas above 20 30 ppm, because it numbs the olfactory nerves, and we won't be able to distinguish whether it's H2S gas or not. So this is, since we don't have time, so I'm just skipping this. This is a safe chart as per 14C. These are levels of control that we use in case of escalation and events that we have on process platform. And these are two evacuation methods that we have, that is a lifeboat as well as a life raft. We have more than 13 lifeboats on our complex. So in case of an emergency, we can use the lifeboats to evacuate the personnel. So another challenge that we have is the management of inventory in the complex, because space is a concern. So we have to manage inventory, both hazardous and non-hazardous, in an efficient way. So if we are accumulating a particular inventory there, it changes the fire load of the particular deck also. So we have to dynamically track the incoming and outgoing load and effectively perform backloads to manage inventory. This is a huge challenge, especially during monsoon season, where we stockpile inventory in excess quantity, anticipating shutdown of logistic networks. So at that time, we have to plan this judiciously. And this another challenge is maintenance of safety critical equipment and asset integrity. So like I said, most of the installations are getting old in the field for 30 plus year. So naturally maintenance activity is jacked up like every day here, and then we have to perform my maintenance activity on almost all the equipment. Plus safety critical equipment, there are more than 1,700 equipment that we need to maintain on a fixed schedule, that we are following a schedule called IRR. That schedule, we basically take the reference of API and the OSHA standards to perform the maintenance. And this is a huge task by itself, because with limited manpower and managing this huge inventory and say a list of equipment is also a daunting task. Next comes protection and safeguarding our environment. Since we are in India, the issue is that there are water, air, or these pollution act, they don't apply beyond the territorial water. So right now, for disposal of oil, produced water that we are disposing into the sea, we follow the MARPOL guidelines, which clearly state that we have to maintain a ppm of around 20. The oil in water should not go above 20 actually. So we are maintaining that. We have revamped our facilities and a produced water conditioning unit for that actually. So that's what we do for the protection. Actually, each and every aspect needs even further explanation. So due to the time constraint, I'm only able to summarize this much. The issue is that this subject is very vast, and what we do is also the job that we perform daily, day to day, to explain it to someone is also a full task. And I don't have that much time right now. So I'll be sharing my number here. You can contact me anytime, so I can explain to you whatever you need regarding stream and in surface facilities. So if you have any questions,
Yeah, thank you very much, Mr. Anis. There are many queries from Rahul Patteri. So better I would like to, Ramana, please unmute Mr. Rahul, so he can ask some question. And please keep in mind, we have a very short, we don't have much more time.
So basically, from the HP separator, sir, Rahul sir, first of all, regarding the some case, so we have actually hydrocyclones there. Basically, hydrocyclones, they are used for the produced water conditioning. And we have IGF also, use gas flotation, we use chemicals for that. And what happens is that from the skimmer vessel, it goes down to some case where there's a retention baffle, and it is recovered by the some case and pump back to the skimmer again, and it is taken up to the LP separator. It's continuously cycled there. Whatever water that comes from the HP separator of the oil side, it is taken down, and it's continuously recycled over a period of time. Retention time exactly, I am not aware how much is the retention time, because the issue is that each module came at a later time. The first module of the plan got commissioned 1987. Then subsequently each module got upgraded, and every one of these modules have some casein with that. So this retention time varies from some casein to some casein. But this is basically how we recover it. This is the basic process that we do. And
Yes, and Anis, I'll just, I mean, there are quite a lot. Thank you very much. I mean, let me say you are very conscientious while you say very well presented. Just one thing. I mean, as you said that yours is a SOAR facility with 18% and more. I haven't seen in the flow diagram any SOAR stripper or scrubber or any sort
Actually,
of another.
my station doesn't have that because our average PPM is around 120 to 200 max. But my adjacent platform, it has 18,000. Yeah, I'm talking about. I talked about the reservoir having an average PPM of 200 to 18,000 actually. But my plant doesn't deal with that much consideration. The adjacent plant is called B193. It's very famous actually. That's the world's first plant with the incinerator that was installed. Actually, it got commissioned. Yeah. In YouTube, actually, you have the corporate video of ONGC showing B193. Even our senior, Nitin Alex sir, as the fire officer over there, Nitin sir is over there. They use amine recovery as well as an incinerator to strip the concentration down to manageable, approved level for transit through pipeline as per OSHA standards. So there's an amine recovery and there's an incinerator also. And that plant.
One thing which I wanted to ask is that, I mean, having understood that it's only now 180 and 120 in dissolved state, do you have a temporary refuge endurance time for that particular H2S in your facility?
In our facility, temporary refuge is not there in our facility.
Because of the H2S being, I understand.
So what happens is eventually when it comes out, right, sir? So once a leak happens due to we have wind is like perennial every time. It's like moving towards west to east all the time. So even though there's a leak, we only had once. If I remember, it hardly reaches 30 ppm max. In case of major incident also. So because of the heavy winds that we have.
There is one. I'm sorry to interrupt you, Anis. One thing, possibly we'll speak about it at depth. Wind direction when it comes to a very highly condensed platform as yours, what happens is your ambient wind gets turned off because of wake effect. So maybe at the flare side or the windsock, you seeing it in one direction, but then what happens is because of the wake and corona effect in the wind, it actually flows the other way side. Excellent presentation, Anis. I am very happy. I mean, and you, because you started stating that you are the youngest, but let me say you've delivered a very well quality presentation, calm, superb. I'm proud to say that, I mean, we share the same college.
Actually, I was apprehensive because everyone is so senior to me and I've been invited here to speak. So next questions are like medical tests performed during.
It's okay. We can talk about it because the moderator is also giving us more time. But thank you, Anis. I'll speak to you later.
Yeah. Okay, sir. Okay. Yeah, I'll just drop my message.
Mr. Anis, just go ahead.
Yeah, I'll just drop my number over here. The issue is that actually certain networks are blocked in my installation, so I won't be able to use Facebook and this LinkedIn over there. So recently, WhatsApp is accessible through the net that we have in offshore. So I'll be dropping my personal number. Feel free to drop in any query related to operations over there. So I'll be able to, if I am able to answer your query, I'll definitely do. Else I'll refer and I'll get back at a later time. Okay. Thank you for giving me an opportunity to talk among eminent personalities over here. So that's all. Thank you.
Yeah, thank you very much once again, Mr. Anis. Really, presentation is very well, and the way you explain also is very nice. Okay, thank you very much once again.
Yeah.
And Mr. Safdar, over to you.
Thank you, Mr. Samiullah, Pathan, and Mr. Anis Jaram. It was really a very nice engagement, but because of time, we cannot extract more on this. But anyway, we will be keeping networking. And now I will leave this floor to another session for technical session 5. The moderator is Mr. Venkataramana. who is our chapter executive. And today's speaker is Mr. Najas Tatakate Abdul Karim, who is a lead HSC engineer in Larsen and Toubro Hydrocarbon Engineering, Kuwait. And his topic is challenges in construction on cross-terrain oil and gas underground pipelines. So mark the timing. The timing is 15 minutes. So keep a close watch on timing. Over to you, Mr. Venkatramana.
Thank you, Safdarji. Noted. And welcome, Mr. Najas, who is our instrumental for this wonderful event. Are you there, Mr. Najas?
Yeah. Is it audible?
Okay. Yeah, it's audible. Thank you. Okay. To introduce him, as you all aware of, he's a student of CUSAT, and moreover, he's helping us a lot as a volunteer. Okay, he has taken this program. This is the first program for him, but he has done it wonderfully. He is in between CUSAT and ASSP as a middleman, and he worked a lot. He has taken a burden, a double burden than everyone else. Okay, thanks a lot for that. And going to his profile, he's a lead HSC engineer for L&T Hydrocarbon Engineering and working for KOC project EF 1943. And he has done his NEBOS oil and gas and lead auditors in all the standards. And I have 14 plus experience in the field of HSC and fire management. Currently working in EPC company, and the major duties involve HSC documentation like plant, risk register, assessing the risk, etc. And previously worked with TSC as PMC and Petronet Pathan in EPC, HOCL, Fire Mumbai, etc. I request Mr. Najas to take the session.
Can I share the screen?
Yes, you can. Yes.
Is it okay?
Yes, it's clear, Mr. Najas.
Okay. Thank you, Mr. Ramana, for wonderful words. I don't want to have any introduction. You have already done my introduction part. Okay. Is it audible also?
Yes, thank you.
Yes, fine. So I'd like to continue with my presentation directly rather than going because first of all, time is very limited. So construction 15 minutes, 20 minutes, it's very difficult to tell the challenges, but I like to compare to certain activities only. So what I did, I just consolidated into 4 activities like driving, excavation, extreme climate, and hydro test regarding my project. So I am working under KOC project EF 1943 for L&T Hydrocarbon Engineering, and the topic I choose is construction of cross-terrain underground gas pipeline. But cross-terrain means it's going into different terrains like rocky structure, loose soil, and this is already identified by the soil test during the initial period itself. And the design has been done accordingly because we are the EPC contractors. This is regarding the project layout. It's in Kuwait. It's in Kuwait, and those who are in Kuwait are much familiar with the North Kuwait. Abdali facility, and here this is the Burgan facility, which consists of BS 140, and our line starts from BS 132 point A. It's up to BS 132 point A. It's 30 kilometer, 30 inch, 13 kilometer, 13 kilometers, and from point A to Minar Al Ahmadi, outside of refinery, it's coming 40 inch on 132 kilometers. And it is running to our parallel project, crude oil project, which is of a 48 inch dia. And the layout is almost 80% same. And which have crossing different roads like Road 80, that is from Abdali to Jara, and cross Road 30, 40, and which are the busiest, one of the busiest roads in Kuwait. So this is regarding the project layout. So let us go back to the main topics. Why I choose the driving is one of the challenge, because we are driving very off-road. You can see the layout. It's from point A. It's not the straight actually. There are a lot of curves are there, and also which is around 3 to 5 kilometers away from the main road. So it's purely off-road. We can tell it is purely off-road. And we have certain summer bands are there. So the work duration is between 1 a.m. to 11 a.m. So 1 a.m. means midnight we have to start the journey to site. So that time driving is one of the critical parts. Then CUSAT is famous for the extreme temperature, like extreme climate, like fog and sandstorm. So that also considered to be one of the challenge in the driving. And another challenge is long distance driving. You can coming back again. And here near to Ahmadi, we have the residential areas like Fahil, Mangaf, Abu Khalifa, Mabula. And here in between, after Kadma here, we have the Jalib, or we call it as Abbasiya, Salmiya. People are staying in different locations like residential locations like this only. So from there, if somebody wants to travel from Mangaf or Fahil, it took more than 2 hours to reach the site office, which is inside KOC fence north area. So 2 hours in the morning, 2 hours in the evening, plus 10 hours duty, 14 hours, full driving, full testing. So that is why I choose one of the concern, which is long distance driving is one of the concern. So off-road, coming back again, the off-road driving, the challenges that we are facing is the animals. A lot of camels, animal sheds are there, especially camels and sheep. Public is there. Then there are a lot of life facilities of KOC. Then the another issue is that we don't have a particular road. Okay, roads is not tarred one or like a normal road. So mostly we had to drive in the off roads, loose soils. So vehicle stuck is the common concern. So in order to recover that concerns, we have the defensive driving training for all the drivers, and right of way. Right of way means the road, the temporary road along with the pipeline. I will show the photos so that a temporary road made along with the pipeline, so that and with the signboards are marked there with the speed limit. Then we have the dedicated parking area for the vehicles at site also. And mostly we are using 4x4 pickups for the commutation inside the off-road. Then sandstorm, for fog and sandstorm, the issue is the visibility, and vehicle incidents are quite common. So we are having the regular campaigns, driving safety campaigns, and we have the driver have full authority to stop the vehicle at any time if they feel unsafe to drive the vehicle or visibility is zero. Regarding the long drive fatigue, Earlier, I'm staying in Mobula. Morning, it is very difficult for me to come in the early morning, even though I am using the common bus school vehicles or the, like a coaster. Then we shifted to, and depending on the work nature, we shifted to the nearest camp. So those who are working in the North Kuwait, we have a separate camp in Abdali, and in Burgan area or in between Jara also we have the camp, and Burgan also. So Burgan area also working, we have the camp or the flat apartment in Mabula. So like that, we reduce the traveling timing from 1.5 hours to 2 hours to half an hour or maximum half an hour. So people get more rest, so that they can average, they have 6 to 8 hours sleep. And night driving is one of the main thing. The main challenge that we are facing is the fatigue. Okay. However, if there is change in the shift, our biological clock is always returned to sleep in the night only. So there will be more fatigue during the night, especially for the drivers. During early morning hours, like we can say 3 to 6 more accidents are happening in the 3 to. So our biological clock can withstand maybe up to 3 in the early morning, but beyond that there may be some slowly sleepy feeling will be there. So medical fitness, physical fitness is one of the things, and at night we have the overall site lightings are provided, and the workmen in order to protect that one from, we have the reflective jackets for the workmen. These are some of the photographs that we put it. And also we have strengthened our night inspection also, checking the illuminati of the and this is called ROW, which is which is parallel to the excavated line. And our caves, the client approved PP is having the reflective strip. So this will not work in the morning hours. This will be useful during the night. So this photograph shows the clear evidence how it works during the night. So the thing means somebody come and hit you also is a problem. Okay, let us go to the second activity, excavation. Excavation starts with the stringing of the pipe. We can see the photograph. The trailer coming from the port. With the pipes are offloaded in the ground. Then we start before starts digging. And mechanical excavation. Mechanical excavation means machines are used for the excavation, which is around 3 meter depth, where we have to lay the pipes. So EOD is one of the concern. EOD means explosive ordnance disposal. For information of those who are not in Kuwait, those who are in Kuwait are much familiar with the EOD the way, but for others EOD is not familiar. So EOD means explosive explosive ordnance disposal, the short form, and which is directly related to the ammunitions, leftover ammunitions during the Kuwait-Iraq war in 90s. Another main challenge is the soil collapse. At any time there may be potential for collapse. And one more point I choose is the micro tunneling, that is the road crossings. In our project, we have more than 20 road crossings were there. So how we tackle that road crossings, open cuts are not allowed. So we had to go for the specialized technology called micro tunneling, which is based on the horizontal drilling method. So coming back again to the first step is pipe stringing. Pipe stringing, what is the traditional method that we are following is that Crane will be there. We'll set up the crane there. We'll offload it. Then the next batch will come. Then again the crane so crane will be set up there. Again offloading. So what happen if ton trailers come together? So the waiting time is more, and also more slippage of pipe. But during the offloading, there are more chance for slippery of the pipes. And also there is also possibility for the rollover. So what we did, the action plan is we introduced the vacuum lifter for that one. So that it will be easy. Hello.
Yes, Najaji.
I can't see my video. That's why. Okay. Okay. These are the concerns related to the pipe stringing, or we can call this word is technical word which is used here is the stringing, rather than pipe. It is similar to pipe offloading only. Next is the mechanical excavation, and again the EOD, underground utilities, live lines. These are the concerns. So the main how we tackle this one is that excavation notification is there from the client side as well as the EOD clearance, and we had to do the scanning prior to each excavation. Physically, we had to do the scanning using the scanner, and also we had to do the slit trench. Slit trench means some sample trenching in between. Okay, if you have 25-meter length, we will do some sample trenching, sample excavation here, like that. And usage of trencher. So suppose mostly as per the design, the stretch will be straight. Okay, in order to save the allocation of the pipes, the stretch will be maximum in the straight way. In that situation, we can use the trencher. Trencher means it will automatically cut as per our requirement the width and the depth or dimension as per requirement, and it will pour the mud, soil inside or rocks inside, and it will keep it, and we can keep it as a bund there. So that equipment is also very time consuming now, also as well as we can reduce the number of manpower involved. So that we have to see certain locations only we can able to do that one. We have to ensure that there is no underground facilities or any other utilities available there. So mostly our pipeline is going on in a greenfield area. Greenfield area means there is no much, there is no facilities available. But in certain areas there may be some crossovers where there. That area will be considered in the brownfield. And mostly this pits are more than 3 meters. Some certain areas we have the open pits of 10 meter, 20 meter. So there's in that areas we have a lot of concerns like fall of animals, public vehicles. So usual action plan like a hard barricading of the sites with a proper signboards, and rerouting from the residential areas. And the last one is that in the excavation we are using the micro tunneling for the road crossing with the proper engineering design, and which doesn't allow the open cut in the busiest roads like road 80, road 30, road 40, like that. So we have engaged experienced and specialized contractor with necessary ministry approval, and ensures proper coordination between them. So these are some of the photos of the stringing. These are the methods earlier we are following. Maybe in India, maybe this is the step may follow. We are using the hydras and using tandem lift. We are offloading the things. So this is the photograph of the vacuum lifter. So what does it do? It just suck it here and put it down. And It can also slightly move also, so that it will reduce the time, offloading time. So with the minimum time, we can offload maximum pipes. And without, and also accident risk will be also less as compared. And these are the excavation pits. What we are doing normally, instead of going for slopping, we prefer to go for benching. Okay, and the proper access is provided to all. And there is possibility of rollover also. Rollover in the sense that actually earlier this pipe was here, and due to some issues, it rolls over to the edge. You can see the difference. You can see the pellets earlier. We kept it there. Okay. So actually the packing was not proper. This was the root cause of that one. And we had to keep enough sandbags as a packing here so that this rollover can be prevented. And you see that this is one of the micro tunneling sites. You see how beautifully that benching has been provided. And this is the launching area and the receiving area. And this is one of the challenge. Whatever the launching area and receiving area should be same with respect to our design should be same. If you miss us, if there's any mismatch of, if there any mismatch of even a minor. Okay, so third one is extreme climate. Okay, Kuwait is very well famous for the climate. It is one of the hottest spot in the world. During the summer, the temperature may go up more than 50 degrees. And in winter means winter, it is chilling here. Okay, and rainy means rainy. It's like we can't able to predict when rain is coming, where the water is coming, how the water is entering, in which area it's entering, and more accidents and damages are happening during this extreme climatic. And climate change also it's one of the major concern. Now we feel that from summer to winter changes that people are more prone to the traditional diseases like throat infection, fever, and so on. So for my one of the challenges we faced is this is actually our deep excavation site. It is fully flooded with water, and this is the road, access road to our office, which is full of water. And you can see the damage caused to the perm. Perm means the overall structure. After laying the pipeline, we are making some perm in order to identify properly. These are also we had to go for rework of all the work done. And this is the damages caused last year in our camp. We don't know from where this much of water is coming, and this year this is not the last year. Before then, 2020 January, because I just joined in 2019 December. So immediately the next month, once a time, all the people are coming from Abdali to our camp in Mobila and occupying our beds, stating that it is under emergency, and people from our camps they were evacuating to other camps, and we had to adjust for 3-4 days. And this was the condition, actual condition of the camp, and it took around 1 week to recover or reinstate into the normal stage. So these are the things. Our action plan we did it. We have to have a proper preparation plan, and weather forecasting we are monitoring properly. And Bandwal, we had to see whether the water is coming from which area, and we had to provide proper Bandwal and for the water channel diversion. but it will be success to certain we can able to do for 100%, but for 80% success will be there, so that we can save that much of water coming to our camp or work area. And in the site also, in deep excavated area, fund walls are provided, and the same water channel diversions were planned properly. So last year there was much damage, less damage as compared to previous year. The other one is that hydro test. Hydro test means in the initially I shown the layout of the pipeline. It's from around 140, 132 plus 13, around 150 kilometers we can roughly tell. So you can imagine bulk source of water are required for this much of hydro test. In one stretch it is not possible, so that we divided into different stretches. And the quality of water also to be ensured before and after disposal. So how we manage the bulk source of water, we have the connection from the existing water line from the client side as well as other source, and the major 130 kilometers outside the 14 inches is divided into 3 major sections, and we have the plan to reuse the water to other steps by minimum filtration and purification. The other area is open desert. We can control the people theft, residential areas, then high pressure, gas, water leakage. Water leakage, the thing is that we have to see the continuous day and night monitoring and security patrol. These are the action plans regarding the controlled, water leakage, monitoring of the water leakage. And finally, the dewatering. After hydro test, we have to dispose of water. So that will be done. That will not be done to the open areas. That will be first we will try to reuse it in the another stretch. Then it will be disposed in the finally into the ministry approved disposal site. Okay. So how we overcome this challenge? That is because of only the management commitment. Okay, ours is an EPC company, which we took the whole engineering design, and from this engineering design to commissioning, it is under our scope. And also PMC, Technical Energy PMC, and client, of course, KOC. And also we would like to congratulate and thanks to the competent and trained resources that are available in our project, 200 plus manpower, 20 plus major contractors, and 90 plus client approved HSE professionals are there in different categories like HSE manager, lead HSE engineer, then HSE engineer, HSE officer, industrial hygiene officer, then environmental officer, environmental engineer, HSE trainer. So all considered, we have more than 90 plus client approved people are there. 200 plus client approved WSS, worksite supervisor. They are the backbone behind the site locations, and engineers working, and all the workmen who contributed for the success of 9.5 million man hours till date from the start of the project. And recently we got 3 gold awards in all the areas we participated in the project sector. We participated in 3 HSE excellence, environmental excellence, and management of driving safety. And we are ensuring all the employees are going back home safely, how they come here. So this is our motto. Thank you.
Thank you, Najaji. It's a wonderful presentation. It's similar to the project where I'm working actually. I'm working for Algorithm International, and we are also doing the same thing, but only 36 kilometers length. We are doing RTRP 30 inch only, but yours is a very big project, okay, which is crossing city. we are in the desert only. But here, when you are using this staggering, sucking with vacuum, is it safe or like?
It is safe. It is safe more than going with the traditional lifting, because slippage is more in the traditional way. Because once it is stuck, once it is done, it will be like this. It is vacuum sucking. Vacuum is used.
Yeah. Before doing that lifting, is there anything to be considered, like the piping, like the weather conditions?
Yeah, of course, that will be common for all. Okay, we had to go ahead with the client requirements of the weather conditions or something. But the thing is that it will be stick because once it is stuck, it will not. It will hold. And if it is slightly differ from the CG, also it will hold.
Okay.
But if you go in the traditional way, if you leave from the CG, center of gravity, the slippage is more.
Yeah, that's true.
So that is because people will be continuously, people has to do the same job, and trailers are waiting for offloading. So considering that one, vacuum lifter is one of the best one.
Yeah, okay, good. And how far they can move by holding that item?
See, only thing is that we have to lift it and just hold it down. Okay, that much. Only 5 meter, 10 meter. Beyond that, we are not using that one.
From the trailer to ground, that's it.
Yeah, that's only. Otherwise, every time we had to set up the crane, because the line is moving forward now along with the ROW. Temporary road, a crane has to move along with that one. Set up, it will take time. Okay. Outrigger, we had to set up and everything, it will take time.
Okay. What I'm asking is the what you can say, the ground level will not be the same. No trailer will not go in all the places.
Yeah,
but
this can be. This will be tire mounted or the chain mounted, so that it will be easy. That risk will be avoided.
Thank you.
We are going in different terrains also. That's why we called the name called multi-terrain. Some areas we have the rock, some areas we have the loose soil.
Yeah.
So this can move to certain extent. This can move. Otherwise, we have to bring the higher capacity cranes and offload it into different slightly.
Will that equipment having the boom as well?
No, it's a fixed one.
Fixed one.
There's no boom extension.
Okay. Thank you for your answers and the presentation. And now the floor is for question and answers. If anyone would like to ask any questions, you can go ahead or type in the chat box. We'll go for Ashokji raised his hand. Ashokji, please go ahead. Let me see.
Thank you, Ramana, for this wonderful presentation by Mr. Najaz. In fact, we are also facing a same issue related to the driving. I want to ask Mr. Najaz, after implementation of so many programs, how do you see the violations? KOC tracks the violations also. Are there any reduction in violations after your programs?
Yeah, reduction is of course there.
So you think there are no more violations, or
no, I can't able to say no more violations. Violations are coming, but it is limited to 1 or 2 cases.
I see.
Especially the overspeed only. Other cases are limited. Accident cases are limited, because even I also personally experienced stucking in the mud, stucking in the sand one, but it was not a 4-wheel drive. So fortunately, we got help from another vehicle. They have the shovels and other equipment. They pull out our vehicle and saved us. So that I told them, okay, company to give me 4-wheel to go inside this area. So once ROW is prepared, then it will be okay, because certain days ROW also will be damaged due to the frequent movement of the vehicles.
Okay.
Because once you made the ROW, public also will use that one. We cannot restrict that, okay, this is only for the contractors. No, they are using, they are making, because camping season only we are facing a lot of issues. The winter camping. There's a time, sir.
We cannot control them, yes.
Yeah. When they drive in front of us only, they drive. We didn't expect that. Just to miss.
I see. Good. Thank you. Thank you, Nagas.
Thank you, sir. Now, Mr. Sunil Sadanand, our advisory committee member, is again one more advisory committee member raised his hand. Very good to know this. Sunilji, please go ahead.
Am I audible?
Yes,
yes,
sir.
Sunilji.
Yeah, thank you, Najas, for giving us a wonderful presentation on the challenges, especially related to the underground pipelines, especially in Kuwait. Just I would like to ask one question about managing the subcontractors. Sometimes, often we have a big challenge in managing the subcontractors. The main job will be subcontracted, then further subcontracted, and finally there will be one group coming who will not be having any sort of HSE arrangements. How you, in your project, this is being managed? If you can throw some light, it will be a lessons learned for all of us.
Yes, sir. Sir, definitely when a new subcontractor is on board, we'll have the kickoff meeting with them, and we'll explain the requirements from them, and whatever the commitment from their side also is getting signed from their management. Okay, and the induction, project safety induction is a mandatory part, and we are issuing the training passport to each and every employee. And if they want to engage some subcontractors under them, that also intimated to us officially through email as a request for induction, along with the one of the application. In that application form, they are declaring their personal ID, like the civil ID status, their health also, because as per client requirement, health, we have to ensure that he is medically fit for job. For example, driver fitness is valid only for 1 year. From the date of testing, date of examination, it is valid only for 1 year. So we have to provide the valid medical fitness certificate. Then only we will issue the passport. Okay. Without HSC passport, we are not allowing anybody to work inside. If you found that, we will not allow them to work. First of all, we will give them a warning. Okay, we'll give enough time to recover. Maybe as per 2-3 days within, if you found something, any deviation, we will request them to clear within a particular time frame. It's like that. Initially, there are a lot of issues, and especially the all are now we are in the streamline.
Okay, thank you very much.
Yeah, thank you. Thank you, Sunilji and Ashokji. Your questions gave us answers also, like we are the upcoming professionals who missed to answer these questions. Ask these questions. But these questions helping us to know more about these things. And now one more professional, Mr. Sridhar Bikumunla is online. Please go ahead, Mr. Sridhar.
Yeah,
Yes,
good
sir.
evening all. Yeah, nice
Yes.
presentation. So I would like to know regarding the joints. It's a threading system or welding jobs. I think a lot of welding hard work jobs is going on, right? I think. So I want to know what are the precautions regarding the joints.
Welding, actually, it is automated welding that we are using. So most of the areas we are using the automated welding machine. So first, the only thing is that we have to set up we have to face it properly, face the edges properly, and set it there and put the welding machine there, cover it properly. It will automatically welds it, and it is laid in proper way.
Okay, thank you. Thank you.
Very nice to know that, Najaji. Actually, we are using manual one.
Yeah, manual. Automated, it is actually, yeah.
Good, good. Okay, is there any other questions from anyone?
Naja sir, this is Rafiq from Kochi.
Yes, Mr. Yeah.
Yeah. Sir, actually, I just wanted to know that, you are dealing with the underground pipelines, right? The major threat associated with the underground pipeline is the third-party intrusion. So what precautions do you take to prevent those hazard?
Your meaning is underground utilities. Am I right?
Yes, sir. Yes.
Yeah. The main underground utilities here, we have the existing corridors are there. Okay. Or existing corridors means pipes are going like this. So that is one of the things. So in that area, we are allowing only for manual excavation. No machines will be allowed. First thing. And another areas, if you don't know about the corridors, scanning with the equipment is compulsory. That we are doing jointly along with the PMC. Okay. So if you found mostly we have some observations or findings in that scanning. And another issue is that EOD, as I mentioned earlier, explosive ordnance disposal. Those who are in Kuwait are much familiar about that one. I show one photographs of the grenade, bullets, and other things. So we can't do anything. We had to isolate the area and report the emergency number 160 for a client emergency number, KOC emergency number. And the KOC people will come and collect the materials in safe custody. So
But
we had to
third
hold
party,
the
apart from that, also third party intrusion can happen, right? Like common public or anyone who is coming under the right of use area.
No, that to some extent we had to do the hard barrications, and whatever we are doing, we are doing the excavation. So that same excavated soil will be used as a bund wall in order to protect. So maximum we are using the same.
Okay.
And proper lighting will be there, reflective lights and reflective stickers, flickering lights will be there during the night, signboards, reflective signboards. Even though we can't control to a certain extent, we can't control the public because they are coming in very fast. We can't imagine how the rash driving is. Even the main road also, people rash driving is more as compared. So you can imagine how this during the camping period, people are driving, especially during night.
No, I was particularly asking about the underground pipelines. How do you ensure the safety of that?
Yeah, I told you, we have the scanning report. First of all, there will be soil test prior to this one. Okay, prior to the start of the project. As part of the engineering study, there will be some soil test will be there. And drawings, what are the drawings, client will be hand over. So we have some known areas are there. There they will only go for a manual excavation. Another areas where we have unknown facilities, we will do the scanning, manual scanning prior to excavation. And we are doing the
pipe
slit
locating type, right?
Yeah, we will do the slit trenches. Slit trenches means it's a sample trenches in between. We will know instead if you have some 100-meter line, we will do in between some sample trenches.
Okay.
So we will find mostly whatever things we will find in that one.
Actually, I'm working with the GAIL India Limited. Actually, we operate cross-country pipelines. So we do have pipeline networks from Kochi till Mangalore in Kerala.
Yes,
so
but
we do face this third-party intrusion. It is a big threat for us.
Yeah, I also worked previously in my project. The issue is that we don't have the existing drawing, and also existing drawings they may deviate from that. So the final built-up drawings will not be available, or will not be same as what they laid actually. Even we also faces during our project in Charthala, especially cables were damaged, telephone cables, and the soil is very loose. If you put it if you pour one bucket, you may found some cables.
Okay, fine. Thank you, sir.
Thank you. Sir.
Thank you. Thank you.
Just Mr. Venkatramana for this nice engaging presentation. I hope people has got most of the item out of it. Ramana, hello.
Yes, Safdarji, boliye.
So the next session, technical session number 6, which is, I believe, Mr. Moderator is Narendra Patel.
Yes.
Hello?
Yes, I'm available.
Yes. Okay.
Yes.
And the speaker is Mr. Siju A. Surendran. He is HSC manager for a company ISCCO UAE. And the very interesting topic, which is mattering to most of the HSC professional working in any plant process industry, turnaround safety challenges. So the whole presentation will for say 40 minutes, including question and answer session. So over to Narendra Patel.
Thank you, Safdarji. My name is Narendra Patel from ASSP Kuwait Chapter HC1 Committee, and I'm working with Petroleum Coke Industries Company. It's been a long, great knowledge sharing session today, and it's a really historical initiative by ASSP Kuwait Chapter and CUSAT, which here this moment. Well, moving on, I'll be a moderator for this session number 6, and thanks for this opportunity to introduce the speaker of the day, Mr. Siju A. Surendran, who is working as a HSC manager at ENOC. I will be delivering a speech on subject turnaround safety challenges, a very practical subject we do encounter routinely, but a pleasure to listen from the speaker from his point of view, sharing his knowledge and experience for the attendees. If I could introduce him, he's MTech in industrial safety from CUSAT. He has MBA in oil and gas management from UPES. He's BTech in chemical engineering from IICHE, ADIS from TVBIA. He worked as a supervisor production at ONGC. He worked as a safety engineer at HWPM. He worked as an assistant manager HSC at Ken Energy Firm. He was also special safety specialist, production and surface facilities, PetroChina International Iraq, ZD Iraq branch manager QHC, Tabodin Peters Engineering France. He also worked as a commissioning expert safety at Engg Sons Refinery and Petrochemical. He's a certified safety professional at BCSP. Further, let's move on to the session now. We request all the attendees to make sure that they mute their mics, and without taking much time now, we take this flow to Mr. Siju to share his experience and knowledge on the subject turnaround safety. Mr. Siju,
Thank you.
please.
Thank you, Narendra Patel. I hope I am audible.
Yes.
Yeah, thank you. I'm getting a minor reflection with my audio. Let me use my sound. Hello? Yeah. Yeah, thank you. Let me take this opportunity to give my sincere thanks to ASSP as well as Cochin University of Science and Technology for organizing this nice program, sharing the knowledge to the. Sorry, I'm actually 1 second. Hello? Yeah, now it's okay. This is knowledge sharing section. Please consider, like a lecturer, somebody giving lecture and someone listening, rather than, it's a knowledge sharing section. We we received a lot of knowledge from our colleagues. So similarly, please consider this is what I come across during the last turnaround in ENOC UAE. So that is what I am trying to share it here. This is from my perspective. You might have come across turnaround in a different way. but please feel free to stop me at any point of my presentation and feel free to ask questions. So I welcoming all your questions. So let me start before getting into this presentation. Just go through the contents what we are going to deliver this. An introduction about TAR. The word TAR means turnaround. It's a short form of turnaround. So what are the challenges in TAR, and there are how these challenges are managed, because we have multiple challenges. And when a turnaround is completed, we do the closeout. So this is, starting from the introduction, how the turnaround process is closed out. So I have time constraints, so please bear with me. I'll be running through the presentation slightly speedy, but if you find something something need to be repeated, something need to be more explained, please feel free to stop me and ask questions. So let us, before getting into turnaround, this is not a quiz question. I am not troubling you, please. There are different terms like turnaround, shutdown, outage, downtime. These are different terms. Turnaround is different from shutdown. Shutdown is, shutdown is something happens in the plant and plant is shut down. It's not intended for any maintenance. When there is a planned shutdown followed up by a planned maintenance, it can be a predictive maintenance, it can be part of corrective maintenance. All those things planned and do. The total plant is shut down and we do a systematic maintenance, that we call it as turnaround. So in a turnaround, it's a turnaround is a very expensive process. The total plant is under shutdown, the utilities are under shutdown. So for the owner, it's a very expensive process. So, but this turnaround is very mandatory to revive the plant and bring it back to the production and operate it safely. If you look into the risk, how during the turnaround, actually during the turnaround, the inventory, the chemical inventory is removed from the process. So it reduces the process risk. But actually, the process risk come down, but the activity risk increases tremendously, because for a short duration of time, all the activities in the construction. Normally, construction of a refinery takes maybe 3 years, 2 to 3 years. So this 3 years activity, whatever is being is, all the concentrated activity is done in a 1 month time. So you can just imagine, it's so activity intense, so that the risk is also very intense. Multiple activities, CMOPs, many people working at site. It's very huge. Really, the people, those who come across turnaround, understand the feelings of the activity intensity. But still, I think you understand the turnaround is one of the, if you compare with construction, maybe it's riskier, 10 times more riskier than construction, what I felt, because the number of cranes, number of activities, those kind of things involved in this makes it very risky. Now, just a quick look at the ADNOC turnaround, last revised refinery east. There were approximately a number of 6,000. The activity, as we discussed, it was very intensified. ISCO was the major turnaround. ISCO was the contractor for which I was working. There were more than 5 leading contractors. The HSE team itself of around 350 people, 25 safety engineers and 125 safety officers. So it was a huge team of people, those who are working. So these are some figures. Actually, I am unable to show the figures from ADNOC turnaround because of some security issues. These pictures I have taken from internet. So just to have a feel that, because many equipments are being stopped, opened, it's decontaminated, depressurized, the covers are opened, the equipments are taken out, flushed, cleaned, handling. It's a very heavy equipments. It's not very easy to manage it. So there are big capacity cranes are being employed. Sometimes there will be replacement of equipments, replacement of columns, replacement of reactors, replacement of catalyst. There are many activities being completed in a very short period of time. We can see the the level of activities which are being conducted. There are many activities. There are multiple cranes. The lifting radius, definitely it will conflict with other cranes. The lifting radius very closer, standing maybe 5 meters apart, and they may be working. There will be very clearly defined CMOS plan on which we mitigate this risk. So if somebody is interested about those kind of CMOS plan, how we manage it, I can discuss it separately, because the discussion will go a little far beyond the timing what we are available. So this is one of the critical activity. This experienced our safety professionals know this. This is a bundle puller on which we take out heat exchangers, and all the heat exchangers in the refinery will be taken out. It will be used for hydrojetting. Hydrojetting is another critical activity on which high pressure water is being sprayed into the tube bundle, and it is being cleaned. The pressures are very high. Sometimes manual lancing, but nowadays many places we engage in automatic lancing. Automatic lancing reduces the risk to a great extent. But some places we cannot avoid manual lancing. Manual lancing is also required because it's part of this. Let us see what are the challenges in the turnaround. If you look into the turnaround, there are many challenges like fire and explosion. Fire and explosion, as you know, it's an inherent challenge in any oil and gas industry. So in addition to that, the possibility of toxic release. But here, the most important thing is fire and explosion is not very. The possibility of running into a critical situation is very less. Toxic release, same. There are multiple possibility of toxic releases, but those releases are very small. But that can damage someone, especially in confined spaces and all. Then there are critical lifting, CMOS lifting, confined space entries, electrical jobs, working at height, high pressure. We discussed already. We have seen hydrojetting and high pressure jobs, radiation jobs. Interference with radiation, slip, trip and fall, noise. Many, actually the list is very exhaustive. I have selected 10 items out from the list and just presented here for the sake of highlighting. But there are still more. There are many other just from turnaround you can find. I just go through all these 10 items one by one. This little expand it, maybe one slide for each point, and we just discuss it and we will close down. So I think I can be within the time frame available. The first one is fire and explosion. The major challenge in fire and explosion is, there are 100 plus hot works issued in a day, in a turnaround day. So 100 plus hot works, different plans, people are in fabrication yard, then site, welding, MOC jobs, modification jobs. What else? All these things will have 100 multiple hot works simultaneously going on at site. So, these hot works need to be managed effectively so that it is not propagating to any kind of fire. Then, obviously, even though operation has taken very extreme care in cleaning of the equipment and releasing it for turnaround, but still there will be so many places hydrocarbons trapped inside, and really troubling the people. Like if you take the example, any column, there will be level transmitters, level, the DP lines, level trawls, all these things will some left out hydrocarbon that will get released exactly at the time of hot work or some confined spaces. So these are very trapped hydrocarbons, which is still in the left in the plant, is one of the challenges. Then work pressure. This work need to be completed well within the timing, because each day they have scheduled. These schedules need to be finished, and it is being followed up by various agencies on daily basis. The work pressure is tremendous, so we cannot postpone anything. So that activity needs to be finished in that particular time frame available. Then we have a lot of modification jobs, MOC jobs. Those things also will come in picture. in addition to all of these things, where we have a behavioral issue because of the huge manpower, we bring them from various countries, mostly Indians, then Bangladeshis, Pakistanis, Sri Lankans, many people comes in for turnaround jobs. So they also have different behavioral issues. They try to smoke inside the, maybe inside the confined spaces. There are, many different kind of issues. Then the second issue what we have come across is the toxic releases. Some minor toxic releases entrapped between some two walls, maybe between the drain wall and the CDD wall. There are, different places this kind of toxic material get trapped, even though the highest level of care has been taken for decontamination and depressurization, but still something will be left out if the entire plant is considered. But that will get released during the activity. So these trapped hydrocarbons, trapped H2S is inherent in the hydrocarbon. Those things can create pressure. So similarly, there will be columns, tanks will have some. When it gets agitated, there will be a possibility of toxic gases, demister, many absorbents, catalyst. When when the water is spilled on catalyst, it releases H2S. There are many locations where we can come across these toxic releases. So toxic releases is again a nightmare for a safety manager like me, and not only for me, for all workers especially. Then the third one is lifting. Rigging activity during turnaround is really tough actually. In a small unit, last time we have a condensate fractionation unit where 20 plus cranes standing at a time and doing that turnaround job, different contractors. Now it's a really difficult situation. What we did was, we created a SIMOPS procedure for different contractors, 2 different cranes taken, and we have compared the micro schedule. It's a very interesting job. First time in ENOC we developed it, comparing the micro schedules, and we have a SIMOPS matrix. The next level was micro schedule comparison. And the contractors are allowed only to work during the micro schedule they have committed as per the SIMOPS procedure. That's how we manage the SIMOPS. Then cold weld, many lifting equipments face this problem because not fresh lifting. It is already equipment is in service. Maybe some maybe connected with some other equipments and all. When it is removed, so it will show this cold weld. Actual weight coming on the crane will be more than what is expected. So that a lot of problem in parking the crane, placing the load, lifting the load, many things, many critical lift. We cannot the critical lift to become normal during a shutdown. Majority of the lifts are critical lift. A lot of space constraints. Like construction has got a lot of space available. You can do anything with the construction and only one activity during construction. But here, multiple activity, multiple cranes doing the multiple critical lift, and you have very limited space constraints to do the activity. So it's really difficult. Heat exchangers, bundles, looks very small, but it's very heavy. 30-ton bundle, it's just the height of a 30-ton bundle will be approximately just 5 feet height. So it looks very small, but when it start rolling, then it's a problem. It's a big problem. It's a small heat exchanger bundle rolls. It bundles with a momentum of 10 trailers. I mean, not 10, at least 5 trailers. 30-ton is rolling. So it's a small, it looks a small equipment. The momentum it carries is very high. Nobody can stop it. We have a small accident, rolling with the heat exchanger. Then all these equipments need to be certified. All cranes, all the lifting tackles, tools, shackles, all a lot of equipments need to be certified. And in last turnaround, we used a crane ranging from 30 to 1,200 tons. So this is the range of cranes we use in a turnaround, and it's huge. The next challenge what we come across is confined space entry. It's not, we cannot compare with an operational confined space entry activity here. please remember 350 plus confined space entry permits per day. So 350 confined space activities going on simultaneously. So these need to be 350 fire watches. This gas testing, fire watch management. There are inert entries, not less than 5 inert entries per day. Then rescue arrangements for all these 350, because we cannot have 350 rescue kits available throughout the site. So we strategically, keep the confined space rescue kits, so that all 350 places, they are accessible to the rescue kit. Then there are many monitoring from ADNOC side as well. So there is strict compliance. There is an ADNOC from corporate audit, ADNOC site audits, ADNOC cross-functional audit, ADNOC other site, the guys will come and they do audit. All the safety guys in ADNOC will come and see this turnaround site. So it's very challenging, and the monitoring and the compliance need to be perfectly in line with the procedure what they are sold. Next challenge is electrical equipments. Like construction, we have a lot of electrical equipments. Every confined space is required. Diesel generator, then welding machines. Many are diesel generators operated. Then a lot of BGs. Then we have a lot of switchboards. MC, ELCBs. All the switchboards, local boards need to have ELCB. Then all the ELCB need to be tested, and the certificate on all ELCBs. It's really managing this electrical alone. We require a separate team for electrical safety officers for a short period of 2 months, 3 months time. Managing this, it's really dangerous, because electrical we pay more attention. If something goes wrong, it's nothing less than fatality. So it's more severe. The probability may be less if you have the probability can be brought down by engaging a lot of control measures. But severity we cannot do anything. Then working at height. Working at height, when it comes to turnaround, it is unavoidable. Every column, every reactor, we will have outside scaffolding as well as inside scaffolding. In any turnaround, an average turnaround, we'll find more than 1,000 scaffolds in one turnaround site, and all the scaffold need to have the scuff tag. The 7-day inspection program. We have four scaffolding engineers continuously working on this to make sure that all scaffolding are up to date. And nothing that this need to be, again, they have to go back and scaffold register need to be updated on daily basis, because the audit can be at any time. So we made a system which anybody can walk in and anybody can do the audit at any point of time. That was the system we are working on. So it was very fantastic. Then similarly we discussed, there are so many countries, so many people comes in behavioral issues, smoking. They go to work at height somewhere inside the column, and somebody may be smoking. Can be problem. So extreme height works. These are behavioral issues. We have curtailed. We have dismissed some people, and we have brought the situation under control. It's very critical. Then high pressure is another one. It's not a simple issue. We engage from 3,000 psi to 15,000 psi. 15,000 psi is 1,000 bar. So there are some places we use very high pressure for hydrojetting. Then as we discussed, the manual lancing, but manual lancing is necessary some places, but 90% of the hydrojetting activity is automated. So sometimes the hydrojetting, all the hydrojetting is done in the hydrojetting yard. Some places it's not possible. For example, heat exchanger tower. All the heat exchanger towers we cannot shift to hydrojetting yard. So what we did, we made an arrangement at site on the corner, and that become a temporary hydrojetting yard for cleaning the heat exchanger heads. So that was another. Look at me, time schedule. I'm trying to limit me within the time available, so don't worry. radiation was another issue because many equipments, refinery equipments have got level interface level measurement requires radiation equipment which contains radiations. Then in addition to that, we have radiation coming out from the radiography of various weld joints, because many places you might have seen in construction sites and all, we do the construction in the daytime, night will be dedicated for the radiography. But here it's not like that. Day and night it is fully, people are fully in the site. We are not having a dedicated time for radiation, so we limit our radiation to the lunchtime, tea time and all, but it's very difficult to manage the radiation. There is a radiation safety coordinator. We continuously communicate with the construction contractor, the modification contractors and all. Then the radiation times are allotted. The area is barricaded, but beyond the barricaded area, people are allowed to work. So it's really very difficult task of managing radiation. And multiple contractors, they have different contractors. The project contractor, operation contractor, or turnaround contractor, all will have radiation team. Different contractors, different radiation team. So all need to be coordinated. So radiation CMOPS is also there. We need to make sure that one radiation will not affecting other ways. So this is slip, trip, and fall, as all of you are aware, because many equipments, all equipments are open. You can find everywhere bolts, studs, and all, removed and kept, removed at many locations. Many materials are removed. So you can find that when the plant is dismantled, the site may not be look very clean, and the housekeeping, maybe to an extent it is possible, not 100% safe housekeeping is very difficult to achieve. But to the maximum extent it is achieved, but still housekeeping issues is very relevant in any turnaround site. We do housekeeping campaigns, we give promotional gifts, we dedicate in half an hour in a week time, or whenever we feel that there is a housekeeping element required, we declare it and we do that. So this housekeeping creates a lot of slip and falls. So this one and another one, this is not the not very simple. Noise is one of the very kind of problem which create all people irritated, because so many activities, 10 cranes are working, the sound from the crane, maybe some area hydrojetting, somebody is doing drilling, grinding, all these things will have very high noise. So without ear protection, nobody can enter into site. So it's very heavy, noisy. So we make sure that people working inside so this is how this is 10 hazards from various activity has been taken to discuss here, but there are many still more. I think another 10 is very easy to find out, but due to time constraints, I'm closing down. There are many process equipments. Just to have a look at the process equipments, these are the process equipments which undergo various maintenance, like distillation tower, reboilers, pressure vessels, fin fan coolers. Fin fan coolers who work in refinery can understand how big is fin fan cooler maintenance. Each unit will have a lot of fin fan coolers, condensers, valves, instrumentation, many electrical equipments. Electrical substation is total under maintenance. All so many pumps, turbines, gas turbine, compressors, gas engine, all these things, do their complete maintenance, and they are revamped with a new stage, so that this is working for another 1 or 2 years. Many equipments, instruments, level transmitters, LPs, LGs, FTs, all these things did the maintenance, cleaning, and recalibrated to the and ESD control system, all things will be managed. So these are the challenges what we can find in.
Excuse me, Mr. Jiju.
But please bear with me. I gone very fast, but I think the major challenges in a turnaround has been taken care. Now, how we manage it? We still have more challenges, but that's not related to technical things. It's a short duration. There are different contractors, different nationalities, different cultures. lack of training, HSC training, then provide this training to all these people, then issue them HSC passport. 6,000 people issuing HSC passport in a period of 2 weeks time or 1 week time, it's really challenging. Streamlining many HSC issues at site, enforcing. So because of many issues, I know HSC turnaround team will not have enough time to give education and change these workers. No, it's not possible in a turnaround. What we do is enforcement, and HSC is being enforced in turn. So because the short duration, 2 months time, and all the contractors from different, this is the rule, this is the rule, you need to follow, that's all. So enforcement gains very importance than education due to shortness of time and urgency of work. And other challenges like stakeholder management. You know, there are so many stakeholders comes in line, right from local authorities, client side, subcontractors, government authorities. Then as you know, a turnaround, road safety is one of the major challenge. 6,000 people, transportation, how many buses required, how many drivers required, managing these drivers when they are not on duty. All these things comes as a turnaround challenge. Induction training, HSC training, fatigue, because many people, they don't take weekly offs. They tend to do job continuously to get overtime. So that fatigue management, make sure that people are getting enough rest during the work duration. Many. Then observation, close out. There are client visits, legal authorities visit. They give observation. We need to make close out properly, and all together, all the above, emergency management. Now, in the turnaround, there can be emergency that need to be integrated with the client requirement. So this all, these are all the challenges of turnaround. But I just skipped over the challenges. But I hope you understand there are many challenges in the turnaround. Turnaround is not very simple as construction or operation or something else. This is really challenging. In my experience, because I work for construction, I work for operation, I work for commissioning, I work for all the different life cycles of HSC I worked on. But I can tell you, turnaround is the highest, riskiest job in the life cycle of the hydrocarbon. Not anything else. This is my opinion. Maybe I may be wrong, but this is what. When it comes to the last, the conclusion is, we need to submit a closeout report, a handover report to the client. The turnaround what they have given to us has been completed safely, and the equipments, the safety systems inside what we established. These are the safety systems we established and how we managed it, how we closed it down, how we are giving you the HSC system back to the operation. This is a HSC handover report. This is how we submitted to the client. I just taken a screenshot from my laptop, and there are set of documents inside. Due to the time constraints, I am not showing it. There are many documents inside which need to be submitted back to the client to make sure that the HSC has been taken there during the turnaround. It was a professional management of HSC. That's what we did. So thank you. Thanks for your time. I think I finished it within the time slot available. Thank you, Narendra sir. Thanks for the opportunity. If any questions, please feel free to ask me. We can.
Thank you, Mr. Siju, for Dilip, very detailed topic, taking a few minutes only to describe it. And it's really a challenging task managing such a big turnaround. Thank you very much for enlightening the topic and putting your views. I think, Safdar, we don't have any questions in the chat box. We can move on.
Yes, thank you, Mr. Narendra Patel and Mr. Siju AS. We will be taking your time sometimes in later stage, because the time was not justified and we have to rush it for other activity to finish it. But anyway, it was a very eye-opener, and we have engaged too many people. See, I can see that people enthusiasm. I can see there are 70 plus individuals still waiting from since morning. So you can see that how much they are passionate to learn something new. But I understand we are giving too much doses in a day. After that, there will be 1 hour session, which will be subject matter expert panel discussion. So some of the speaker will be also there as a part of that. So we can take some of the questions. Let me see, there is a question popped up, but you made it very simplified, very interesting to understand that. Okay, we will take that question during this panel discussion, but it was really very engaging and you have made it very simpler to understand. And this was seen through all these experts who are sharing these lessons. So really you people are making very interesting HSC as a profession, and you are keeping people very enticing to adopt for this profession. And we will keep the journey of networking and other proceedings. So thank you very much, Mr. Narendra and Mr. Siju again. Now I will move to another session, which is very interesting, and people will be waiting very eagerly for HSC quiz. Are we ready, Mr. Ramana, quiz master?
Yes, we are ready, Safdarji.
Okay, so the rules will be explained by Mr. Ramana, okay? And the whole this quiz process should take 15 minutes. So let us be ready with this. The fastest answer will be taken quickest. There is a time bound response is required, right? And now Ramana, over to you to explain the process. And good luck to all participants who are going to participate. Yes, Ramana?
Yes, Safdarji.
Okay, the floor is yours.
Yeah, thank you very much. And I'm just logging in. I request everyone to open kahoot.in through browser or app.
Post the spelling word kahoot.it. Okay, then explain the process again, dear.
Yeah, just a minute. I'm logging in. Okay, there is a problem with integration again. What I'm doing is I'm going to share the website through the website. Okay, that is working fine. No, there won't be much difference in between these two. Are you able to see the screen now?
Yes, dear, I can see now.
Okay, now I request everyone to, okay, why it is asking? Oh my God. Okay, game pin is opening now. The screen is clear, right?
Yes, dear.
Yeah, okay. Thank you very much. There was some glitches again. Morning I worked it and it was working fine. Again, there was some issue with the integration. Yeah.
Wow, good. Good going. See the energy.
Yes.
And fun, the people are enjoying. Wow, good, great. So speakers are not allowed to participate, you mean?
No. Only
Let them participate.
Okay, but we will not take in award. Don't worry.
Yeah, organizers are not allowed, please.
Okay, got you. I can see Najas is there. Good. Najas, be there.
Ramana, increase the music. Ramana, play the.
Yes, see the energy of our Ashok Garlapati sir. See?
Play the music here on the sound button there on the top.
Is it coming or no, sir?
No,
it is very slow, very slow. Yeah, increase it. Yeah, okay, somewhat. Okay, good.
Okay, here it is.
Yeah.
This is the way.
Right.
Yeah, thank you. Ashok sir, you are always helpful.
Without music, there is no fun.
Yeah, you are right, sir.
out of 72 point.
No, from our side also we need to invite. Keep your screen active, okay? If it is going off, then you are going to log out automatically. Please keep your screen screen on. We are going to have it in 2 minutes. In fact, after 1 minute, we'll play. Some more logging off is by default. Okay, please keep your screens on. If it is logging off, then screen is going off, then you are going to log off automatically. Keep it active. Okay, so let's start, Safdarji.
Yes, dear. I think we have enough participants to start. Okay, good. Go ahead.
Okay, thank you. You can see the question, I hope. If anyone is having doubt, please tell me. I can pause it now. Once it moves, we cannot pause it.
Yes, it is obvious. It is clear.
Thank you. Mr. Atul on top.
Yes, sir. Yes, Ravana. Other can also be coming on dashboard. No issue at all. Don't lose your hope.
Okay.
Please keep playing.
Okay. But like Ashok sir was telling, we have to encourage the people. That's why I'm telling. Okay, no issues. You can go ahead.
Yeah, that's what I'm saying. Keep playing.
Very good. Actually, out of 44, 42 answered in quicker time. Very nice. Dishan, okay, it's because of dual devices, no issues. The energy, how fast people are answering, very nice. This is a simple question, it seems. Who answered first? Oh, Matthew Bobby. Very good. A little bit tough question, it seems. Very good. Good response from many people. Now, who will beat Matthew G? Question. Oh my God! Within seconds, everyone answers. Good, good. Who will beat Matthew Babuji? I will see in the next question, okay? Simple question. Everyone answered. Thank you. Oh, still no one beat. Good going, Matthew ji. Power tool that is most likely to cause burnt. Thank you. All answered. It's freezed, it seems. I don't know. Names are not moving. Is it going fine or I have some doubt?
It's going fine, Ramana. It's going fine.
No, sir, just joking. Because the score is moving, no? See, 5 seconds left. Everyone answered. Very good. Very close. Someone is very close, Matthew ji. Good, good. Here also 3 people. No, 3 seconds early we finished. Very good. Going very good. All are very professionals. Scored. Yeah, done. Very good. Thank you, participants. You are saving my time. In each question, few seconds I am saving. One to go. Very good. Mr. Said is coming very fast. He's running in.
सवाल ये तीसरा सवाल
Good, very good play.
Quiz number 14.
Done. Thank you very much. And now it's last power play. Okay, keep your heartbeats very low. good, very good. Mr. Patteri is running in very fast. Even Surabhi, no Saurabh. Last 4 questions. Fast, come on. Very good. Last 3 questions. No, in fact, 4 so next method. No move. Wait. There is something. Very simple question. Last 2 questions. Very, very simple. Nice. Very good. Last question, be quick. Very good. All are responded. Thank you. Thank you for participation. Now we'll see the podium. I'll play once again. Third winner, Bazu. Second winner, Patteri. Winner is Matthew Babu. What happened? Okay, Mr. Matthew Babu. I request to give your details in the chat box so that, or you can WhatsApp me the details. I'll follow up with you. Thank you. Thank you, sir. Thank you.
Thank you, Ramanaji, and I hope our president also join it for the greeting to the winners. So congratulations to our winner and also the participant who has participated this event. It is really very interesting. It is showing you your interest and your energy, and we really like that spirit of doing this activity. Now, other things what we will do, Ramana will be separately approaching to all speakers. And before we go ahead, let me have a word with our president, Mr. Jahid Thakur. Say Salam Alaikum and welcome you to join this panel discussion. Mr. Jahid Thakur, President of American Society, Kuwait Chapter.
Thank you very much, Safdar. Assalamu alaikum. Good evening to all. Really excellent execution of entire day's event, and a big round of applause to entire team of CUSAT and ASSP Kuwait chapters volunteers. mashallah, really feeling very proud. And special thanks to Najas and his team for bringing this idea, and entire CUSAT team. And special congratulations to all the quiz winners. Inshallah, our secretary will announce the gift for the winners. And mashallah, in Teats and Beats, I had attended this one because of unavoidable and some family commitment. I was not fully involved in today's event. But whenever I join, I feel that, yes, again now there is the bar is raising by ASSP Kuwait chapter. And special thanks to advisory committee, Sunil Bhai and Yunus Kanod, Najas and his team, Safdar, Mazhar, and entire team. If I forget someone, just please excuse me. Please carry on the panel discussion. Now onwards, I am with you. Over to you, Safdar.
Thank you, President Jai Thakur. For those who had just joined it, Ramana, I am having that all list. We are having a panel discussion on challenges in oil and gas industry. And today, Mr. Moderator is Mr. Sunil Sadanan, Advisory Committee member of ASSP Kuwait chapter. He is also a past president of American Society. And the value addition, just to share something new, that during his time, the chapter won a Platinum Award, which is highest award. And after that, we receive again a Platinum Award. So altogether, we are having 6-time Platinum Award for this chapter, which is highest award outside Kuwait, US itself, and 2-time Gold Award. So it is showing how meticulous and energetic we are with connection with many people like you, and who are propelling this wheel of success. So please help me to welcome Professor Dr. G. Madhu, Department Head from Department of Chemical Engineering, CUSAT, and subject matter expert. Who else are there? Can I have their names? Just for, yes. Oh, the list is so long. Okay, that's fine. Good. We welcome all the subject matter panel members. Mr. Joshi John, Corporate Head from Tata Consulting Engineering, India. Mr. Muhammad Ranis, Human Factor Engineering Specialist, Saipem, Italy. Dr. V.R. Renjith, Head Division of Safety and Fire Engineering, CUSAT, India. Mr. Anis Jairam, Fire Officer, ONGC. Mr. Prabis, MP, HSC Manager, John Energy. Mr. Arshad Ayub, Safety Engineer, Kuwait Oil Company. Mr. Raj Sekhar, HSC Engineer, Al Kuwait, Kuwait, and Mr. Siju AS, HSC Manager, ISCCO, UAE, and Muhammad Alamgir, Lead HSC Engineer, Worley Parson, Kuwait, and he's also our past president and a part of advisory committee. And eminent Dr. Siva Prasad Penke, Senior HSC Specialist, KOC, Kuwait. So we are having a galaxy of subject matter. We have time for 1 hour. Okay, over to you, dear Sunil.
Am I audible? Am I audible to everyone?
Yes, sir.
Yes, sir. Yeah, thank you. Thank you. Good evening to everyone. Now we are entering to the last segment of our today's seminar with ASSP and CUSAT. I'd like to welcome everyone who was there still waiting eagerly to hear the panel discussion from the panelists. Along with me, let me introduce myself. I'm Sunil Sadanandan, working with as a safety engineer in Kuwait Aviation Fueling Company. I'm here in Kuwait working in this field for the last 22 years. I'm a mechanical engineer and a postgraduate in health and safety. Along with me, I have Professor Madhu. I'd like to invite Professor Madhu to have a brief profile on him.
Thank you very much. Good evening to all of you. I am Professor G. Madhu. I am presently professor and head of the Department of Chemical Engineering of School of Engineering, Cochin University of Science and Technology. I am also part of the Division of Safety and Fire Engineering and a former head of the division. I am basically a chemical engineer, having 18 years of industrial experience. Before joining academics, I was with the fertilizer industry for 18.5 years. I was with Fertilizers and Chemicals Travancore Limited, Cochin, India. And since 2004, I am a professor with the Division of Safety and Fire Engineering. My areas of interest include process safety engineering and environmental management. Thank you.
Thank you, Professor Madhu, for that wonderful introduction. We are really blessed to have you along with us in this panel discussion. So to start with, we will request all the participants to post the questions in the chat box, which will be read and will be given to the subject matter experts who are present here in the respective fields. To brief about, we have today with Josie John, who will be a specialist from construction, Mohammed Ranish, he's from HSC Design, Dr. V.R. Renjith, he will be giving academic and as well as other studies, HSC studies. Anis Jairam, he will be explaining on offshore operation. Mr. Prabish, he will be handling the onshore drilling. We have Arshad Ayub, who will be handling HSC studies. Rajshekhar Janathan, who will be explaining on the chemical plant operations. Shiju, we have already heard from him. He will be explaining about the shutdown. We have Mohammad Alamgir. He is again with construction and project management consultants. And Dr. Shiva, we have, he will be explaining about HSE management system and training audit. So I request all the participants to post the questions which you would like to hear from this 10 subject matter experts available here in this panel discussion. If we don't have questions, we will hear from their experience and challenges. So to start the discussion, let me invite Josie John to have a few words to kickstart our panel discussion on his experience and exposures. Over to you, Josie, Mr. Josie John.
Thank you, Mr. Sunil, and to ASSP Kuwait, CUSAT together for organizing this special program. I see a few familiar faces. One is Dr. Madhu, who I have quite a long association, even though I'm not a CUSAT student, but in a professional area we've been associated, as well as Dr. Renjith has also been associated. And Najas, who actually invited me, Najas has worked with me for some time when he was in Tata Consulting Engineers. Now, I'm not getting into other information. I like the term somebody used earlier, challenge is an opportunity. Challenge is an opportunity to showcase your competence and improve your own competencies. Just like any other industry or sector or profession, the safety profession also has huge challenges. But when it comes to safety challenges, it is more important because you're dealing with human lives. And if there's an error, there is a likelihood of either a person getting injured, and even in the worst situation, he or she can even lose their life or can be disabled for life. So there are different situations that can happen. So when we look at these kind of challenges, it is all the more imperative on us professionals to be able to provide competent advice to prevent people from getting injured or exposed to occupational, either gas or any other illnesses because of their occupation. So this is something which we need to fundamentally keep in our mind. See, we are in the business of protecting human lives, and that happens in very, very different areas. So when we look at the oil and gas sector, I graduated as a civil engineer in the year 1986. 1992, I moved to Dubai, to Saudi Arabia, where I had the first exposure to the oil and gas in the working environment, even though before that itself, I did have a considerable background because my father used to work with Bharat Petroleum. So I had a fairly good understanding of what the oil and gas industry and about safety, because he used to come and talk about safety at home. So from my young days itself, I've had some exposure in that area. But in 92, I moved to Saudi Arabia, where I was posted as a site engineer to work on a petrochemical construction of the Ibnzar polypropylene plant. And that's where I got my first exposure formally to safety. The first day itself, we had an induction as usual for everybody. When I had my induction as safety, I remember the person, he was a safety superintendent. His name was Girish. I do not know where he is now around. He may be somewhere in the Middle East or elsewhere. He was the one who provided us a safety induction, and then we moved off to site. And then on the site, we had another safety induction where it was a Westerner by name David Harris, with whom I am still in touch. He is currently working in Australia for the past several years, because he was in working with ADCO in the Middle East for some time too. And then that's where I started learning my safety. What was important is, the first thing I noticed was the safety officers over there used to wear their green hats. So that was the first thing that, that's typically what we also do in our country, and in our construction sites here we use green topiwala. That's the terminology which is very commonly used in the construction industry. Wearing green hats, and they move around. And then I moved to UAE, and then it's in 2001 that 2001 that I actually moved into safety after having spent the previous decade plus actually in the construction side. And that's how I started off. Was the company that I was working for was doing a lot of work in the oil and gas sector, the Al Masood Group. So they wanted somebody to take up safety as a interview, to start the department of safety in the organization, and that's how it was thrust on me. And I think that was the biggest challenge that I had, because I'm here as a person who does not have any clue of any formal understanding of safety management systems, because that was not there. That was not part of the system. That we are more interested in getting the job done and to be sure that nobody gets hurt, and just go below the radar and get things going. And that's when the first challenge started. And that challenge propelled me into being a full-time safety practitioner. And when today I look back 20 years down the line, it's a great sense of achievement, a great sense of fulfillment is there in my own personal professional life. Now, when we look at the oil and gas industry, there are greenfield projects, there are brownfield projects, there are shutdown, or what we heard Mr. Shuju talk about turnaround projects. And there can be small, half a day or even 2 days, or 3 days, 4 days, where we have to do some working on some live pipelines like hot tapping, which is actually happening in a plant which is live. So these are the 4 major areas into which the challenges come up during the construction phase. A greenfield site is quite okay, because it's a new site. There is nothing to be worried about existing plant operations. All the procedures, which are standard construction procedures, get in place, and you start work. And as I said, fortunately, I started off as a site engineer on a greenfield project, and got exposed to what was working in a highly specialized environment. Because on that particular project, we had John Brown from Portsmouth. I do not know; they've changed hands over the years. They were the engineering and they were the consultants, engineering, and they were known as John Brown Portsmouth EMC, engineering and construction. That's how they were known as. So we had all the ground rules laid down, and we just needed to just follow them. But then after that, I moved to the UAE, and that's when I got involved in the ENOC group of companies projects, which already Shiju has talked about in this presentation about Takrir. I've also done some work in Ruiz refinery and in and around Gasco, Habsha, and all these other places, and also offshore at Zadco and with ADMA, both in Das Island and many other platforms. So from the greenfield, I got into a brownfield, and that became a much more challenging kind of a scenario where you have live work happening within a plant, and there you have to ensure that nothing will go wrong, where you can cause a fire or an explosion, because these are 2 critical things which can go out of control. And then, of course, you have your shutdown, which is your turnaround. I've been involved with some shutdowns, like in the 72-hour shutdown for Gasco at Habsha, as well as ADCO at Assab, where it's a race against time to get the plant back in shape. And then, in a shutdown, one of the principles that we had to follow was that we had to pump in more than planned resources. So there will never be shortage of resources in order to complete the job in time. And maximizing, bringing the people, and what Shiju was saying is giving them the induction and, putting them through the whole process. It's a huge challenge. And, it's only when you work right in that environment, you can feel even the adrenaline pumping in to ensure that you're able to, get it done. And offshore, it becomes all the more challenging. Then live working, that was the next stage which I got exposed to when I had to do some work with ADMA-OPCO, as well as on ZATCO, Central West. I don't know what those platforms are known now as. And on the quest, one of the things that the platform manager, what his name was, some Aziz something, I don't remember the second name, about more than 15 years ago, he said, Josie, we understand that you guys have the most professional welders and fitters and fabricators. But unfortunately, we are not looking at that, but rather we want to have people who have safety uppermost in their mind. I cannot afford a single spark to go outside your habitat. So you need to have a habitat which will be proper, the pressure will be maintained, not in a single spark can go on. Because if that plant meets with some kind of an accident, it means 10 million or some figure is $100 million dirhams worth of production gets shut down, and that can be the end of my career also. So we want to be sure that this little job that you come down here to do, you have guys who are fully aware of what is to be done. So what happens is, so I got a good exposure, over the years in the oil and gas industry on what are the challenges. And each time I looked at the challenge as a learning experience. I picked up some competencies, demonstrated those competencies, and then the next step was learning new things. Because learning never stops with your university education. A degree in safety or in engineering, whether it's civil, mechanical, electrical, is just the beginning of the journey. You just come to the starting point. But it's the experiences that really count. And I do get on my LinkedIn page, I do get a lot of advice. So what is the next course that I have to do in order to further my career? I tell all these young people who are telling me, you don't need to do any further course. You just have to go spend your time on the floor, on the site, observing, just observation. And that's how your learning actually increases. Well, there is the design aspect of it. That's different, where you need to do additional courses. But on occupational health and safety, for managing at a workplace, you need to spend physically time over there and absorbing as maximum information as possible. Now, having worked in the construction industry, actually, I came back to India in 2012. I started working with L&T hired me to come and work with them at the Mumbai airport for the T2 terminal. So that was a new kind of a challenge too, because that Mumbai airport was a live airport. So all this while worked in the oil and gas brownfield projects. Here you have an airport, which is a live airport. And this airport had to be kept running. The agreement with the client was that we will give them 52 parking bays available all the time so that the airport operations will not be shut. It was like a marathon because the whole project was spread over several years, 5-6 years. It was like a marathon, a runner doing a surgery on a marathon runner. He has to still keep running. He cannot stop running because if he stops running, he's not going to complete the race. So that was the scenario that we had to work in that airport. It's like keeping one hand tied and working with the other hand to ensure that operations still go on. And with about 15,000 people, some of them who come from the villages, who have never seen an airport in their life, they have to be put through a special training, induction for a few hours. Then they have to be sure that they fully understand. There was a test paper given to make sure that they understood this. We had some guys who never fully understood when they're seeing an airplane, they want to go close to it and find out what it is to feel like going near an airplane without realizing that, if the airplane engine starts off, that can even burst their eardrums because the sound level which goes in an airport goes up to 140 decibels. And we just had a question about the decibel level that is permissible. So that was a huge challenge. Driving across the airport. If you want to go to the other side of the airport terminal, you have to go all the way around, of the other side. But one of the drivers suddenly thought that, why should I do going around? Anyway, there's a runway. Let me just drive across the runway. And that was really a near miss because Mumbai airport, you have an aircraft taking off or leaving every 1 or 2 minutes. And this guy literally, he drove across. Fortunately, it was not the runway which was live. You know, Mumbai has a cross runway. So the secondary runway is not used always. So it was not on 927, which is the main runway. The other runway, the 1428, is not. So it was fortunately on that. And suddenly we found all these yellow vehicles, you know, the safety jeeps, 2 or 3 of them rushing onto that runway to get this fellow out. So there is a lot of challenges, and as we always understand, there is human behavior which is involved. And in the construction industry, human behavior becomes a big challenge. As I told, when you pick up people who come in from the who are basically agricultural workers, they come to a construction site when there's no agricultural work going on. So the skill level, and they have to be taught from the basics. They have to be taught how to actually carry out their even their basic masonry skills or carpentry skills or steel fixing skills. They also have to be taught the safety requirements. But if you have a good system in place, if the site is very well controlled when it comes to safety, believe me, these people will change their minds. You have to bring about a program, as I always use this term, their DNA can be changed. Usually the DNA of any human beings cannot be changed, but I tell you, in safety, we can change the DNA of people. That is what we call as changing the behavior of people. You know, the DNA changes, you will have people, once they start understanding what are the challenges they have, they will start behaving in a different manner. One of the projects when I was working with L&T was the Dhirubhai Ambani Convention Center, which is here in Bandra Kurla. It was one of the biggest construction sites, I would say, because it had more than 10 million square feet of finished floor area to be done. 18 acres of a plot which was being simultaneously done. Just imagine, 72,000 square meters with 4 basins and about 4 basements and 21 towers. So I was handling that project, then I moved out of it to take care of the region. So one of my friends from one of the group companies, one of the manufacturing L&T companies, L&T Komatsu, he said, Josie, can I have a look at this site? I said, why not? Please come along. So I said, okay, you can walk and see and come back, because I said I was busy with something else. So he took a walk around. Then he came back very excited. I said, what are you so excited? He says, I walked into that basement and there were some guys who were, using a broom and cleaning up the place. Yeah, so what? When they saw me, they stopped. I told them to carry on, but they told, sir, we cannot go ahead. What is the issue? You are not wearing a dust mask, whereas we are all wearing dust masks. Therefore, you will breathe in all the dust and that will affect your lungs. He said, this was the answer as what we call a worker giving him. He's a senior guy who was close to his retirement, he says, I have never heard this kind of a comment from even people who work in Komatsu who are willing to take care of visitors like this. So I said, we have run a program where we brought about a DNA change in the workers so that they started taking care of people who started coming onto their site. So it's always possible to do that. So this challenge is a big challenge which we have in the construction. I saw Najas was also doing about his construction site challenges, and I was just, my mind also went through all those similar scenarios, especially working in the desert and how the people will be behaving. Then the second issue that we would always have is the quality of the supervisors. That's a big challenge, because the supervisors, the workers will follow what their supervisors do. I always have experience, and I tell whenever I do any training program, my challenge is not the worker. My challenge is with the supervisors, the site engineers. You guys need to change. If you guys change, the workers will change. So one of the biggest challenges. And I've had issues on even having had to take disciplinary action to throw site engineers off the site because they did not comply with the safety requirements. My first day when I came to L&T again, it was, I walked in, I went to the airport side, I saw one of the engineers, he didn't even have a hard hat or safety shoes. I said, no, I was sitting in the office, I just came out. I said, okay, fine. 2 days later, I came back again. I followed the same fashion. I said, can I have your ID because you need a Bureau of BCS safety pass to get it. Can I have it? I said, you may leave the site. He said, what's the issue? I said, you are the one who has to show the example, but you're not willing to do it. I said, you cannot be working on this site. And that was, I was told, the first time ever that somebody was thrown out of the site because of safety. And I said, I just used, I did it because...
Pardon me, sir. Sunil, I think there are some questions. Please, if you can look into the screen and also continue.
Yeah, I will just, I'll be just looking at it also. And I'm just stopping. Just one more thing. Then the time for execution also becomes a huge challenge. This is also a big challenge. And when the time for execution is compressed, the availability of the resources also become a challenge. And today, every client, And I know when I worked with ENOC, some of the things I said, when do you want the job to finish? They say, we want to finish the job yesterday. That means that is the hurry with which they want to finish up the job. So in these kind of a constrained environment, we are working. And this is a huge challenge for safety because we are dealing with human lives. We need to take care of them. The people who are actually at the cutting edge, the construction workers, as well as the others. And it's a together, we work hand in hand together so that human lives have to be taken care of. And I think that is the responsibility that every safety professional, safety practitioner needs to carry within him. So that was a challenge that I looked at it, and that's what I'm still continuing on in my current role also. So let me just quickly look at the questions. So I'm stopping here.
Thank you, Joseph, sir, for beautifully explaining about the various challenges which you have faced. It is quite rightly pointed out, each and every industry is unique and their own challenges, but human elements remains, almost the behavior elements remain same. Now, in order to catch up the time, I have few questions and I'll be asking our one of the panelists who is from the offshore exposure. And the questions are the first question is that the treated water to sea, is it discharged via Cassian legs? So I request Anis Jairam to answer this question. This was in the morning session.
Yeah, actually, sir, am I audible?
Yes.
Hello? Yeah. Actually, in the basic treatment, whatever, even when we receive fluids from the gas well, it consists of water and condensate. And from the oil well, it's basically an emulsion of oil and water. And after you do the basic separation, the initial HP separators, what happens is that the water that we initially remove, it's still oily actually. Then it's actually sent down to a skimmer vessel actually, and a skimmer vessel basically like an other LP separator itself. And again, one more separation happens, and the water side of that separator drains down to the some caisson actually. So some caisson is pretty long. It's about 30 to 40 meters in length and submerged, and there's a retention time. So once the discharge from the skimmer vessel is moving into the some caisson, there will be a layer of oil that is maintained as per the level of the sea at that time. So oil that is floating within the some caisson is again recovered and sent back to the LP separate, which comes back down to the skimmer, and it keeps on circulating. So a particular portion of oil remains there, and the some caisson has baffles lined inside. So they will separate the oil, and oil gradually comes to the top, and whatever water is remaining, it gradually goes down and it mixes with the seawater actually. And this is after process, after going through a produced water conditioning unit. This comes through the skimmer cycle actually. So this is how they ensure that it is like 20 ppm, below 20 ppm of oil in water is maintained as per MARPOL guidelines.
Thank you very much. The other question is that medical tests performed during chopper transit. Can you have a yes or no?
Sir, actually, individual crew change, there are no medical tests carried out. We have a comprehensive PMV that is carried out every 2 years. And as such, before every crew change, there is no medical test. There's a procedure, a certain we have to see the safety briefing video, and we have to talk with the pilot before boarding. Otherwise, there's no medical check for boarding.
Is there any protection system for the helipad which we use in the
Yes, sir. Our helipads are basically protected by fixed fire protection equipment, firefighting equipment. Basically, we have 500 GPM capacity to foam water monitor, along with one FWH, that is foam or water monitor, foam and water monitor, and we have a 900-pound DCP skid also, which is protecting the helipad. These are the 3 systems that are available to protect the helipad.
That's another question. What is, thank you. What is the endurance time for your temporary refuge shelter?
Sir, we don't have a temporary refuge in our plan because the average PPM is varying from 120 to 200, and as per the last space inspection and last ER studies and whatever QRA studies were conducted, the conclusion was that it was not required because the wind was dissipating to a concentration far below IDLH, and our mustering stations are all located at a position which are inherently safe from H2S. I mean, in case a leak happens, there is no chance that H2S can reach that particular location. All our muster stations are located likewise.
Thank you, Harish, for that excellent answers for these questions. Now, there is one question to Mr. Prabish, who is from drilling session. What are the 5 HSE challenges with respect to the offshore drilling when we compare with onshore drilling? Will you be able to put some lights on this question?
Hi, good evening,
Mr.
everybody.
Prabish.
Yes. Yeah, actually, happy to be here, part of the team. If you see offshore and onshore drilling, the upstream sector is an important sector. Basically, that is where all other industry starts. The drilling activities happens in the offshore and onshore, and from where all other petroleum chemicals, everything is happening. So main challenges are, in onshore, we are on land basically, and in offshore, basically we are on sea, where it is a remote location. In onshore also, we will be in a remote locations, but in offshore, we are extremely into remote locations where we have only one way to go. That is basically we will be using helicopters for transferring to the platforms. If you remember, there is an incident happened in 2005 in Mumbai North Platform disaster. It happened. One of the medical evacuation multi-vessel hit on a platform, and the whole platform was burned out because that happened by a medical evacuation. On that day, the helicopters cannot reach that location. So they have to use the vessel to transfer a patient. And that was a kitchen helper who got a cut on his finger. So that medical cases also, we cannot evacuate the people from the offshore locations. It is very risky. And the time to reach the locations, because the offshore platforms are maybe 100 kilometers, maybe 200 kilometers. In Abu Dhabi, we have Das Islands, which is 186 kilometers from the shore. So the reaching there it will take time. So the medical evacuations is very issue. And if you remember the Transocean incident where the well blowout happened, and BP has to pay very huge fines due to the blowout of the oil. But if it happened on the onshore, we can contain it. Somehow we can put some foils with the equipment machinery, we would have contained it. But it happened offshore where we have very limited resources to reach because the wells are very deep. The ocean is very deep. So we cannot go manually and do the activities over there. So where we have to rely on the automatic equipments, and the depth is there. So these are the main challenges over there. Basically, we cannot reach on the locations where we can have the people on time from the offshore and onshore comparisons. And the resources are very limited. Even this COVID period, there are many platforms has to be shut down due to the COVID breakout on the platforms, where the people cannot go on time and take over the people and quarantine them. But if in the same case, in the onshore areas, we can quarantine that particular area and risk run throughout times also. So basically, these are the main challenges in our area to reach the locations which will happen in operations, and even the medical cases where people are having very much issues to reach the location to do the job safely.
Thank you, Prabesh, for highlighting those 5 challenges with respect to offshore and onshore. Thank you so much. Now, let me, there is another question to Muhammad Alamgir. I hope he will be able to say something about this one. What is the scope of carbon capture in the field of construction? I think it's related to carbon credits, or I'm not sure. But is it any such thoughts available, Mr. Muhammad Alamgir, who is an expert in the construction and PMC side? Muhammad Alamgir.
His network having issues, I think.
All right. So anybody else is there available to say something about this topic? Carbon capture in a field of construction. From the eminent panelists over here. All right, then we will leave this question for some other time. And let's go to another question which has been asked by our one of the speakers of the morning, Mr. Rahul Patteri, would like to ask how feasible is green hydrogen as a source of alternate energy? That's an interesting question. I'm not sure whether our panelists, they will be experts in this one, but some of them may be able to throw some lights on this one. Green hydrogen as a source of alternate energy. Is there anybody to help me with this question? Or anybody from the audience even? All right, I think then there is nobody to say something on this. So Rahul, sorry Rahul, we'll take it up next time with you or at some other occasion with the ASSP Kuwait chapter. So moving on, let's hear, since there is no much questions in related to these items, we will have a view of our theme, which is the safety challenges in oil and gas industry. So for that, let me ask Dr. Pinky Shivasprasad. He's an expert in audit and training and HSE management systems. So with respect to audits and HSE training and management system, what are the challenges which you have exposed during your stay with the oil sector industries? I request to limit to within 3 to 4 minutes.
Good evening, all of you. And I was observing the proceedings and well done today. And really, it is a great day for coming all the experts to share their experiences and then making the youngsters, the future safety stalwarts to come and helping them with the experiences what we learn. And now we landed to share our experiences or what are the challenges. To say the challenges in the industry, I worked for atomic energy, that is a nuclear processing facilities, which dealt with uranium refining. And then I moved to petroleum refining and petroleum corporate sectors and upstream and downstream I worked. So the first challenge for any safety professional or young safety professional who is coming to the industry is, making the, the management to believe that a good business comes from the good safety. Good business comes from the good safety. So making the first leadership to believe. So how this is the biggest challenge. We can have many systems, many international practices, but at the end we need to comply it. But for that, one answer in any industry is the, all the eyes when it comes, who will do this one means the safety officer. However young he is, however senior he is. So one answer, the industry, the particular place, they will be looking towards the safety personnel. So therefore, how he can, meet these expectations, that is the biggest challenge. Because entire business, they have many, expertise in them, but when actual the problem comes as a safety, the health or environment, so they look for one person, that is the HSE professional. So this challenge, how you can come out, that is the competency of the personnel. You need to improve the competency through, knowing about the industry, that is their specific hazards and the technology, and meeting to what is required legally and the technical aspects, how he is going to deal. So updating his knowledge. For safety professional, I say there is no holiday for learning. All the time they need to keep learning and updating the knowledge. So the first challenge is establishing and be part of the teams. And one example I wanted to share with you. So there was a first turnaround in one of the largest refinery where I worked. So the organization is committed that unless you give an induction training, we will not allow any manpower. But they brought the manpower from the remotest places who are not aware of the fundamentals of what is a tool or what hazards may be present in the refinery. But the personnel estimated was 25,000. But 25,000 people in shortest time, you have to make them ready and allow them, and you have to certify. That is the challenge for a safety professional. Then how do you do that one? So you should come out with innovation. So therefore, here comes a safety personnel need to have some innovative methods, which will make the management, yes, we can do like this also. Yeah. So therefore, we need to be a part of the management helping this way, giving solutions. So innovative solutions. So what we did at the time, so we planned a big tent outside, and all the people, all the 25,000 people or plus have to undergo this process of the HSC induction, the security induction, the preliminary scanning of the medical, and then the gate passes and go. So this is the really it changed it is a game changer of from where we can't do a situation, we can do and we will do, and this is the way the safety we can manage. So therefore, managing the safety with the innovativeness, the technological updations is very, very important. So this is the one big challenge for the larger sectors. Another sector where I worked, a pipeline, 600 kilometers of a pipeline from Rajasthan to Gujarat has to cross 2 states and 11 districts. So you need to, so many, challenges, safety challenges, the material movement, the truck movement, the pipeline movements, and then, the interacting with the people. And also that organization was committed for the HSC and the international level of compliance like IFC compliance. So therefore, how do you manage? So that means, and you're bringing the different types of contractors, maybe their level of understanding, their level of preparedness is not there. So therefore, the safety professional, the safety, whatever the levels you say, that is the biggest challenge. That is managing the different levels of contractors with their culture, background, their language, linguistic backgrounds, and aligning them to the organization's expectations, and finally performing the task on time with safety. So this is these are the biggest challenges. So the operational aspects, since morning our friends have talked already. One challenge I think I could not see in the presentation, that is the emergency preparedness and the emergency handling. That is also very, very important area. So again, I'll go back. I have I have seen many emergencies and also part of that. And just give me maybe another 2 minutes. So one of the emergency, the pipeline, which was operating between Rajasthan and the Gujarat, some sabotage has taken place, and then there was a call that there is oil is leaking in the public domain. So now the organization is looking towards the safety. Where are the safety personnel? So the first question comes to them. So therefore, the mindset of the people in the organization is anything means the safety people have to do. So, but of course, the emergency preparedness, we handled at the time the round the clock basis, and then whatever the required with the help of the local teams and all we have done. But it has, we took it as a challenge, that one, and that incident we turned into be the one of the best in class, the emergency monitoring facility we have developed in that organization, with taking the latest technology and visiting the Aberdeen, that is the you all know the oil hub for the oil business hub, and how they manage the emergencies. So knowing from the others and adopting that technologies in that particular organization, I was one of the key person who developed central emergency control center, global emergency control center, sitting at one place at Delhi. We can monitor very larger assets, number of assets of emergency. We can contact the persons by name and the person. So the here what I want to say, the challenges means in the oil industry very large. The one is the growing technology, and then adapting to that technology, and then making the people to align, that is at the ground, and the organizational setup itself. So these things will happen with the what you say, the planned, structured, the management. So the shift has to happen from the, say, just only compliance of the management systems to, or the dependent culture to the path, the growth has to see, the curve has to see that independent culture. That means the people have to, in the organization, to take its safety themselves. So therefore, the safety personnel has to work as a catalyst with their knowledge and innovativeness. So these are the challenges, and these are, I thought I share these points.
Thank you, Dr. Shiva Prasad, for wonderfully explaining that challenges which you have come across. Now let me invite Dr. Renjith, head of the Department of Division of Fire and Safety. Sir, what you were involving in many studies with respect to oil sector facilities, and during your such visits and things, what you have seen the challenges which such industries are facing? Would you like to put some highlights on that?
Yeah. So good evening, all of you. So there is one question for me. I will answer to that question after this answer to this question. So actually, when we are approaching the industry, so I'm talking about the Indian scenario. The industries are afraid when the word safety, they are getting the word safety, they are having a hesitancy to share the data. That is one challenge that we academicians are facing. And what I have observed, there is a lack of industry-institute interaction. So if the industry-institute interaction is there, then we can understand what is happening in industry and what researchers are going in institutes. So I think it will take some time to understand about the sector. So the academicians will take some more time to understand the industrial activities, and the industry will take some time to accept our research also. So if there is a good collaboration, I think we can produce better results later. So in our department, we are fortunate to have Professor Madhavan. He is having both industrial experience and academic experience, and majority of our faculty members are having industrial experience and academic experience. So that contributed a lot to our department. That is why our department is so unique in the world in the field of safety and parenting. These are all my observations, and I can see one question. Is any vocational courses from any university, either from CUSAT for working professionals who wish to enhance academic careers in HSC course, either online or in person? Is there any thought plan for CUSAT in this regard? Okay. So CUSAT is offering, as I mentioned in my presentation, CUSAT is offering a BTech program in safety and fire engineering, MTech program in HSC management, and a PhD program. Our BTech program and MTech program is in full-time mode. So the participants need to spend their time in our campus for this thing. But for PhD, we are offering a full-time program as well as part-time program. And we are conducting regularly short courses, 1 day courses, 2 days courses, and even 1 week courses also in the field of safety. Suppose somebody is requesting, we need a particular type of training for this many number of candidates, then we can identify the experts and we can provide. We are also having internal experts, and we will identify other experts from other industries and nearby areas. Then we will provide these what you call training in a nominal fee. So that is one thing about CUSAT. And regarding updating your knowledge and getting some certification, so I suggest one NPTEL course offered by IIT Madras. There is one ocean engineering department. So they are providing some certification course in the field of safety. So you can do it online. You can write the exam online, and you will get certificate also for enhancing your knowledge. Suppose if you want to gain additional degree, you may approach MKOPSC Center of Texas A&M University. So they are providing PG program in industrial safety through online. It is they are offering. And similarly in India, you may approach University of Petroleum at Dehradun. So they are having customized program for the working people, I understand. So these are all some of the institutions you can look for your higher studies, for enhancing your knowledge as well as acquiring more degrees. So that's all from my side. Thank you very much.
Thank you, Dr. Dr. Renjith, for giving us your experience as well as the various curriculum available with CUSAT Safety and Fire Division. Now, let me invite Muhammad Alamgir. He's our past ASSP person, so he's a CFI OSH as well as a CRSP and CSP. Please, can you share some thoughts on the challenges which you have experienced in the construction industry when you were in the various companies where you have worked with? Muhammad Alamgir.
Thank you, Sunil. I hope I'm audible to you. Sorry, I
yes,
was
you
on
are
a call.
Loud and clear.
Yeah, I was on a call on my phone last time when you were inviting me to answer the question. Okay, Sunil, in my perspective, I see currently one of the major challenges is building a budget for safety. Recently, for the past 2 years, if we see what pandemic has done to the world, is really catastrophic. We are seeing there are, like if we talk about oil and gas industry, a lot of projects have been either postponed or shut down. Okay, like there are cost cutting everywhere. And what's happening when like any industry, we can like give an example, like one of the major industry within this country or in any other countries, whatever, like they were budgeting for the safety is not totally utilized by the contractors when they are bringing their manpower on board, their resources on board. So safety should never be an afterthought. Employees and managers are not able to achieve a safe work site if safety isn't prioritized. Like we can look into it whatsoever budget they do plan for safety. Is it properly invested to achieve the targets? Because sometimes like whatever the projects they are going to take from any client, do they like take in safety into consideration, that whatever the timelines or deadlines are given to execute the projects are safe for them? The manpower they might have on board require more specific trainings. The number of HSE personnel required to supervise those activities, the equipments they are bringing are absolutely meeting the current safe standards, and all those latest PPEs. Even like we are seeing currently like some of the workers were working without the pandemic PPEs, like they were not having face masks or sanitizers, and when investigated, came to know like, okay, they are simply saying, no, we were not budgeted for it. Okay, we did not get the money for these kind of PPEs, therefore we cannot provide. Imagine like the life is compromised, where hundreds or thousands of these workers are working on such high risk activities, and we never know who could be exposed or who could be already suffering from these situations. So I feel like this may still go for another couple of years until this pandemic effects will be over, as everywhere all companies are going for cost cuttings and like achieving more. And one of the major issue also happens during this challenge. If some of the top people who are managing the projects are not safety oriented, they will not pay respect to the safety norms and standards, and they will try to bypass each and everything, whatever resources they can cut down, whatever people they can reduce to bring on board for safety compliance. This is becoming difficult for I can say the safety professionals who are handling more tasks with less resources, and they are under immense mental stress. Thank you.
Thank you, Mr. Muhammad Alamgir, for wonderfully highlighting the major challenge nowadays, which is the budgeting due to cost cuts in the pandemic situation. I'm sure that companies will come with clauses in their contracts next time for having such a control on these budget issues. Whereas low profile companies, they have very much low budget for HSE requirements. Thank you very much. Now let me call Mr. Mohammad Ranish. He's an expert in HSE design, currently working with human factors engineering specialist in Saipem, Italy. Mr. Muhammad Ranish, could you please highlight the challenges which you have come across while during your stay with the various companies internationally and others? Mr. Muhammad Ranish, please.
Thank you very much for this opportunity. And I would like to give a shout out to Mr. Rahul Patteri, who I have been in touch earlier also to maybe kind of know things. He's somebody who I look up to in knowing things. Coming back to the topic, I believe that the challenges have a direct relationship with the term safety and its different terminologies, diversified names that we used to hear, starting with loss prevention, then process safety, and finally, what we now call as an HSC, where you put all things together. So when I say challenges, I say accidents and the challenges coming from that, and also the near misses that is happening. So we take out something from this and ensure that these things do not repeat in future. Secondly, what I would like to say is, I mean, the last challenge and the way how we get past this was about functional safety. So functional safety was something which was not around maybe until 1950 or something. When we started making things more automatic, which obviously increased our productivity, but then it started problems associated with the integrity of those we started introducing safety integrity level. We started providing an integrity value for the sensors, transmitters, final elements, and to, I mean, finally ensure that, okay, with this increased automation, even then we can put things into a safer mode. Just like a functional safety, which came into the picture after 1950, human factors engineering is also something which has been something recently introduced. Until now, this was something handled by independent people. Let's say if it is from a contractor side for a piping design engineers, he is the one who looks after the accessibility of those pipes, valves, etc. If he's an instrument engineer, he was the one who was looking for the accessibility for those instrument. When he want to do calibration, how he will do. But then now having a separate entity who looks after all these things will give it due importance, and we can monitor its effectiveness. In terms of human factors, I would see two challenges. One is to provide proper access for operation and maintenance inside a refinery, if it is onshore, and more importantly, if it is offshore, we don't have much space. So providing a sufficient space for operators to go around and exit when it is required, and also provide proper accessibility to all the valves that is there, spades that is there, so that he can operate it throughout the plant life is something, a challenge that we see as a contractor. And as a human factors engineer, what I would do is to present the operator or end user perspective into the design, so that design can ensure that everything is in an accessible location. So what it does is it will cut short on what we call as jugaad or any other thing, because at the end of the day, if you don't provide a good access to any valve or any pipe or anything, the operator or maintenance guy will find some way around. If it is not scaffolding, he'll try to get on top of the pipe, and that can cause him to do some error. So first part of HFE in terms of challenge is to provide proper access to everything around. Second is procedure. We all very well know HAZOP is something which we give due importance in the project life cycle. Just like HAZOP looks for the possible problems the control loop can have in its malfunction. Similar to that, what we do is at the time of preparation of operating manual, we look for these operating procedures and we'll fine tune it and see which all are the critical operating procedures. And finally, what we will do is we will do what we know as a risk assessment or a critical task inventory review, where we'll find what are the possible human errors associated with an activity and how we can ensure that is considered in the design by making it a more problematic to make an error for a person, and also with the clear signages and making procedures clean. Since there is no much time, I would like to conclude it here. Thank you.
Thank you, Mohammed Renjith, for wonderfully explaining about the human factors related to your experience. Thank you so much. And it is really interesting to hear that challenges which we have come across and the importance of that. Next, let me move quickly to that. We have a limited time, so I request everyone to make it fast. Let me move to Mr. Shaikh, who is an experienced person with operational safety in one of the largest petrochemical industry in Kuwait. Dear Mr. Shaikh, can you please quickly say the challenges which you have come across in your experience?
Yeah, thank you very much. One of the biggest challenge in the operation safety is complacency. An activity which is being done routine, repeated number of times, and the operator or the worker or the contractor comes into a part of complacency. I will give you a few examples of this in nature. Like there's a compressor, and the compressor is having a oil down below, a big compressor, and inside there is something called as a heater, oil heater. The oil has to be kept at a temperature whenever the compressor is running or not running. In both the cases, it has to be kept at a normal temperature, a fixed temperature. So this heater is always online. When you do a LOTO and give the lockout, tagout and give the compressor to maintenance, this particular space heater, this particular oil heater needs to be isolated, but it was missed. It was not there in the energy control plan. In the isolation LOTO, this was not all there, this line item. What happened? They drained the oil, heater was live, and it caught fire, the compressor caught fire. Similarly, there is one more called a space heater. You have in a very big motor to see to it that the air does not have moisture, you have a space heater. And this is also an electrical driven equipment element which keeps the air lightly warmer so that there is no moisture in the air, so that there's no shock or inside the big sized motor. When you give an equipment to maintenance, or when maintenance takes it up for their own and go for isolation, at that time they should see that this particular space heater is isolated. It is not captured in the list of the LOTO and it is missed. I'm just talking about a routine, repeated, normal, daily activity done by LOTO. Still, the line item is missed from their side. Again, one more example of this complacency and the routine repeated activity. You go for blinding. Whenever you give a blind list to go for blinding, what happens is that the contractor takes the blind list and starts putting the blind in all the locations. One time it so happened that the equipment which was planned for going for a confined space was stopped, saying that we don't need for confined space, we'll drop it. By the time the blind list was given, and one of the blind was inserted in that particular vessel. But normally whenever you give the blind list, it never gets stopped. The activity goes on completely, and you finish the blinding, you put the tags, you create the LOTO active, and you allow the people to work. It never gets interrupted in between for this activity because it is a confirmed planned activity. Now in this case, it was stopped in between. One blind was inserted. There was no tag. That ECP was not made active, and nobody knows that there's a blind there. And the job finished, inspection, whatever from outside they did, and then they started, and then they pressurized. They did the leak test with nitrogen. There, that operator observed that there is a blind in the place. If the operator did not observe that, then it could have been a disaster. So what I'm saying is that one of the biggest challenge in a running plant is that the complacency comes into picture. Anywhere you find a routine repeated activity coming into picture, experienced people also make mistakes. How much ever you bring checklist, how much ever you bring procedures, it will be complied by signatures, but in the field, there should be an eye to see that it is not missed. That is what I just want to share here. Thank you.
Thank you, Mr. Rajshekar. That's a wonderful piece of information. Yes, complacency continues everywhere to dominate at many places, and it triggers to incidents. Yes, you are absolutely right. Thank you for sharing that. Now let's move quickly to the last two panelists. I'll call Arshad Ayub, who is a very familiar personality in Kuwait for the HSC studies. Can you show some light? Show some of your experience with respect to the challenges faced in the HSC studies?
Sunilji, his network is having some issue, I think.
All right, so we'll go to Shiju. I request Professor Madhu to handle from here to give a speech, handle the speech of Mr. Madhu, Mr. Shiju, and conclude this session with that. With that, I'm signing off right now, and the rest will be handled by Professor Madhu, if it's agreed.
Thank you, Mr. Sunil, for handling this panel discussion in an excellent manner. So we have listened to quite a few panelists, and they have covered most of the aspects related to the challenges in oil and gas industry. Now, I think the last person is Mr. Shiju. I think he has experience in operational safety as well as HSC management. Now, let me ask Mr. Shiju about the emerging challenges. Let me start with, for example, the issues related to equipment reliability. Any process industry faces that challenge, equipment reliability. So most of the process industries, including oil and gas industry, they use methods to increase equipment reliability, that is to reduce the downtime. Okay, so I just want to know, what are the techniques adopted by the oil and gas industry to improve the reliability of equipments? Okay.
Very good question. It's in fact something beyond my knowledge, but try to answer this. Sir, when we look into the equipment reliability, it is most into the availability, which gives profit to the organization. But as such, safety is concerned, equipment reliability, with respect to emergency systems, are more relevant. What I believe. The reliability of emergency systems are very important for safety persons. So for industries, latest IEC standards like 61508, 61511, these standards, gives a very clear-cut guideline how equipments can be, shutdown related equipments can be effectively maintained, so that in case of any emergency requirement, these systems are available. The probability of availability on demand, so that can be maintained. So these are the standards presently we are following. But when it comes to normal operation, the reliability with respect to the operation, I am not very sure how that can improve the safety part. But definitely, I think I answered your question.
Okay, Mr. Shiju. I think now we are coming to the fag end of this panel discussion. And I think there are some issues. For example, I have also worked in industry for quite some time. Then I think, so I think Dr. Renjith has posted a question. It's about SIL. The importance of SIL in oil and gas industry. Okay, I think Mr. Shiju can respond to that question also.
Yeah. Yeah, safety integrity level is again the extension of IEC 61508. 61508 talks about the equipment reliability with respect to emergency systems, like emergency shutdown systems. The emergency shutdown system as a whole, it's like in industry, we know we have control systems. So emergency shutdown system is a parallel system like control system, which simultaneously observe the process. If something goes, if any of the process parameters run out of control, it takes the control. No, it will not take the control. It monitor if the parameter violated beyond the permitted limit. The process, the emergency shutdown system take the control, shut down the process, bring back the process parameter to the normal situation. This is what an emergency control system, sorry, not emergency shutdown system does. Now, coming to different level of SIL, like SIL 1, SIL 2, SIL 3, SIL 4. Depending upon the requirement, depending upon the complexity or risk of the process, we can the system. We need to run use the standard. There is a table in IEC 61508 that the particular table need to be utilized to find out what is the targeted SIL for the particular process, location, and equipment. Then, based on the target SIL, we identify what is the SIL level required for that particular equipment. So the SIL level required for the equipment will be decided. Then that need to be matched. When we match it, we make sure that the complete loop, starting from the initial detecting element, then the control loop, starting from final control element, detecting element, the sensing element, everything should meet that particular SIL level. So using the SIL level, SIL is something is a layman language. Anybody can understand when we talk about SIL, but when you talk about reliability, people normally don't understand. So using the SIL concept, easily we can say that SIL 1, SIL 2, SIL 3, based on that, this requirement is met. So using the SIL concept, as Madhu sir was mentioning, the reliability levels can be equated so that people can understand, everyone can understand.
So, okay, there are some other issues like the incidents that can occur during startups and shutdowns. I think that's an area to be addressed. I think it's a challenge to any type of process industry, including the oil and gas industry. Then another issue that comes to my mind is the reducing the carbon footprint. I think there was a question regarding how to reduce the carbon footprint in the construction industry. I don't know whether there is scope in construction industry also, because during construction activities, various types of fuels will be used, and ultimately these greenhouse gas emissions will contribute to climate change, global warming and climate change. Of course, there is a scope for reducing the emission of greenhouse gas emissions in construction industry also, but the industries, the oil and gas industry can, I think, it can play a major role in reducing the greenhouse gas emissions. I think it's an area, I think a lot of work is being done all over the globe in this area. And again, people are now talking about carbon sequestration. And again, one potential area for carbon sequestration is these abandoned oil and gas wells. So is this carbon dioxide can be stored in these wells. It is projected as a viable method for carbon sequestration. So that way also oil and gas industry can play a major role. So I think these are some of the challenges that we have to address in future. So that's all from my side. Now I take this opportunity to thank the Kuwait chapter of American Society of Safety Professionals for organizing this technical webinar in association with the Division of Safety and Fire Engineering of School of Engineering, CUSAT. It was a great opportunity to all of us, both the faculty members and the students. All of them got benefited. I'm also glad that many of our alumni contributed a lot to this technical webinar. They are now occupying senior positions in HSC all over the globe. So we are very glad that they are contributing much to make the oil and gas industry safer. So that's all from my side. Thank you very much. I think over to Mr. Sunil for concluding this webinar.
Thank you, Professor Madhu, for wonderfully concluding. Thanks to all the panelists. It was a great discussion. I hope this will be a start with CUSAT. We will be having more sessions in future. And with that in note, I will hand over back to our chapter officials for the final conclusion of this event. Thank you once again.
Mazharuddin, are you around? Yeah, okay. Okay, go ahead, Mazharuddin.
The names are ready?
I mean, which names? Winner names? No, that I'll coordinate them. I'll get the details actually. You want the names? I can get.
Quiz winners. Okay. Hello. I hope I'm audible. Hello. Hello, Ramana. Am I audible?
Yes, Mazharuddin.
Yes, wonderful panel discussion. Thank you so much. Thank you so much, everyone, for sparing your time and giving so insightful details of your areas of expertise. And it was really wonderful to know a few things and also learning from experience. Few of you have initiated the safety department first time in your plant or your facilities, and good to know that what are the challenges and how you overcome it. Thank you so much for this. Now it's time for closing, I think. Let me have pleasure of thanking all the people who have participated in today's event, and all the speakers, all the mentors, all the moderators, all the panelists, and of course the number one thanks to the participants who joined today, stayed with us for full day. Now, before I go to the end, let me first announce the name of quiz winners. So thanks everyone. Many of you have joined in the quiz, and these are the results you can see on the screen. Congratulations to Mr. Matthew Babu for getting the first place in the Kahoot quiz organized by ASSP Kuwait chapter and CUSAT jointly. So many congratulations, Mr. Babu, for this. Really excellent. The number is given based on the maximum number of right question in a minimum number of time. The second is Mr. Patel. Could you please write your name in the chat box so that we will know your full name. These names are given by you in the Kahoot, the short names. So congratulations to you. Mr. Patel, we would be very thankful to you if you write your name and email ID in chat box. And the third place is by Mr. Badusha. Congratulations. For you also. Okay, Mr. Badusha Ali. Many congratulations from CUSAT. Okay, Narendra Patel. Okay. So second place is Narendra Patel from ASSP. Congratulations to you, and Mr. Badusha Ali from CUSAT. Many congratulations. These are the results, and our office staff, Mr. Ramanna, will be in contact with you guys for further things. Now, at the end of this closing of event, I'd like to thank all of you today for joining us and sparing your valuable time. Special thanks to our chairman, who was very excited and supportive while he heard this idea of doing this one-day program along with the CUSAT, so that we can engage not only professionals but students also from Kuwait and from CUSAT India. So thank you so much, Bu Muhammad. Thank you. It's very nice support always and motivation from your side, how we can do this kind of things. Further, I would like to thank the staff of CUSAT, Dr. George. Thank you so much for joining today with us and supporting to us, allowing your staff to do this event along with the ASSP. We are very much thankful to all of you in CUSAT. A special thanks to Mr. Najas, who has initiated this idea to combine combined event by ASSP Kuwait chapter and the CUSAT. Thank you so much, Mr. Najas. The seed you planted, it's now very good event we had today, where this is all because of initiative taken by you. Thank you so much for all our advisory committee members and EC members, our president, Mr. Jahid Thakur. Special thanks to Mr. Safdar, our secretary, who has hosted this for a whole day. And also he has moderated the first technical session, which was FMEA studies by Professor V.R. Renjith. Thank you so much, Safdar Bhai. This would not be possible without your continuous hosting and moderating beautifully. Thank you so much for that. Thanks for our office staff, Mr. Ramanna and Riaz, who has arranged all these Zoom things very beautifully. I would like to thank all our speakers today. It was really wonderful day, very different topics, different thinkings, different way of looking at the things. Really, all the topics were very interesting, and all the speaker has made it more interesting by presenting in the manner that can be understood by all level of participants. I'll start with Professor V.R. Renjith, head of safety and fire engineering in CUSAT, who has presented today FMEA studies in LNG industries. Mr. Rahul Patteri, last night he has also presented with ASSP, and today he spared his valuable time to present challenging in project life cycle from concept to commissioning and operation. He is from Fire and Protection and Process Safety Department, leading the department in ENOC. Next, thanks to Mr. Dilip Madhavan, who is a manager in Petronet LNG. Thank you so much for your presentation today. Mr. Anish Jairam, Fire Officer in ONGC, Mr. Najas, the key of this event. Thank you so much for presenting also. Mr. Najas is a ASSP key active member and lead HSC engineer at L&T Hydrocarbon Engineering. He's in Kuwait with us. Also, I would like to thank Mr. Siju Surendran, HSC manager, ISCCO of UAE, for presenting on turnaround safety challenges. I would also like to thank all the moderators, starting with Mr. Safdar and Mr. Najas, Mr. Samiullah Pathan, Mr. Ramanna, and of course, Mr. Narendra Patel. Thank you so much. You have handled this all, sessions very well within a time. We are a bit ahead of time, but that's okay for the event like this. And moving forward for panel discussion, it was so interesting, different experiences we heard, and special thanks goes to Dr. Madhu and Mr. Sunil Sadanan, our past president and good friend of mine. Thanks for moderating this panel discussion. So really, it was really wonderful, and we learned a lot from this discussion today with the help of our panel members, Mr. Joshi John. He's a corporate head of TCS in India. Mr. Ranish from Saipem, Italy. Dr. V. Renjith from CUSAT, India. Anish Jairam. Mr. Anish Jairam from ONGC, India. Mr. Pravesh MB, a very active person of ASSP Kuwait chapter, and very good friend of mine. He's HSE manager in John Energy, Kuwait. Mr. Arshad Ayub, once again, very good friend of mine. He is safety engineer with us in Kuwait Oil Company. Mr. Raj Shekhar, our leader of the ASSP Kuwait chapter, and he is presently working in Kuwait as an HSE engineer. Mr. Seju AS, he is HSE manager in ISCCO UAE. Mr. Mohammad Alamgir, our past president, our advisory member, and a very good leader of ASSP Kuwait chapter. He is presently lead HSE engineer in Wali Pasan in Kuwait, associated with Kuwait Oil Company. And my previous boss and present colleague, Mr. Dr. Siva Prasad Penki, always guided me since last many years, maybe almost a decade. He is the senior HSE specialist in Kuwait Oil Company along with us. And thank you so much. It was really wonderful. Yes, some shorts were there and suggestions were there from the Dr. Siva, and we will take care of this in our next event like this, including emergency cases and all. So thanks all of you. Special thanks to CUSAT staff. We would like to be more associated with you for such kind of events for student as well as our members, and also for the professional upgradement of our working professionals in middle, especially because it is very difficult for us to find kind of masters and doctorate works in this part of the world. So it would be great if you guys can help us and guide us how our people here in Kuwait as well as in the Middle East can take benefit of your programs. Thank you so much for everyone who has joined today since morning and continuously was being with us for whole day. It was really such a wonderful event. And with this, I am thanking you all. Anyone would like to say any words, please, you can go ahead. Officially, we are finishing this event. And once again, let us plan another event and we will see all of you in that event. Also, I would like to just remind all of you that on November 3rd and 4th, we have Kuwait International Conference on Occupational Health and Industrial Hygiene, which is also one of the key area of HSE, along with Viconex in Malaysia. And I would like to invite all of you to join that, and all the details are available and on the website. Thank you so much once again. Have a good night. If someone would like to share something regarding today's event, please go ahead.
Thank you all. I am Sridhar. I am Sridhar Vikmanla, ASSP member. First of all, thank you, ASSP Kuwait chapter. And special thanks to Mazhar. You've given all thanks to everyone. But I want to say thanks to you, a special thanks from my side. Thank you all. Thank you,
Sridhar. Thank you so much for joining today and being with us for so long. Actually, I could not thank many people because the list is long. There are so many in planning and coordinating this event. It's not only the name I have taken, but with the time limitation, I have just stopped with that. I am seeing our leader, Mr. Ashok Gallapati, is raising his hand. Sir, please go ahead. Screen is yours.
Thank you, Mazhar, and appreciate ASSP Kuwait chapter for this particular event. I think this is the first time we have done with any collaboration with any of the academic institution, as per my knowledge. And this is a very good initiative. Our the core committee has taken, of course, with the support of everybody. But this we have so many partners, correct? Corporate partners, sponsorship partner. I think we need to look for the educational partner. I think CUSAT will be the right educational partner to start with. And we also have the local societies like GUST and American University and other things. So let's have a plan to have an educational partner. Let's begin with the CUSAT. I think that's a great start, I think, today. Appreciate your lead on this particular event, Thank you very much. It's a very good information.
Thank you, Ashok sir. As usual, a great idea, and of course, it's noted. And you are the only one, I am sure, who will guide us in this. So yes, with this agenda, we will come back to your good self only, and inshallah, we will have good thing and good progress in that also for our coming time. I am seeing one beautiful face here, who is my very good friend, Mr. Jahid Thakur, our president of ASSP Kuwait chapter. Mr. Jahid, please say a few words. We are waiting for your voice since morning. Please, please.
Thank you very much, Madhar. Mashallah, really a wonderful event and excellent execution from the both team, CUSAT from India and ASSP from Kuwait, and entire show whole the day. Okay, I am unfortunate I did not attend the full, but I can see the feedback from the members who has participated. And as Ashok sir told, this is the first time in the history ASSP Kuwait chapter has jointly make this event happen. And I would like to thank on behalf of ASSP Kuwait chapter all the CUSAT members, starting with Dr. Renjith and Dr. Madhu and Najas. A special thanks to Najas who brought this idea. We know that as a voluntary, once you want to have this kind of event, it requires a plenty of hours of preparation. And as our secretary always used to say, 5 P's: pre-planning, prevent, poor performance. And really it looks here, which is the plan, and back of the things you had done 2 or 3 dry run, and you made a WhatsApp group, and you had connected with all the speakers, all the panelists, and wonderful organization for today's event. And thanks to you, Mazhar, really wonderful vote of thanks. And thanks to entire team of ASSP. Let's enjoy. Thank you very much.
Thank you. Thank you so much. So there are no more hands raised. Anyone from CUSAT would like to add something in the closing remarks? It would be great.
Yes. Okay.
Yes,
so it
yes,
was a
yes.
wonderful event. Within short
Thank you,
period,
sir.
we could organize this wonderful event. I hope most of the participants are enjoyed this program. So that industry institute chemistry is worked out here. I hope in future it will continue. So whatever may be the feedback given in the closing ceremony, we will take up and we will discuss on that, and we will revert back to you regarding that collaboration with university and ASSP formally also. Anyway, we can be the academic partner for you definitely and officially, but officially we need to get some support from our administration. So we will also think about that for getting some degree for the person who are working in Kuwait and all for PhD and other program. I will definitely talk to our Vice Chancellor about this, and we will try to collaborate. So I take this opportunity to thank all the core committee members, the organizing committee members. I'm not mentioning the names, and moderators, then the panel members and speakers and the participants. So a big thanks to all for this wonderful event, and a special thanks to Najas, because some 15 days back he sent a WhatsApp message to me, and immediately I responded to that. And from that only this event is happened. And since he's my student, he did 90% of the coordination or 99% of the coordination. And I think a special congratulations and thanks to Najas is required. So everybody is pointing out his name. So when he was a student here, he was supporting me organizing the quiz competition for our annual Safety Day celebration program. I think he is continuing that nature. I understand that he can organize more and more for the benefit of the whole community of safety professionals. So I take this opportunity to thank each and everyone. Thank you very much. Have a nice day. Thank you.
Thank you so much, Dr. Renjith, for these words. And as you said, I think many of us are started feeling happy that you will look into how Kuwait professionals in Kuwait can gain their further degrees and can gain their knowledge through CUSAT. So some positive hope is there. I am sure you will be looking into it, and it will be something good decision will come up for professionals like us who are having more than 15 to 20 years experience and want to pursue something, but in this part of the world it is getting difficult for us. Thanks once again. Anyone would like to share something, then, or we can have officially.
Yes, Najas, we want to hear from you.
Yes. I was coming to that.
Mr. Najas, your mic. No, please.
Is it audible?
Yes.
Yeah. Actually, I met Mr. Rahul for bringing me as a speaker for PSM forum. This was the start of the initiation for one-day webinar. Then we discussed with Renjith sir, and finally it came as a one-day webinar. Discussion starts for as a single speaker for a PSM, but initially it was like that. Then finally today, what happened is it came as a one-day, full-day webinar. So initial idea was mine, but without of support of the core committee and other people, other department people, it doesn't happen. It's a teamwork actually. And Mr. Rahul has wanted because he becomes the speaker for PSM as well as also in the one webinar also. I want to bring some innovative. That's why I want to bring all the speakers from CUSAT itself. I tried a lot. Even though from here now recently only the Kuwait has again wake up for the traveling, so people are really busy in flying home. I'm also flying this month. So anyway, thanks for giving an opportunity to come forward and be a mediator between ASSP Kuwait and ASSP Kuwait chapter and CUSAT, because I'm confused because I am in both the boards.
Yes.
So I had to
Both are in your heart.
Yeah.
Both are in your heart.
Yeah. Anyway, once again, thanks. And regarding that membership, a lot of people shown the interest in taking the membership. There are two possibilities. Either we had to bring them under ASSP Kuwait chapter as a student member, or we had to start a new new membership chapter in new chapter in CUSAT. So that we can decide it with our membership. That is up to the core committee. That maybe up to my knowledge, maybe 300 people are there in one section. 300 live students will be there, considering BTech and MTech.
Wow, that's great to hear.
Yeah. So plus, yeah.
Mr. Matthew Babu has also posted in
the
chat.
They also supported me. Their coordination, back-end coordination was very good, because before thinking here, we made all the things, speaker profile. Before asking, I told them to make it ready, all the things. Go for backup plans. If something goes wrong, go for co-host, like that, everything. Anyway, it was nicely presented with the help of Mr. Ramana and Riyas, and it was the outcome of the result of the endless sleep.
Great, Mr. Najas. Yes, of course, it's a very good teamwork within a very short period of time for having this kind of event, and support of our advisory members, our past presidents, and all other committee members, student committee and multimedia committee who has posted everywhere regarding this. And really, it's really a good teamwork within a short period of time, and it showed us that yes, we can do something like this also, a full day program within a week, with the help of all our people, and with gatherings a few very polite experts who understood the emergency and join us within a short notice. So that's really good. We can do such programs in regular basis. And of course, Mr. Matthew, yes, we will be in touch with you through Mr. Najas for your ASSP Kuwait chapter. Inshallah, and we both the parties will be benefited with the knowledge of each other, because you have such a kind of knowledgeable professors over there who has also industrial experience of decades, which will be helpful for our professionals. And we have also here many professionals who are 20, 30 years, 35 years of experience in the field of process safety especially, and safety also, as well as health and environment. I don't want to miss that. Which will be helpful for the students who wants to pursue the career in the field of HSE, and especially for process safety. So thank you so much. And with this, I'm saying all of you a goodbye and good night. Hope all of you have enjoyed this, and inshallah, we will see you soon in further events and as well as conferences. Thank you so much. Have a good night. Officially, we are closing this event. Thank you.
Okay, thank you.
Bye-bye.
Bye.